Hello and welcome to Windows PowerShell Scripting. I'm super excited about these videos. Now, admittedly, I've had a lot of people tell me that they're intimidated by PowerShell. Believe me, I get it. I think that the intimidation factor stems from the fact that many PowerShell scripts resemble hieroglyphics. The reason why some PowerShell code is so hard to decipher is because of the use of aliases. In the world of PowerShell, aliases are shortcuts. By using aliases, it's possible to replace commands with a few letters. Using aliases can be a time saver, but it makes the scripts very difficult to read, so I'm going to be staying away from that sort of thing, except for in a few special cases, and in those cases I'll explain exactly what I'm doing. The vast majority of my code will be written in long form, which will make it much easier to read and hopefully much easier for you to follow. Remember, my goal is to teach you how to do some really fun and useful things with PowerShell, not to dazzle you with my use of obscure code and shortcuts. My plan is to take my time and explain everything and present the information in a way that will help you to learn PowerShell with minimal effort. So with that said, let's take a look at the overall lesson plan. Lesson 1 is essentially an introduction to PowerShell. It's intended primarily for those who are just getting started with PowerShell. Lesson 2 focuses on PowerShell Basics. This is where I introduce you to fundamental concepts such as variables, objects, and attributes. I also spend some time talking about what to do if you receive an error message that you don't understand. Lesson 3 is where I begin to talk more about scripting, and then I cover advanced scripting techniques in Lesson 4 and Lesson 5. PowerShell isn't just a programming language, it's also a management tool, and that's what Lessons 6 and 7 are all about. Lesson 6 covers using PowerShell to manage Active Directory, and Lesson 7 explains how to use PowerShell to manage a remote system. Lessons 8 and 9 are about using PowerShell to create various types of reports. I start out by showing you how to create text-based reports, and then I show you how to create HTML reports and even graphical charts. Even though PowerShell is a text-based command line environment, it's possible to create GUI-based applications using PowerShell and Microsoft.NET. In Lesson 10, I'll show you how to build such an application. Finally, I'm going to wrap things up in Lesson 11 by talking about some of the new capabilities that are included in PowerShell 7. As you can see, I'm going to cover a huge amount of material in this course. Even so, I've tried to create these videos in a way that will make the material fun and easy to learn. So if you're ready to get started, I'll see you in Lesson 1. Lesson 1 is all about getting started with PowerShell. I explained what PowerShell is, what it does, how you use it, and what you can do if things don't work quite the way that you expect. The videos in this lesson cover what is PowerShell, the Windows command line interfaces, the basic PowerShell syntax, getting help, predicting a command's behavior, and dealing with a term not recognized error. Hello, greetings, and welcome. Thank you so much for watching my course on Windows PowerShell, which you can see PowerShell on the screen right now. You know, PowerShell is one of those things that has a reputation for being super complicated. And indeed, PowerShell can be complicated. So one of my goals for this course is to make PowerShell easy to understand. And I want to do that without dumbing down PowerShell and leaving out important things that you need to know. So it's a tall order for sure, but I'm going to try to construct this course in a way that will provide you with lots of helpful and real-world type information, but at the same time, make that information easy to understand with lots of hands-on examples. So that's my plan for the course. So the first thing that I want to talk about is what is PowerShell? Now that seems like such a simple question, especially being that PowerShell has been around since the days of Windows Server 2008, so well over 10 years. But the question of what PowerShell is surprisingly difficult to answer. Some people define PowerShell as a management tool for Windows. And while that definition is accurate, it's also completely inadequate, because PowerShell can be used to manage a lot more than just Windows. You can use PowerShell to manage Linux. You can use PowerShell to manage other Microsoft Server products besides Windows. You can use PowerShell to manage cloud platforms like Microsoft Azure and even the Amazon Web Services. So PowerShell is indeed a management tool, but it can be used to manage a lot more than just Windows. Now, I mentioned a moment ago that PowerShell is tough to define. And if we could just say PowerShell is a management tool, then that's not really all that difficult to define. The flip side to PowerShell is that it also acts as a programming language. In fact, some people refer to PowerShell as a programming language. That tends to be more the side that I think of PowerShell in, and certainly I'm going to show you how to write numerous PowerShell scripts throughout this course, but just know that PowerShell is both a management tool and a programming environment. So this leads to the next big question. Why PowerShell? Why do we need it? Well, there are actually several different reasons. And in order to fully explain those reasons, I need to give you a bit of a history lesson going way back all the way to the dawn of the PC. So let me go ahead and minimize this PowerShell window, and I want to show you something. What you see here is a Hyper-V virtual machine running Microsoft DOS, or MS-DOS. Now, before I get into what DOS is and why I'm showing this to you, I just want to take a step back really quickly. And this is a bit beyond the scope of the course, but I want to throw something in that I hadn't planned on talking about just because I think you might find it helpful. Let me go ahead and close this out. Now, I mentioned a second ago that DOS was running inside of a Hyper-V virtual machine. Hyper-V is a Microsoft virtualization platform. It runs on Windows Server, and it also runs on professional editions of Windows desktop operating systems like Windows 11 and Windows 10. Now, right now, I'm using Windows Server 2022, and if you want to install Hyper-V, what you would do is click on the Start button, open up Server Manager, and yes, you can install Hyper-V through PowerShell too, but being that I haven't really talked all that much about PowerShell yet, we're just going to use the GUI for right now. And then once you're inside of Server Manager, what you would do is go up to Manage, and then click on Add Roles and Features, and this is going to bring up the Add Roles and Features wizard. And what you would do is click on Next and set the installation type to role-based or feature-based installation. Click Next again. Select your server, which in this case there's only one, so click Next. And then you're asked to choose a server role. And you can see that there's a role called Hyper-V and it's installed. So you would select this role, click Next a few more times, and then Hyper-V would be installed. And then there's a management tool for Hyper-V called the Hyper-V Manager. I'll show you that in a few minutes. But the reason why I wanted to go ahead and show you how to install Hyper-V is because if you want to experiment with some of the techniques that I'm going to be showing you throughout this course, the safest way to do that is to set up a virtual machine and experiment with PowerShell inside of that Hyper-V virtual machine. So that way you're not putting your primary desktop operating system at risk. So with that said, let's go back to that virtual machine that I was going to show you a moment ago. So this is a virtual machine running Microsoft DOS, or MS-DOS as it's often referred to. And I wish I could make this a little bit larger for you, but DOS is a very ancient operating system, and screen resolutions were very limited at the time that it was created. So this is the best that we can do. Now, DOS was a very primitive operating system for the PC. And I'm not sure what year it was created, but I can recall using DOS way back in the 80s, and it may have even existed before then, I'm not sure. DOS is spelled DOS, and DOS stands for Disk Operating System. So DOS really was a command line driven operating system, and it was extremely lightweight. As a matter of fact, the core DOS kernel that you needed to boot from consisted solely of 3 files: msdos.sys, io.sys, and command.com. And if you had those 3 files on a disk, that disk was bootable. Incidentally, 2 of those 3 files were hidden by default. So the primary purpose of DOS, or the disk operating system, was to allow you to manage the disk. Now you'll notice that right now this DOS window is pointing to the R drive. And the reason for that is that I booted this particular virtual machine off of a CD that I created with DOS on it. It's a weird configuration for sure. I'm probably the only person to ever do something like that. Now, the main thing that I wanted to show you in this DOS window is that DOS is indeed a disk operating system. If I were to type C:, which switches to the C drive, and press enter, I'm going to get an error. And the reason is because this is a brand new virtual machine and it's never been provisioned. Now, in a DOS environment, what you had to do is you had to use a command called fdisk. And what fdisk would do is it would make the system aware of the hard disk. So you can see right here that I get a message saying that this is a large disk, and because it's larger than 512 megabytes, so bigger than half a gigabyte was considered large back then. And it asks if I want to enable large disk support. I'm going to choose yes. And then it asks me what I want to do next. I'm going to go ahead and create a DOS partition or a logical DOS drive. I'll press 1. And then I'm going to press 1 again to create a primary DOS partition. And so now DOS is verifying the drive integrity, and it's creating a partition structure. And then I'm asked if I want to use the maximum available size for the primary DOS partition and make the partition active. I'm going to say yes. And then I receive a message saying that I have to restart my system. So I'm going to go ahead and press Escape to exit fdisk, and then I will restart this virtual machine. And the menu that you see right here isn't really a part of DOS. This is just something that I set up so that I could access DOS from a CD. So now that DOS is booted, we can begin to format the C drive. And the way that we do that is with the format command. And then I'm going to append /s. And what that's going to do is it tells DOS to copy the operating system to the C drive and make the C drive bootable. Now we're asked to enter a volume label. I'm just going to press enter to leave the volume label blank. And the disk has been formatted. So at this point, I can turn off the virtual machine. I'm going to eject the CD. And then when I click start, I should be able to boot off of this virtual machine's hard disk. And you can see we booted straight into DOS, and we're now on the C drive, so the C drive is accessible to us. And there are any number of different DOS commands that you can use. For example, if you wanted to see what was on the C drive, you could type dir, and that gives you a directory. Remember those three files I mentioned earlier, command-com, iosys, and ms-dossys. iosys and ms-dossys are hidden, command-com is visible. We can do other things as well. If, for example, we wanted to create a folder, we could type md, that stands for make directory, and then the name of the folder that we want to create. I'll create one called temp. And then I can type dir, and you can see that I've created the temp folder. If I wanted to access that folder, I could type cd for change directory, and then the name of the folder. And I can even copy files. If, for example, I wanted to copy the command-com file to the temp folder, I could say copy c:/command-com. And then the file has been copied, and if I type dir, you can see that that file now exists in the temp folder. Now, obviously, a lot of this isn't the sort of thing that you're going to use today, or even in this course for that matter, because this course is about PowerShell. What I really wanted to illustrate is that PowerShell has its roots in DOS. And as a matter of fact, everything that I just showed you, you can do inside of PowerShell. It's not the preferred way of doing things, but it does work. And one of the big things that I wanted to accomplish in this video is to show you why those commands still work today and what the rationale is behind using PowerShell. So with that said, what I want to do is go ahead and shut down this virtual machine. And I'm going to close this out. And I'm going to open up something called DOSBox. Now, DOSBox is a DOS emulator, and it's something that you can download for free. The only reason I'm using DOSBox as opposed to my DOS virtual machine is because I wanted to open up an old version of Windows, and I can't really do that in the virtual machine that I created. So the thing that you need to understand from a historical perspective is that DOS is older than Windows. Windows did not exist at the time that DOS was created. So at that time, all applications were DOS applications. You would insert a floppy disk and then enter a command to launch the application. There was no point and click back then. Now, eventually, Microsoft created Windows. And when they did, Windows was actually an application that ran on top of DOS. If I type dir, you can see that there's a folder for Windows. I'll go ahead and use the cd command and go into Windows. If I type dir again, you can see all of the operating system files that make up the Windows operating system. And I can launch Windows by typing win. So here you see Windows 3.1. Now the important thing to keep in mind here is that once Microsoft created Windows, some of the different software vendors ended up creating Windows applications. These were applications that were designed to run inside of Windows. At the same time, though, most of the applications that were out there and already in use were DOS applications. Now, Microsoft didn't want Windows users to have to leave Windows in order to run a DOS application. So you'll notice that we have an MS-DOS prompt that's accessible within Windows. So you could click on that prompt and that would open up a DOS window so that you could run your DOS applications inside of Windows. So I'll go ahead and close this out. So as you saw, Windows back then ran on top of DOS, and you could access a DOS environment from within Windows, which was more of a convenience feature. Yes, you could run your DOS applications directly from DOS, but you could also run them in Windows so that way you could run your DOS and your Windows applications side by side. Now, eventually, Microsoft changed things. In the mid-90s, Microsoft created an operating system called Windows NT, and Windows NT completely did away with the DOS environment. It booted into something called the NT kernel. Now, the NT kernel is still in use today. It's the basis for operating systems such as Windows XP, Windows 10, Windows 11, and all of the Windows Server applications. So even this Windows Server 2022 operating system that you're looking at right now is running on top of the NT kernel. Yes, the NT kernel has been adapted since the early 90s. It's not the same NT kernel that we had back then, but it still has a lot of similarities. Now, the problem that Microsoft ran into is that when they created Windows NT, there were still a lot of people out there using DOS applications, and they needed to continue to use those DOS applications inside of Windows NT. So Microsoft couldn't just open up a DOS window inside of Windows NT. So what they did was they created an emulated DOS environment, and we still have that today in the way of the Windows command prompt. If I were to right-click on the Start button and go to Run and type CMD, that's going to open up the Windows command prompt environment, and you can see that this looks very, very similar to DOS. So where does PowerShell fit into all of this? Well, DOS really served two purposes. One, it was the disk operating system. It allowed you to perform low-level operations on the disk like what I showed you a moment ago. You could initialize a disk with the fdisk command, you could format a disk, you could create and delete folders, you could copy files, you could do all of those disk-related activities within MS-DOS. But DOS was also a true operating system. You could run applications on top of that. So Microsoft couldn't completely do away with DOS. They left fragments of the DOS operating system in modern operating systems, just as you see here. Now, where PowerShell came into play is that Microsoft began realizing that DOS is ancient, and that they needed a more grown-up version of DOS, if you will, that was more capable, and that's PowerShell. So PowerShell isn't a true operating system in that you would run applications on top of it. You can certainly run PowerShell scripts, and there are certain applications that you can launch from a PowerShell environment. You'll see examples of all of that throughout this course. But PowerShell is a management environment. You can use it not only to perform disk operations, but to control virtually anything related to Windows. And it's also a scripting environment. You can use it to write management scripts. You can even build custom applications, all from within PowerShell. But there's one more thing that PowerShell gives us. Now, I've mentioned several times that PowerShell is a management interface. And you might be wondering why in the world you would use PowerShell when you can just point and click your way through the Windows GUI interface. Well, the reason for that is that PowerShell gives us something that the GUI doesn't: scalability. You can actually use PowerShell to simultaneously manage large numbers of Windows systems. PowerShell is also useful in situations where no GUI is installed. Let me show you what I mean. I'm going to go ahead and close out these windows. And earlier I mentioned that I was going to show you the interface that's used to manage Hyper-V virtual machines. So I'm going to go ahead and open that up now. What I'm going to do is click on the Start button, and I'm going to go to Server Manager. And when Server Manager opens, the next thing that I'm going to do is click on Tools, and I'm going to go to the Hyper-V Manager. As you can see, there's one virtual machine installed on this particular Hyper-V server, and it's currently off. So what I'm going to do is double-click on the virtual machine, and this is going to open up the virtual machine console. And I'll go ahead and click Start, and that launches the virtual machine. So right now, this virtual machine is booting off of a Windows Server 2022 boot disk, and it's going to go directly into Windows Setup. So now that we're in Windows Setup, I'm going to click Next. I'll click Install Now. I'm not going to worry about entering a product key, so I'm going to click on I don't have a product key. And then I'm taken to the screen that asks you to select the operating system that you want to install. This is what I really wanted to show you. Now, typically, if you're installing Windows Server, you would choose the desktop experience. And what that gives you is the full GUI environment like what you've seen so far with this virtual machine. But you can also install Windows Server without a GUI. All you have to do is choose Windows Server 2022 Standard or Windows Server 2022 Data Center. And what that's going to do is provide you with a Windows Server installation with no graphical interface. All you really have is PowerShell. So at that point, if you want to manage that machine, you have a choice. You can either install the GUI tools elsewhere and use those tools to manage the virtual machine remotely, or you can manage the virtual machine with PowerShell. So that's a big part of where PowerShell comes into play. So the purpose of this video is just to talk about what PowerShell is, how it relates to what we had in the past with DOS, and why PowerShell is important. I'm going to get into a lot more of the how to use PowerShell in some of the videos that are coming up. In the next video, what I want to do is I want to show you some of the tools that exist for using PowerShell. I want to talk about some more of the differences between the Windows command prompt and the PowerShell environment. And I also want to show you some of the different tools that exist for writing PowerShell code. So we'll get into all of that in the next video. So before I get too far into this course and start dealing with the actual PowerShell commandlets and all of the hands-on stuff, I wanted to make a short video and show you some of the tools that are available for interacting with PowerShell. So right now I'm logged on to a Windows Server 2022 server, and the server is running a default configuration. The only thing that I've changed is the screen resolution and some of the font sizes, just to make things a little bit easier to see. So what I'm going to do is click on the Start button. And right here we have a PowerShell icon. Now remember what I said, this is a default configuration. So this is where the icon normally exists, straight out of the box. And if you want to launch PowerShell, you can do so simply by clicking on this icon. And that's all you have to do to launch PowerShell. Now, having said that, the technique that I just showed you is sometimes inadequate. Let me go ahead and close this out and I'll show you why. If you think back to the previous video, you'll recall that I said that PowerShell could be used as a programming language or as a management tool. Now, if you're doing a lot of Windows management, typically you're going to need elevated permissions. For example, you might need administrative permissions to do a particular task. Now, just being logged on as an administrator isn't necessarily going to be good enough. What you actually have to do in those types of situations where you have to do something that requires administrative privileges is to open an administrative PowerShell session. So let's take a look at what that looks like. I'm going to go ahead and click on Start again. And this time, rather than clicking on the PowerShell icon, I'm going to right-click on the icon. And this is going to open up a submenu. Now you'll notice that we have a command right here for Run as Administrator. So if you want to open up an administrative PowerShell session, this is what you would do. Now, if you're running an older version of Windows Server, this option may not exist. And if that's the case, then the way that you would open up an administrative PowerShell window is to go to More, and then just choose Run as Administrator. I'll go ahead and click on that now. And now I've opened up an administrative PowerShell session. If you look at the title of the window, you can see it says Administrator Windows PowerShell. And the word administrator on the window title indicates that this is indeed an administrative PowerShell session. So this is the main PowerShell console, and this is the console that I'm going to be using almost exclusively throughout this course to run scripts and to do other sorts of PowerShell things. Having said that, this isn't the only tool that's available to you. Let me go ahead and close this out. And I want to show you another tool. I'm going to go ahead and click on the Start button. And when I do, you can see that we have an option for Windows PowerShell ISE. It's located right here. And again, you can open an administrative session by right-clicking and going to More and choosing the Run as Administrator command. But I'm just going to go ahead and open up Windows PowerShell ISE. So this is Windows PowerShell ISE. ISE stands for Integrated Scripting Environment or something to that effect. And as you can see, the window is divided into 3 sections. Now, the top section on the left is tabbed. You can see that the name of the tab is untitled.ps1. ps1 is the file extension that's given to PowerShell scripts. Now, I don't want to get into this too much in this video because I'm going to be covering scripts extensively as we go throughout this course, but just know that ps1 is the extension that's used for PowerShell scripts. And this number 1 right here, this isn't really part of a script. This just indicates line number 1. This tool tries to make it a little bit easier to work with large scripts by placing a number in front of each line. So if, for example, you were to start typing some code right here and then press enter, you would see that the number 2 would appear on the next line. And then if I pressed enter to create a few more lines, we have some additional numbers. Now the section just below that is a PowerShell window. So this is a live PowerShell window, exactly like what you saw in the previous example where I just opened up PowerShell. The only difference is that this window is built into the PowerShell ISE console. And then off to the right, we have a listing of all of the commandlets that PowerShell knows about. And for any one of these, you can get help. So let me just show you what this looks like. I'm going to click on one at random. I'll click on Add Computer. And when I do that, we can see the name of the commandlet, in this case, add-computer. We can see the module that the commandlet exists in. And if you don't know what a module is, don't worry about it. I'm going to be covering modules extensively later on in the course. Just know that you can get module information right here, so that might be something to put in the back of your mind. And then we can get a little bit more information about the commandlet right here. We can even click on Show Details. And we get this screen that allows us to populate the various parameters that go along with that commandlet. And if we want to insert the commandlet, we can simply click Insert. And we can see Add Computer added to the command line, so we didn't even have to type it. Now let me go ahead and backspace over this. And I want to show you another trick. When we type a commandlet within the PowerShell ISE console, then PowerShell is going to try to help us out as we go. Because quite frankly, some of the commands are a little bit long and convoluted and they can be difficult to remember. So PowerShell will try to use autocomplete to help you out a little bit. Let me show you what this looks like. I'm going to type the get VM command. That's the commandlet that retrieves a list of the Hyper-V virtual machines. I'm just going to type get-vm, and you can see already PowerShell is popping up help. We get a list of the commands that start with get, and there are a large number of those commands. If I scroll through here, you can see just how many commands there are that begin with get. So I'll type v, and now the list is narrowed down a little bit. We have commandlets like get variable, get verb, get VHD set, and so on and so forth. I'll go ahead and type m, and now I'm taken to the get VM commandlet. And if I press enter, of course, that commandlet will be executed. And we can see that this particular server has one virtual machine, and that virtual machine is currently turned off. Now, the integrated help works the same way in the upper portion where we can author scripts. If, for example, I were to type get-vm, you can see that immediately we have not just the command, but we have the full command syntax that's displayed for us. For example, there's a parameter called name. And if I go on and use the name parameter, I type dash, and now I have a list of all of the parameters that I can enter. I can type name, or I can just click on it. And then I could follow that up with the virtual machine name. The point being that this console tries to give you as much help as it possibly can. Now, having said that, I'm really not going to be using Windows PowerShell ISE very much throughout this course. I may end up delving into it a couple of times as we go along, but for the most part, I'm going to stick to the raw PowerShell terminal that you saw a moment ago. That is this terminal right here. And the reason is just a matter of personal preference. I like that the interface is a little bit cleaner, and you can fit a little bit more on the screen simply because you don't have all of the command help. So this raises an interesting question. If PowerShell ISE is specifically designed to help you build scripts, and I'm not going to be using it that much, what am I going to be using to build scripts? Well, the truth of the matter is you can author PowerShell scripts in any text editor. And I'm going to be using Notepad for the most part to create my PowerShell scripts. So you'll see what that looks like as we go along in some of the later videos. For right now, I'm going to go ahead and close this out. And it asks me if I want to save. I'm going to say no. And I'm taken back to Windows. Now there's one more tool that I want to show you. And unfortunately, this tool isn't a part of Windows Server. But if you have Windows 11, this is something that you can use. So let me switch over to Windows 11. So here I am in Windows 11, and Microsoft created a brand new tool in Windows 11 called Windows Terminal. What I'm going to do is click on the Start button, and I'm just going to start typing the word terminal. And you can see that already we have the best match, Windows Terminal, and that's an application. I'll go ahead and launch this. And on the surface, the Windows Terminal looks a lot like a PowerShell window, and indeed we are running PowerShell. But the interesting thing about the terminal is that it's tabbed. So I could have simultaneous PowerShell sessions open simply by creating additional tabs. And in case you're wondering, these tabs are completely independent of one another. If, for example, I were to define a variable within one tab, that variable is not going to be valid in the next tab. So each tab is an independent session that's not aware of anything going on in any of the other tabs. Now, there are a couple of additional tricks that I wanted to show you with the Windows Terminal. For one thing, Microsoft makes it really easy to keep track of what you're doing in each individual tab. If I go ahead and right-click on a tab, you can see that we have a few different options. I can rename the tab, so I could assign each tab a different name to make it easier to keep track of what I'm working on in each tab. And we can even color code the tabs. So if I wanted to pick a different color for a tab, we could easily do that. Now, there is one other thing that I wanted to show you about this tool, and that is that it isn't limited solely to working with PowerShell. You'll notice that right next to the new tab icon, we have a drop-down. And if I click on this drop-down, we have a few choices. PowerShell is the default. That's why PowerShell opens whenever I click the new tab icon, but we can also open a command prompt. And additionally, there's an option to open the Azure Cloud Shell. And of course, there are any number of different settings that you can use to customize the terminal. So that's just a quick look at this tool. I wanted to show you that, being that Windows 11 is brand new at the time that I'm recording this video, just in case you weren't aware of the existence of this tool. Because I'm guessing that a lot of you who are watching this are going to want to try out some of the techniques that I'm showing you. And a Windows 11 virtual machine is probably going to be a little easier to come by than a Windows Server virtual machine. So with that said, let's go ahead and close this video out, and I'll see you in the next one. Hello and welcome back. One of the main keys to being able to use PowerShell effectively is to understand the command structure. Now, PowerShell commands are based on something known as a cmdlet. A cmdlet is spelled Cmdlet. It's kind of a weird word, but for whatever reason, this is what Microsoft chose to call PowerShell commands. And in all honesty, I constantly catch myself calling them commands rather than commandlets. Just know that the word cmdlet is the official name for a PowerShell command. Now, as I mentioned a moment ago, the key to being able to really use PowerShell effectively is to understand the cmdlet structure. PowerShell commandlets are made up of verb-noun combinations. You have a verb, a dash, and then a noun. That's what pretty much every commandlet that I can think of looks like. So what do I mean by verb-noun? Well, verbs are action words. We use verbs every single day. Verbs are things like run, jump, sit, drink, eat, and the list goes on and on. Nouns, on the other hand, can be a person, a place, or a thing, at least as far as the English language goes, not so much with PowerShell. But nouns are objects, things like chair, desk, car, computer, and the list goes on and on and on. So, with regard to PowerShell, PowerShell commandlets are made up of a verb, so an action word, a dash, and then a noun. So we tell PowerShell what action we want to take, and then we tell PowerShell what object we want to take that action on. So let me give you a really simple example. The Windows operating system uses a number of system services. So let's suppose that we wanted to see a list of those system services. Well, remember what I said. PowerShell commandlets are based on a combination of a verb and a noun. So if we're trying to see a list of system services, the verb that we would use is get, and then we need a dash because PowerShell commandlets separate the verb and the noun with a dash. And since we're trying to get a list of services, the noun that we'll use is service. So I'll go ahead and type service. And if I press enter, I get a list of system services. So I used a verb, a dash, and a noun. And as I mentioned before, That's the way that almost all PowerShell commandlets are structured. Now, the interesting thing is, even though there are thousands and thousands of PowerShell commandlets, far too many to learn them all, Microsoft tends to make extensive use out of certain verbs and certain nouns. So let me give you an example. I used the word get in front of service to tell PowerShell that I wanted to retrieve a list of services. But get doesn't just work with service. It works with countless other nouns. So if, for example, I wanted to get a list of processes instead of a list of services, I could reuse the get verb. So I'll type get dash process. And now I get a list of the processes that are running on this system. So as you can see, the word get is a verb, and it can be used with any number of different commandlets. Similarly, the very first commandlet that I demonstrated in this video was get service. Service is a noun, and that noun service can be used in a number of different commandlets as well. So we have get service, but we also have things like stop service and start service, and there are a few others. So if, for example, I wanted to take a look at a specific service, maybe the volume shadow copy service, I could type get-service VSS, because that's the service name, and I see that the volume shadow copy service is running. So then maybe I want to stop the service. I would type stop-service VSS, and stop is a verb, service being a noun. So once again, we've got an example of a PowerShell commandlet that's made up of a verb-noun combination. So if I press enter, I get no visible output, but if I type get-service VSS, I can see that that service is now stopped. So as I mentioned, PowerShell commandlets are made up of a verb, a dash, and a noun, and a lot of those verbs and nouns get reused in multiple commandlets. So this raises the question of how do you know what commandlets the different verbs and nouns work with? And how do you know which verbs and nouns are available to you? Well, there are a few different ways that you can learn what commandlets are available to you. PowerShell has a command called getCommand. And what you can do is you can actually use the getCommand commandlet to find out what commandlets support various verbs and nouns. Let me show you a couple of examples. I mentioned a moment ago that there were a huge number of commandlets that work with the get verb. So what I could do is I could type get-command. So getCommand is actually one of those commandlets that makes use of get. And then what I can do is I can type get-asterisk. So this tells the getCommand commandlet that I want to see a list of all of the PowerShell commandlets in the current module that start with the get verb. So I'll press enter, and you can see that there's a huge number of results, but every commandlet that was just displayed uses the get verb. So Microsoft does indeed make extensive use of get. And you can also use the getCommand commandlet to take a look at how various nouns are used. So if, for example, I wanted to find out what PowerShell commandlets support the service noun, I could type getCommand *service. The asterisk is a wildcard character in PowerShell. So this tells PowerShell that I want to see all of the commands that start with absolutely anything and end with -service. And you can see that we have roughly about a dozen PowerShell commandlets that make use of the service noun. So we can use the getCommand commandlet to find out what verbs and what nouns we can use as we work with PowerShell. So if, for example, I happen to notice as I'm looking at this list that we have a verb resume, and we wanted to know what all PowerShell commandlets support the use of resume, I can find that out too. I could type get-command resume -*, and I can see that there are only about 5 commandlets that make use of the resume verb. So as I explained at the very beginning of this video, the key to working effectively in PowerShell is to understand the command syntax. Now, I've shown you how to figure out what types of commandlets you can use with PowerShell, but there's a little bit more to using PowerShell than just knowing what commandlets to use. You also have to know the syntax that's supported by those commands. And the good news is that there is help available. So if you want to know how to use a particular commandlet, then the way that you would do that is by typing get-help. And once again, get-help is a PowerShell commandlet, and you can see that it begins with the get verb and ends with the help noun. So we have get-help
and then the commandlet that you want to take a look at. So if, for example, I wanted to get help on the get-service commandlet, I would type get-service, and I'll press enter, and then PowerShell displays the full command syntax. So we see that we're looking at the get-service commandlet, and then down beneath that, we see all of the various parameters that work with the get-service commandlet. Now, admittedly, sometimes this syntax can be a little bit tough to follow, especially for commandlets that support a lot of parameters. So for example, get-service supports a number of parameters, the first one being name. I showed you a moment ago how we could provide the name of a specific service if we wanted to take a look at just that service. But then we also have computer name, which is used if you want to take a look at a service that's running on a remote machine. And then we have other parameters such as dependent services and required services, and there are several others. So what if we didn't quite know what all of these parameters meant and we wanted to get some additional help? Well, in a situation like that, the best thing that I could recommend is to go online and take a look at the Microsoft website, because Microsoft maintains a website for every single PowerShell commandlet, and they provide exactly the same information that you see on screen right now. But the one thing that the website has that you don't get from using Get Help is that the website provides examples of how to use the command. So let's take a look at what that looks like. I'll go ahead and open up my browser. And let's take a look at the get service commandlet. So I'll go to Google and I'll type PowerShell get-service. And so here's the Microsoft documentation for the get service commandlet. So you can see the syntax, and this looks very similar to what you just saw. And then we have a description. And then if I scroll down to the bottom, there are numerous examples of how you can use the commandlet. And you don't even necessarily have to memorize these and then go and transcribe them into PowerShell. You can actually click on copy. For example, I can click copy right here, and that will copy the command from the example to the Windows clipboard. And then you can switch over to PowerShell and press Control-V, and it will type what you just copied to the clipboard. And then if you press enter, Windows will execute that particular example. So that's just a quick introduction of the basic syntax that PowerShell uses. Hello and welcome back. In this video, I want to talk about some places that you can go if you need to get help with PowerShell commandlets. Now, I already showed you a couple of different methods that you could use to get help in the last video, but there's one more method that I want to show you. Now, just to kind of reiterate what I covered in the last video, one of the things that you can do if you need help with a particular PowerShell commandlet is to just type get help. If I just type get help and I press enter, then I get some basic information about PowerShell. It's not super helpful, but it may be enough to get you started. Now, if on the other hand you need help with a particular PowerShell commandlet, you can type get help, followed by the name of the commandlet that you want to get help with. If, for example, I wanted to get help with the get service commandlet, I would type get help, get service, and PowerShell would display the syntax that's associated with the commandlet that you typed. Now, another method that I talked about in the previous video is that Microsoft maintains a web page with documentation for every single PowerShell commandlet. So what you can do is go out on the web and then just search for the commandlet that you're interested in. In this case, I've got the get service commandlet on the screen, and you can see that this page of documentation displays the commandlet syntax, but it also displays examples of how to use the commandlet. And this is something that's super helpful, and a page like this exists for every single PowerShell commandlet. So if, for example, I were to look up the get process commandlet, you can see that the documentation page for the get process commandlet looks identical to that of the get service commandlet. So Microsoft uses a really uniform format when providing PowerShell documentation. And once again, we have some examples of how to use the commandlet down at the bottom. So these examples can be tremendously beneficial if you're just getting started and you want to know how some of these commandlets work. Now, as I mentioned at the very beginning of this video, there's one more place that you can go for help that I want to be sure to show you. So let me go ahead and close out my browser, and I want to open up PowerShell ISE. I'm not going to be using PowerShell ISE very much in this course, but if you're just starting out and you need help with some of the commandlets, this is a great place to go. So let me just go ahead and drop down to the root folder and clear the screen just to reduce a bit of the clutter. Now, let's suppose that I'm working in PowerShell and I know that I need to use a particular commandlet, but I'm not quite sure about the syntax of that commandlet. Maybe I want to retrieve information about the VSS service that's running on the machine. That's the volume shadow copy service. I think that get-service might be the right commandlet to use, but I'm not completely sure of the syntax or anything like that. Well, one of the things that we could do is we could use this interface on the right side of the screen to look up the commandlet. And you can see that every commandlet in the entire module is listed on the right side of the screen. And we could actually type a name of a commandlet right here in the name box. So I could type get, and PowerShell ISE immediately begins filtering the list based on what you've typed here. So I could continue and type dash and then service, and we see get-service. And if I click on that, then I'm shown a bit more detail. There's a show details button that I can click on to get even more information. Now, the same basic thing also works over here. Watch what happens as I type get-service. I'll type get-service, and as I type, PowerShell begins suggesting commandlets for me to use. I'll go ahead and type service. And so now what about the syntax after typing the initial command? Well, I mentioned a moment ago that maybe I wanted to retrieve information about the VSS service. And typically when you're retrieving information through a PowerShell commandlet, that's going to be done through a parameter. And parameters always start with a dash. But maybe I don't know that I can just type the name of the service without having to specify a parameter name. So I just type a dash, and all of a sudden PowerShell ISE begins suggesting parameter names. Well, here's a parameter name called name. So this is the service name. So you can see that the parameter name is called name, and you can also see that this is going to be a string value. So if I type name, then PowerShell knows that I need to follow this up with a string, and it begins suggesting other parameters that I might also want to use. I'll just go ahead and type VSS, and you can see that VSS is actually a valid entry. I'll go ahead and press enter, and here's the VSS service. So PowerShell ISE gave me help every step of the way as I was formulating this command. So that's just one of the ways that you can get help if you need a little bit of extra assistance when you're getting started with PowerShell. So far in this lesson, I've spent quite a bit of time talking about how you can figure out what command you want to use in a given situation. But one of the things that I found as I was learning PowerShell is that there's a big difference between knowing what command to use and knowing what that command is going to do when you do use it. And this is an important consideration because one of the things about PowerShell is that not only can it do anything that you can do through the Windows GUI, in many cases it can actually do more. There is certain functionality that you can access through PowerShell that you can't access through the GUI. So all this is to say that if you misuse PowerShell, it can be harmful to your system. You can do damage. Now, I don't say that as a way of scaring you away from using PowerShell. Certainly you shouldn't be afraid of it, but you do need to give PowerShell a healthy dose of respect and to at least know what the consequences are going to be of your actions if you're running those actions on a production system. Now, just on a side note, everything that I'm doing in this course is being done in a lab environment. Just thought I would mention that. So this brings up the question of how can you tell what a command is going to do if you're not super familiar with that command? I mean, I couldn't even tell you how many times I've gone out and looked something up on the internet and found the command to use, but it's a command that I've never used before, so I'm not 100% sure how it's going to behave. What do you do in a situation like that? Well, PowerShell actually does give you a little bit of help. There are a couple of commands that you can use to help predict the output of a command that you're about to run, so you can get a feel for what that command is going to do for you. Now, before I show you how this works, I need to point out that what I'm about to show you doesn't work for every possible PowerShell command. As a matter of fact, there's a relatively small subset of commandlets that these techniques can be used for. Even so, this technique is definitely worthwhile, so I wanted to take a moment and show you how this works. So before I get into all of that, let me talk a little bit about the get-service commandlet, in case I haven't already discussed it. Now, the Windows operating system makes use of a number of system services. These services perform low-level tasks that are critical to the core operating system. And as a matter of fact, Windows has a component called the Service Control Manager that lists all of those services. Let me show you what that looks like. You can access the Service Control Manager by right-clicking on the Start button and going to Run and typing services.msc and clicking OK. And that opens up the Service Control Manager. So you can see that there are a number of services that make up the Windows operating system. And for each one of those services, you can see the service name, you can see a description of the service, you can see the service status, which is basically whether or not the service is running. You can see the startup type and how the service is logging on, which the logon affects the service's permissions. Now, one of the things that I wanted to point out about the screen is that not every service is running, and that's totally normal. Services that have a startup type of automatic, like what you see here, are configured to run automatically, whereas a service that has a startup type of manual has to be manually started, and a service that has a startup type of disabled doesn't run at all, unless that service happens to get enabled later on and then manually started. So it's totally normal for some services to be running and some services not to be running. And the reason why I mention that is because I want to demonstrate the ability to predict what a command's behavior is going to be, but I want to do it in a safe way so that way, if you want to try this for yourself, you can do it without putting your system in jeopardy. And the get-service command, which allows you to interact with all of these services, is one of the commandlets that supports what I'm about to show you. But at the same time, as I mentioned, most of these services are critical to the Windows operating system, so it's not the sort of thing that we want to be messing with. After all, if you go and shut down a critical service, it could cause the Windows operating system to come to a grinding halt, and we don't want that. So I want to pick a service that is safe for us to mess with. And the service that I'm going to use is VSS. And VSS is the Volume Shadow Copy service. What that service does is it controls the backup process. And because I'm not running a backup right now, it doesn't matter if we start and stop the VSS service or the Volume Shadow Copy service as it's listed right here. So let's take a look at how this works. I'm going to go ahead and close out the Service Control Manager and switch back over to PowerShell. And if you type get-service, you'll get a list of all of the services, just like what the Service Control Manager shows you. Let me go ahead and do that. If I press enter, you should see those services. So here's the list of services. And if I scroll up to the top, you can see that there is some column headers for each one of these. And we have the service status, the service name, and the service display name. So let me go ahead and scroll back down. And right here is our VSS service. That's the Volume Shadow Copy service. And you can see that right now the service is running. So let's say that we wanted to stop that service. The way that we would normally do that in PowerShell is just by typing stop-service followed by the service name. So if I wanted to stop the VSS service, I would type stop-service VSS and press enter, and that would stop the service. So now if I type get-service VSS, we can see that that service has indeed stopped. I'm going to go ahead and restart the service, and I'll do that by typing start-service VSS. And we'll confirm that the service started, and it is running. So that's how you stop and start a service. Now, let's pretend for a moment that I want to stop the VSS service, and I'm pretty sure that the stop-service VSS command is the right command to use to stop that service. But let's also pretend that I'm brand new to PowerShell, and I'm not entirely comfortable with running this because I'm not 100% sure what's going to happen when I do. Well, in situations like that, there are a couple of things that you can do to get a better feel for what's going to happen. One option is to use a parameter called whatIf. So let me go ahead and retype the stop service commandlet. So here we have stop-service VSS, and I'm just going to append -whatif to the end of this. So what this does is this tells Windows that I want to know what would happen if I ran stop-service VSS. It doesn't actually run the command, it just tells me what would happen if I did run the command. So I'll go ahead and press enter, and we see what if. So right here it says what if, and this is an indication that we haven't actually run the command. Windows is just telling us what would happen if we had run the command. So we see performing the operation stop service on target volume shadow copy service. So we can tell that if we ran this command, then what would happen is we would attempt to stop the volume shadow copy service. So you can see that when we use what if, it doesn't mimic the command's output, because when I ran stop service VSS, there was no output. Instead, it just gives us a clue of what's going to happen when we run that particular command. Now, there is also another option that we can do, and that is -confirm. Let me show you what that looks like. I'm going to repeat the same command, but I'm going to get rid of what if, and I'm going to type confirm. I'll go ahead and press enter, and this time I see a confirmation, and it says, "Are you sure you want to perform this action?" And then I get a line of descriptive text that says, "Performing the operation stop service on target volume shadow copy VSS." So it's telling me what's about to happen. And then it's giving me a choice. Do I want to perform this action or don't I? So I could press Y for yes, which is the default, by the way. If I just press enter, then it's going to go ahead and process the operation. I can also type A for yes to all, N for no, L for no to all, S for suspend, or question mark for help. So I have some options here. So if I were to just go ahead and press enter, or if I were to type Y, then the command would actually execute. So this is different from what if, because what if doesn't actually execute the command. Confirm does execute the command, but only after you've given permission for the command to execute. So if I type get service VSS, we can see that the service has actually stopped. I'm going to go ahead and restart it. And the service has started back up. So I mentioned earlier that not every PowerShell commandlet supports the use of what if and confirm. So this raises the question of how do you know which commands these parameters work with? Well, it's a little bit tricky to find out, but let's take a look at how this works. One of the PowerShell commands that you need to be familiar with is get-command. And what that does is that returns a list of all of the commands that PowerShell supports. So let me just go ahead and type get-command and you can see what it does. And when I press enter, I get a list of every PowerShell commandlet that PowerShell currently knows about. So that's what the get commandlet does. We can also run the get commandlet on an individual command. So for example, I could type get-command start service. And that would give me information about the start service commandlet. I can see the commandlet version, and I can see which module that commandlet exists within. So that's what the get commandlet does. So how does this help us with knowing which commandlets we can use with what if and with confirm? Get command knows more about these commandlets than what is displayed here. If I were to type get-command start service, and then the pipe symbol. And what the pipe symbol does is it takes the output from one command and it funnels it into another. So everything that you see just above what I'm typing, the command type, the name, the version, the source, all of that gets funneled into another command. And the command that I'm funneling that into is select object. And I'm following that up with an asterisk. An asterisk means we want to see everything. So what this is going to do is it's going to show me everything that get command knows about the start service commandlet. And you can see that there's quite a bit. So if I scroll up just a little bit, one of the things that you'll notice is that there is a definition attribute. And the definition attribute shows what all parameters we can use with this particular commandlet. And we can see that start-service supports what if, and it also supports confirm. So the way that we find out which commandlets support what if and confirm is to run a filter against the get command commandlet. And we set that filter up so that it looks for instances of what if or confirm. So how do we do that? Well, let me go ahead and clear the screen. And I'm going to type get command. And this time I'm not going to specify an individual command because I want to look at the entire list of commandlets. I'm going to use the pipe symbol. So I'm going to funnel that entire list of commandlets into another command. And that command is where-object. Where-object is a filter. So we need to provide PowerShell with some filtering criteria. In other words, we've retrieved this great big long list of commandlets, and we're applying a filter to that list of commandlets to narrow it down, but we have to tell PowerShell what we want to filter by. How do we want to narrow down the list of commandlets? So the way that we provide a filter is by typing the bracket key and then $_dot definition. So $_dot is something that you'll see pretty often in PowerShell. It's a special purpose variable. In this case, what we're telling PowerShell is that, okay, we've got all of this information provided by get command. We only want to look at the definition attribute. And that definition attribute is the same one that I showed you just a few moments ago. So we're looking at the definition. Now we have to know, what are we going to do with that definition? Well, I want to filter if the definition is -like, and then quotation marks, asterisk, which asterisk is a wildcard. It means anything. What if, asterisk, and quotation marks. And then I need a closing bracket. So why the asterisks? As you saw a moment ago, what if wasn't the only parameter that the start service commandlet supported. There were other parameters that were also supported. So by appending a asterisk at the beginning and the end of what if, that basically tells PowerShell to ignore anything that comes before what if and anything that comes after what if. If what if appears anywhere in the definition, then that's a result that we want to see. So hopefully I haven't made any typos. I'll go ahead and press enter. And what we get is a list of commandlets that support what if. And you'll notice that right here we have our stop service commandlet. And if I go up just a little bit, we also have start service. So both of those commandlets support what if, as do all of these other commandlets. Now you'll probably notice that the list that was returned, even though it's fairly long, it's a lot shorter than that list that we had of every conceivable PowerShell commandlet. And incidentally, this list is a lot longer than it used to be. Back when I recorded the original version of this course, it was a very short list of commandlets that supported what if. So what if we wanted to know which commandlets supported confirm? Well, let's go ahead and take a look at that. Let me clear the screen. And what I'm going to do is type the exact same command. Actually, before I do that, let me backtrack a little bit. And I'm going to type one of the commands that I typed earlier. Get command start-service pipe symbol select object asterisk. And what that does is shows all the parameters that work with the start-service command. Now, I mentioned earlier that we put an asterisk in front of and behind what if so that it would ignore everything else in the definition and focus solely on what if. So here's the definition attribute right here. And you'll notice that what if comes right in the middle. So by putting an asterisk in front of and behind what if, it essentially tells PowerShell to ignore all of this and to ignore all of this and just focus on what if. So that way, it doesn't matter where what if appears within that definition. If it shows up anywhere at all, then PowerShell will grab onto that. So hopefully that will clear things up just a little bit. So I'm going to go ahead and clear the screen. And let's go ahead and look at which commands support confirm. To do that, I'm going to use exactly the same command as before, get-command, pipe symbol, where-object, $_dot definition, like, And then I'm just going to change what if to confirm. And incidentally, like just means that we're looking for definitions that include the word confirm. This isn't the only comparative operator that PowerShell supports. There are quite a few others. For example, we could use -eq for equals, or ne for not equal to, and there are many others. But the reason why I'm using like is because the definition contains the word confirm and it contains the word what if, but that doesn't make up the whole definition. If I simply set this to equal, then we wouldn't get any results because the definition doesn't equal confirm or doesn't equal what if. There are other elements to the definition. So if I press enter, we see all of the PowerShell commandlets that support the word confirm. And incidentally, just for fun, I'm going to repeat that command, but I'm going to change like to equal. And press enter, and you can see that we don't get any results. And the reason for that is that the definition isn't literally asterisk confirm asterisk. It contains the word confirm, but there's more to it than just the word confirm. So using equal isn't an option. What we want to be using instead is like. So if I set this back to like, then we get a list of all of the PowerShell commandlets that support the confirm parameter. And once again, you can see that we have things like stop service and start service. So that's how you determine which PowerShell commandlets support what if and confirm. Hello and welcome back. In this video, I want to spend a little bit of time talking about the term not recognized error in PowerShell. And the reason for this is that this is by far the most common error that you're going to encounter in PowerShell. As a matter of fact, a couple of times a week, I get email messages from people asking me what this particular error means. So I've got another video later in the course where I talk about a number of other error types, but because the term not recognized error is so common, I wanted to give it special attention in this video. So let's go ahead and get started. So what is a term not recognized error? Well, a term not recognized error essentially just means that PowerShell doesn't understand the command that you've just typed in. Generally, it stems from a spelling mistake or from using a command that doesn't exist. So there have always been error messages like this. It's just that those error messages were previously known as other things. Back in the days of DOS and some of the earlier versions of Windows, the error message that you would get is bad command or file name. If I were to open up the Windows command prompt and I were to type something invalid, I get the command that I just typed is not recognized as an internal or external command, operable program, or batch file. So this is roughly analogous to the term not recognized error that you get in PowerShell. So with that said, let me go ahead and close out the command prompt window and let's take a look at what this error looks like. So I'm just going to hit a bunch of random keys because certainly that big string of letters that I just typed isn't a valid PowerShell command. So if I press enter, I get the string of letters that I just typed, followed by a message that says the term, those letters again, is not recognized as the name of a commandlet, function, script file, or operable program. Check the spelling of the name, or if a path was included, verify that the path is correct and try again. So in other words, this just means that I made a spelling error. I entered something that PowerShell doesn't recognize as a valid name of a commandlet. So what happens if you get this in real life? I mean, here I just hit a bunch of random characters on my keyboard, so of course it's going to cause an error. But let's take a look at a more realistic situation. Let me go ahead and clear the screen. And I'm going to type get-process. Now the get-process commandlet retrieves a list of all of the system processes that are running in Windows. If I press enter, you can see those processes. So that's what the command is supposed to do. But let's go ahead and intentionally misspell process just so that you can see what happens. Maybe I think that instead of get-process, it's get-processes. So I'll add an ES to the end and press enter, and I get the term not recognized error that you saw a moment ago. So how do we fix this? Well, the very first thing that I would recommend doing if you get a term not recognized error is just go back and check your spelling. But if the spelling appears to be correct, then the next logical step is to find out if you're using the right commandlet. As a matter of fact, I'm not recording all of these videos in order. I've already recorded some videos from later on in the course. And in a couple of those videos, there were instances where I got in a little bit too big of a hurry and I thought a commandlet was just a little bit different than it was, like maybe I added an S to the end or something like that and got this very error. So you're going to see some real life examples of that. But just for the sake of discussion, let's pretend for a moment that I thought that this command was get processes, not get process. And I got this error and I don't know what to do about it because everything seems to be spelled correctly and I'm not sure where to go from here. What do you do? Well, the very first thing that I would recommend doing in a situation like this is using get command. Because if you stop and think about PowerShell, the vast majority of the commands in PowerShell, or commandlets as Microsoft likes to call them, are made up of verb-noun combinations. So in this case, get is a verb, process is a noun, and those get jammed together and separated by a hyphen. Now, in the case of get processes, which isn't a valid command, we have get, which we know is valid because get is used with about a billion other commands. Not literally a billion, but a lot of other commands. And then we have processes, which may or may not be right. So what I would suggest doing is using get command. I'll go ahead and type that. Now, if I just press enter right now, then what you're going to get is a great big long list of every commandlet that PowerShell knows about. And you can see it's quite a list. As a matter of fact, this list is so long that, well, okay, it went ahead and finished, so I don't have to break out of it. So that's what get command does if you run it by itself. But what you can do is you can use get command on a command fragment. So in the case of get processes, we know the get portion of the command is valid because there are so many other commands that are based on get. So we could type get-command followed by get-asterisk. And what this is going to do is it's going to show every PowerShell commandlet that starts with get. So ideally, we would be able to take a look at this list and pick out the command that we're looking for from that list. But unfortunately, it's not really practical in this case because there are so many results. As you saw, there are a huge number of commands that start with get. So what else can we do? Well, what we're trying to do is retrieve a list of processes. So the next logical step might be to type get-p, because processes starts with p, followed by an asterisk, and see what that gets us. I need to type get command followed by get-p asterisk. And I'm guessing that this is going to return a great big long list of PowerShell commands, probably more than we care to sift through. So we got quite a few. You might still be able to go through this list and find what you need. I mean, get process is actually right here. But let's pretend that more commands were returned than what we really have. What we could do is continue chipping away at this. Rather than get-p asterisk, we could try get-pr asterisk. So we would only see commandlets that start with get-pr something. And if I press enter, then we only get about a dozen commandlets returned, and it becomes really easy at that point to find the one that we're interested in. So here's get-process. So now we know the commandlet that we want to use. We know that it's not get-processes, but rather get-process. And if we needed a little bit of extra help with this, maybe we weren't quite sure that this is the command that we wanted to use, you could always type get-help followed by get-process. And then that would give you the command syntax. And hopefully by doing that, you could figure out if this is the command that you're trying to use or not. So those are just a few quick pointers on dealing with a term not recognized error in PowerShell.
In Lesson 2, I teach you some of the more important concepts that you'll need to know for basic day-to-day PowerShell use. The videos in this lesson aren't just useful for basic Windows Server management, they also lay the groundwork for creating PowerShell scripts. In this lesson, I cover commonly used commandlets, objects and attributes, working with variables, arrays, and hash tables, an introduction to modules, making sense of error messages, and creating your own custom error message.
Hello and welcome back. In this video, I wanted to show you just a few really commonly used PowerShell commandlets. And this is going to be probably one of the shortest videos in the entire course because I don't want to spend too much time talking about specific commandlets. I would rather show you other techniques that you can use to kind of figure out which commandlet you need to use in a given situation. But I do want to show you some of the commandlets that I'm going to be using over and over throughout this course. And you've already seen some of these. For example, in the last video, I showed you the get-service commandlet. And the get-service commandlet is used to retrieve a list of system services off of the machine. You can see what that looks like right here. Another commandlet that you're going to see me using over and over throughout this course is get-process. And the get-process commandlet retrieves a list of the processes that are running on the machine. And that commandlet is just get-process. So there you can see the processes. And the reason why I tend to use these two commandlets a lot is just because they're simple commandlets, they return visible information, and they're easy to work with, so they make for a good demonstration. So throughout this course, I'm going to be teaching you a lot of PowerShell techniques, and I like to keep things as simple as I possibly can so that I can focus on the technique rather than focusing so much on the specific commands. So you'll find that there's a few commandlets that I just use over and over again throughout this course, and that's the reason why. Now, another commandlet that I'm going to be using quite a bit is select object, and this is one of those commandlets that you're going to use constantly in the real world. Select-object is used to narrow down the list of what's displayed, or to force PowerShell to show things that it wouldn't otherwise show. So let me show you what I mean. I'm going to type get-service, and I'm going to type one specific service, VSS. And we could really use any service for this, it doesn't matter. VSS is just good for demonstration. So right there you can see the VSS service. And we have three columns of information. We have status, we have name, and we have display name. So what the select object commandlet does is it allows you to tell PowerShell exactly what you want to see in the output. So let's suppose for a moment that I wanted to see the service's display name and I wanted to see its status in that order, which is different from the order that's on the screen right now. And I wasn't so much worried about the name. Well, what I could do is I could type get-service, VSS, and then the pipe symbol, which in PowerShell, anytime that you see the pipe symbol, what you're doing is you're taking the output from one command and you're using that output as input to the next command. So I'm taking the output from get-service VSS, which is everything you see on screen right now, and I'm piping that into select-object, display name, comma, status. I'll press enter, and now I see the service's display name and its status. So I eliminated one column of information and I changed the order of the way that the information was displayed. Now there are other options with select-object, because typically any get command that you use in PowerShell is going to return a lot more information than what's actually shown on screen. So let me show you what I mean. If I just type get-service VSS, PowerShell returns three pieces of information: status, name, and display name. But there's actually a lot more that's hidden. So if I type get-service VSS, pipe symbol, select object, and then asterisk, and the asterisk tells PowerShell that we want to see everything related to this service. I'll press enter, and you can see that there are many more fields. And we can use any of these fields in the select object command. So maybe I want to type get-service, VSS, pipe symbol, select object, and then pick a few of these off of the list. Maybe display name, comma, we'll go with can stop, comma, and start type. And I'll press enter and PowerShell returns those pieces of information. So I'm going to have some other videos that go into this concept in a lot more depth. My purpose for right now is just to talk about some of the commands that I'm going to be using pretty often throughout this course. Now, another command that you'll probably see me using a lot is CLS, and that's clear screen. And in case you're wondering why CLS doesn't adhere to the PowerShell commandlet structure, CLS is a leftover from the days of DOS. So I typed CLS, I pressed enter, screen cleared. Another PowerShell commandlet that I'll probably be using a lot is get-child item. I'll type get-child item and press enter, and you can see that what we're seeing is the contents of the C drive. So get-child item is the PowerShell equivalent to the old dir command. And incidentally, dir still works. If I type dir and press enter, we see the exact same output. Another PowerShell command that's left over from the days of DOS is cd for change directory. So if I wanted to take a look at the contents of the data folder, I could type cd space data, and PowerShell changes to that folder. Then I could type get-child item and see what's in the data folder. Then if I wanted to drop back down to the root folder, I could type cd backslash and press enter, and now I'm at the root folder. Another commandlet that you might find useful is md. md is for make directory. So if I wanted to create a folder called data2, I could type md data2 and press enter. And now if I type get-child item, you can see that the data2 folder has been created. So one more thing I want to show you, I'll go to cd data, and I'll type get-child item. And I want to copy the 7-4.htm file to the data2 folder that I just created. So what I can do is I can type copy -item, and then I'll go ahead and use the full path, c:/data /7-4.htm, and I'll copy that to c:/data2 and press enter. And we don't get any visible output, but if I were to go cd backslash to drop down to the root directory, and then type cd data2, and then type get-child item, you can see that that file has been copied. And if for whatever reason I wanted to erase this file, I could type remove item 7-4.htm. And then if I type get-child item, we can see that that particular item is gone. So those are just a few of the commonly used PowerShell commandlets. We'll be using these commandlets and plenty of others extensively throughout the remainder of this course. Hello and welcome back. This is going to be one of the most important lessons in this entire video course. In this video, I'm going to be talking about objects and attributes as they relate to PowerShell. Now, what do I mean by objects and attributes? Well, we have examples of objects and attributes in the physical world that we all look at every single day without even stopping to think about it. Consider for a moment the cars that are driving down the street right now. Those cars are all basically the same. They all have 4 wheels, a steering wheel, a driver's seat, and that sort of thing. But there are certain attributes that apply to each car that make one car different from another. For example, some of the cars are different colors. They might have a different number of doors. There are 2-door cars and 4-door cars, and maybe even some with some additional doors. Cars can also differ in terms of how many seats they have. I once had a convertible that had 2 seats, whereas a large SUV might have 3 rows of seats. Also, what size engine does the car have? Does it have a small fuel-efficient engine? Does it have a large engine? Is the car gas or is it electric? These are all examples of attributes that apply to the object, which is a car. And of course, cars aren't exactly the only example of an object that has attributes. Consider sports, for example. There are a number of different sports that are played with balls. And yet, even though all of the balls are round, the balls differ from one sport to another. They differ with regard to color. For example, A pool ball and a bowling ball might be black and shiny, whereas a tennis ball might be green and fuzzy. A basketball might be orange and have a rough texture. So the color and the texture are examples of attributes. Likewise, the balls can differ in terms of size. The size is another attribute. A golf ball, for example, is really small, whereas a basketball is much larger. Golf balls and basketballs also have completely different textures. So the color, the texture, the size, those are all examples of attributes that apply to the balls that are used in various sporting events. So the point is that in the physical world, we have objects, things like cars and balls and countless other types of objects, and each one of those objects has certain attributes that are associated with it. Things like colors and sizes and textures, and any number of other attributes. Well, in the world of Windows, we have the exact same thing. We have objects, and those objects have attributes. Consider, for example, a user account. That user account might be regarded as an object, and it has a number of attributes that are associated with it. I'm talking about things like the user's first name and last name and password. Similarly, virtual machines are objects, and virtual machines have attributes associated with them. The amount of memory that's assigned to a virtual machine, for example, might be an attribute. The number of virtual CPUs that are assigned to that virtual machine might be another attribute. The virtual machine's name can even be considered an attribute. So we have all of these objects that exist within Windows, and all of those objects have attributes. And those attributes are accessible to us through PowerShell. Now, in this video, I'm primarily going to be addressing those attributes from the standpoint of just accessing them and showing you what's available. But one thing that I want you to keep in mind as we go along is that a lot of the attributes aren't read-only. You can actually make modifications to them through PowerShell, assuming that you have the necessary permissions and assuming that Windows allows you to do so, which in a lot of cases it does. So let's take a look at an example of an object and an attribute in Windows. I'm going to go ahead and minimize PowerShell for a moment. And what I want to do is open up the Task Manager. So I'm just going to right-click on the Start button and go to Run and type taskmgr. And that launches Task Manager. I'll make this a little bigger. Now, right now, Task Manager is empty, but I can click on More Details, and we get a completely different view. And right now, what we're looking at is the Processes view. Now, in Windows, every thread of execution, in other words, everything that's running, is tied to a process. And you can see that those processes fall into various categories. So we have some processes that are tied to apps, things like Task Manager, Windows Explorer, and PowerShell, aptly enough. We also have background processes. And if I scroll down, there are even some processes that are tied to the Windows operating system. And each one of these processes has certain attributes associated with it. We have things like the amount of CPU resources that the process is consuming, and we have attributes such as the amount of memory that a particular process is consuming. So these are attributes of the process. Now, the reason why I wanted to show you this list of processes is to illustrate the idea that oftentimes in Windows, there's more going on than what meets the eye. The GUI doesn't always show you everything that's available to you. Oftentimes, there are things that are only available by going into some of the advanced options within the GUI, and there may even be options beyond that that are only accessible through PowerShell. And that's especially true when it comes to objects and attributes. So let me show you what I'm talking about. Right now, you can see that we have 4 columns that exist for each process. We have the name column, the status column, the CPU column, and the memory column. But there are actually a lot more attributes to processes than just these 4. Let me right-click on the top of one of these columns, and this is going to bring up a menu. And you can see that we have about a dozen different things that we can select, and this will expose additional attributes. So if, for example, I wanted to expose the process name, I would simply select process name, and now we have another column. And this column essentially just shows us the executable file that runs in association with that process. We can also expose the process ID. Just right-click and choose PID, and now we have a PID column that shows us the process ID. So the point being that there's more information in here than what is shown by default. And you can get to some of that information through the GUI. But you can actually do a lot more through PowerShell. So let me go ahead and switch over to PowerShell. And what I'm going to do is I'm going to type get-process. That's the PowerShell commandlet that retrieves a list of processes that are running on the system. So let's take a look at what that looks like. And we have a bit more information than will comfortably fit on the screen. So let me kind of scroll up to the top a little bit. And what you can see is that there are any number of different columns containing information. So if I switch back to the task manager, our current view right now has 1, 2, 3, 4, 5, 6 columns exposed. And then PowerShell is giving us 1, 2, 3, 4, 5, 6, 7, 8 columns of information. Now, I know what you're thinking. You can expand the task manager to show some additional information. And you're absolutely right, you can. But there is a limit to the types of attributes that can be exposed through the task manager. You can actually see more information through PowerShell, though. So let me show you how to access that. I'm going to scroll down to the prompt, and what I'm going to do is type get process again. And incidentally, there is a trick in PowerShell. If you want to repeat your previous command, all you have to do is press the up key on your keyboard, and that will repeat that command. And you can actually cycle through previous commands by pressing the up key repeatedly. And if you need to backtrack, you can press the down key. So that's just a quick shortcut to reduce the amount of typing that you have to do. At any rate, what I'm going to do is I'm going to type get process, but then what I'm going to do is append the pipe symbol. And the pipe symbol is the vertical line that appears on the key with the backslash. That's the key that's just above the enter key on most keyboards. And what the pipe symbol does is it takes the output from one command and it channels that output into another command. And you're going to see a number of examples of that as we go along throughout this course. So what I'm going to do is I'm going to type get-process and have the pipe symbol, and then I'm going to follow this up with another command. And the commandlet that I'm going to use is select-object. Now I'm going to show you a number of examples of select object as we go along throughout this video, but what select object does is it allows you to control what exactly you want to look at. If I scroll back up, you'll notice that every single one of these columns has a column header. We have things like handles, ID, SI, process name. So we could type the select object commandlet followed by the name of one of these particular types of information to see just that particular piece of information. So let's suppose that we wanted to only look at the process name and the process ID. We could do that using select object. We would type select object, and then we would follow that with the appropriate names for process name and ID. And then that would narrow down the information that's presented so that we only see that process name and ID and everything else is hidden. And we'll get to some examples of that in just a little bit. For right now, though, what I want to do is follow the select object command with an asterisk. And what the asterisk does is it tells PowerShell that we want to see everything that's available. So I'll go ahead and press enter. And what we end up with is a huge list of all of the processes and their attributes. And admittedly, that's a lot to take in. So that being the case, now it looks like it's not quite done yet. And you can see how much information there truly is. And we're just now getting to the end of that list. So there's a huge amount of information that's available for all of those processes. So what I want to do is narrow that down because I want to show you the attributes that are available just for a single process rather than throwing this entire list at you. So let me switch back to the task manager and we'll pick out a single process. We'll use the Windows PowerShell process. So the first thing that we have to find if we want to look at that process is the name. So I'm just going to go back to the get process command that we used a moment ago. And this lists all of the processes on the machine. So we should have a process here that corresponds to PowerShell. So let's take a look at what we've got. So here's the PowerShell process right here, and you can see that it's simply called PowerShell. So what I'm going to do is I'll go ahead and clear the screen to make this easier to read. And I use the CLS command to do that. And what I'm going to do is type get process. And this time I'm going to append the name of a specific process. So I'm just going to type PowerShell. and I'll press enter. And then what we see is the information related to the PowerShell process as opposed to the information for every process on the entire machine. So I mentioned a moment ago that I wanted to show you the attributes that exist for a single process. So I'm going to repeat the same command that I just typed, get process PowerShell, and then I'm going to append the pipe symbol. And then I'm going to type select-object. And then I'm going to type an asterisk. So what we're going to see in this output is all of the attributes that exist for this one single process. And there's a lot. Now, there's no need to go into all of these because, as you can see, there is indeed a lot of attributes that exist. The point that I wanted to make is that when we were looking at the task manager, we initially had 1, 2, 3, 4, 5, 6 columns, and we even added a few of those. And even if we were to turn all of these on, we have maybe a dozen columns worth of information that are exposed through the GUI. In PowerShell, on the other hand, there are probably 100 or more pieces of information that exist for each process. So PowerShell exposes a wealth of information in the form of object attributes that you can access on an as-needed basis. Generally speaking, you have access to way more information through PowerShell than you have through the GUI. Now, one of the interesting things about this is that you can filter this information to make it easier to digest. So let's suppose for a moment that you wanted to look at a few specific pieces of information related to processes that are running on the machine. For the sake of example, let's look at the process name and let's check to see if the process is responding. So we have an attribute called process name. You can see it right here. And then we also have an attribute called responding, which you can see right here. So if we only wanted to look at those two attributes, then what we would do is we would type get process, followed by the pipe symbol, select object, and then the name of any attributes that we want to include. So since we're looking at the process name and whether or not the process is responding, we could type process name, comma, and responding. And I'll press enter. And what we end up with is a list of all of our processes, and we can see whether or not each one is responding. And of course, we could do the same thing for an individual process if we wanted to. All we would have to do is repeat that same command, and this time just enter the name of the process that we want to look at. I'll look at PowerShell, and press enter, and we can see that information for that one specific process. Now, I chose to use getProcess to illustrate the point that there are all of these attributes that exist for a particular object, but the concept of attributes and objects is by no means limited to processes. Let's take a look at a couple of other examples. I'm going to open up the Task Manager, and I'm going to click on Services. Now, the Services tab lists all of the system services that are running on the machine, and you can see that we have a name for each service. Some services have a process ID. There's generally a description. We can see the service status, and we can see what group that the service belongs to. And incidentally, Windows has something called the Service Control Manager where you can access this information from a dedicated console. You can get to it by right-clicking on the Start button, going to Run, and typing services.msc. And that will bring up the Service Control Manager. And as you can see, it displays roughly the same information that you see through the Task Manager. But I'm going to go ahead and close this out. And what I'm going to do is type get services. So get-services, or excuse me, get service rather, not get services. And when I type get service, what I end up with is the same type of information that was presented within the Service Control Manager. So for each one of these services, you can see the service status, the service name, and the service display name. And the same concepts that I showed you a moment ago can be used with the get service command just as they could with the get process command. So let's take a look at one specific service. We'll look at the AWS service. Right now the service is stopped, but we'll go ahead and use it anyway. So what I'm going to do is type get service and then ADWS, which was the service name, and I'll press enter, and we see the information just for that service. And then once again, if I type that command, and then I append a pipe symbol, and then select dash object, followed by an asterisk, I can see all of the attributes that exist for that service. So the point that I wanted to make by showing you this is that if you just type get-service followed by the service name, PowerShell will initially show you the service status, the service name, and the service display name. But there's a lot more information that you can access if you know what you're looking for. So up here, we had 3 attributes that were shown, whereas down here, we've probably got 15 or 20 attributes. And then once again, we can look at specific attributes if we want to. So let's suppose that we wanted to see the service name, the service status, and the service type. Well, we can simply use the attribute names that are listed right here, and then we just type get-service, pipe symbol, select object, name, comma, status, because status is the name of one of the attributes, and then service type, which is also an attribute name. You can see it right here. And you'll notice that I'm separating each attribute with a comma. So I'll go ahead and press enter, and you can see those columns that I requested being displayed. Now, one thing that I want to quickly mention before I move on is that you can actually control the way that this information is displayed. What you're looking at right now is what's called a table view of the information. If I were to repeat this command and then append a pipe symbol and type format-table and press enter, you would see that the output looks exactly like what we just saw. On the other hand, I could switch this information into list view. And the way that I would do that is by repeating the command and changing the format-table commandlet to format-list. And now the same information is being presented, but it's being presented in list view rather than table view. Now, throughout this course, I'm going to be typing commands in long form, just as you've seen me do all along. But there are some shortcuts that you can take to some of these commands. And I'm not a big fan of shortcuts because I think that the code is a lot easier to read if you don't take shortcuts. The shortcuts for format table and format list are very, very commonly used, so you're likely to run into this in the real world. I want to show you what those shortcuts are. The shortcut for format list is just FL. And if I press enter, you can see that the output is the same as what you just saw. Similarly, the shortcut for format table is FT. And if I press enter, you can see the information formatted as a table. So now that I've shown you various ways of looking at the attributes that are available for a particular object, I want to move on to one more thing. I'll go ahead and clear the screen. And I want to take a look at a Hyper-V virtual machine. Now, if you're not familiar with Hyper-V, it's something I'm going to be dealing with quite a bit in this course. It's the Windows virtualization platform. It allows you to create virtual machines, and those virtual machines behave just like physical machines, except they share resources on your computer, such as CPU time, memory, and each virtual machine acts as an independent entity. So it's totally separate from your main operating system and from any other virtual machines that you might create. So let's take a look at how to access Hyper-V virtual machines. And incidentally, what I'm about to show you will only work if you've got Hyper-V installed somewhere. So the command that's used to retrieve a list of Hyper-V virtual machines is get-vm. Now, if you've got a specific virtual machine that you want to look at, you can include the virtual machine name here, just as we were able to look at a specific process by typing its name or a specific service by typing its name. I'm not going to worry about that right now. What I'm going to do is just use the get-vm command by itself to get a list of all of the virtual machines that exist on my Hyper-V server. Now, because my Hyper-V server is remote, I have to append -computer name. Followed by the name of my Hyper-V server, which just happens to be called Hyper-V. And when I press enter, we should get a list of the virtual machines. Now, the thing that I wanted to point out is that each one of these virtual machines have attributes associated with them. So we have attributes such as the virtual machine name, the virtual machine state, the CPU usage, the memory assigned, the uptime, the status, the version. And as you probably already guessed, there are a lot more attributes that exist than what are shown here by default. So let's take a look at some of those attributes. So what I'm going to do is repeat the same command that I just used, but I'm going to enter a virtual machine name. And I'm going to go with VM1. And if I press enter, you'll see output that is identical to this, except we're only going to be seeing a single virtual machine instead of all of the virtual machines. So now that I've done that, let's take a look at all of the available attributes for that virtual machine. And as I'm sure you've already guessed, the way that we do that is by repeating the command, appending a pipe symbol, followed by select-object, and then an asterisk. I'll press enter, and you can see that there are a lot of attributes that are available for that virtual machine. So why am I showing you all of this? Well, the reason is because sometimes there are attributes that are a little bit tougher to access than just the basic set of attributes that we've been looking at so far. There is an extra step involved in some cases. So why is that? Well, let me scroll up just a little bit. And one of the things that you're probably going to notice is that some of these attributes are listed in exactly the same way that you've already seen. For example, we have dynamic memory enabled, and then that's set to false. We have memory maximum, and then we have a value. Memory minimum, another value. Processor count, 4. So those are all attributes that we can access directly. But we have other attributes that are enclosed in brackets. And when I say a bracket, I'm talking about this character right here. So we have a pair of brackets here. If you look at hard drives, you can see that there is information, but that information is enclosed in brackets. So let's take a look at what would happen if we try to access the hard drive's attribute directly. Now, when we look at the name of a virtual machine, PowerShell uses VM name, not just name. So we're going to use that in the next command that I'm going to show you. So I'm going to repeat the same command that we just typed, but rather than typing select object asterisk, I'm going to select the object VM name, comma, hard drives, and press enter. And so what we ended up with is the virtual machine name, and then we have the hard drive information, but the hard drive information is still enclosed in brackets. Now on the surface, this appears as though this is the only information that's available with regard to the virtual machine's hard drives. In reality, though, there's more going on here than meets the eye. Because what's happening is that the hard drive has attributes too. Virtual machines generally use virtual hard drives, and a virtual hard drive is just a file that acts as a hard drive for the virtual machine. So what are these attributes? Well, the file name is one attribute, certainly. Also, the file size, where the file is located at, the controller number, the location, whether it's on an IDE or a SCSI controller. So there are all these attributes that apply to the virtual hard drive. So whenever we see information that's enclosed in brackets like this, again, here's a bracket and here's a bracket. Whenever we see information that's enclosed in brackets, that means that there are some additional attributes that are available. So how do we access those attributes? Well, what we have to do is we have to use a parameter called expand property, and that goes along with select object. So let's take a look at how that works. I'm going to repeat the same command that I used a moment ago, but this time what I'm going to do is I'm just going to look at hard drives. I'm not going to worry about the VM name. So we're selecting object hard drives, but what I want to do is I want to expand the property. So I'll type -expand property. And then I'll press enter. And so what I get now is a list of some of the properties related to the virtual hard disk. So we're still looking at VM1. You can see that right here by my mouse pointer, but you can see the controller type, the controller number, the controller location, and the path. And as you probably guessed, there are some additional parameters available. And the way that we access those parameters is by using a second occurrence of the select object commandlet. So I'll go ahead and press the up arrow, and then I'm going to add a pipe symbol to the end of this command. And then I'm going to type select object, followed by asterisk. So what we're going to see is all of the attributes that are related to this hard drive. And there are quite a few of them. And just as we've been doing all along, we can pick and choose attributes. So for example, if instead of showing all of the attributes, I wanted to look at the name and maybe the ID, I could do that. And you can see that I end up with columns for name and ID. So my main purpose in this video is just to show you how to access objects and attributes in PowerShell. And there's a lot more that you can do. I'm just barely scratching the surface. As I mentioned earlier, a lot of attributes can be modified. I wasn't really going to get into that in this video, but I'll just give you a really quick example of that. Earlier we looked at services. I'll type get-service. And you'll notice that the very last service on the list, Windows Update, is stopped. If I wanted to start that, then all I would have to do is type start -service, and then the service name, WA USERV, and press enter. And then if I do get service again, we see that that service is now running. So you can use PowerShell to modify a lot of these attributes. The attributes that you've seen aren't necessarily read-only. Another thing that I want to quickly mention is that there are any number of filtering techniques that you can use as well to access specific information. For example, it is possible to create a filter that will only show us the services that are running. We won't see any of the stopped services. Or we can just look at the services that are stopped and not look at the running services. And I'm going to be showing you how to do that later on in one of the other videos. But for right now, I think we've covered enough for this video, so I'll see you in the next one. Hello and welcome back. In this video, I want to show you how to work with variables, arrays, and hash tables in PowerShell. So let's go ahead and get started. Now, a variable, as I'm sure you know, is a letter or a word that is assigned a value, and that value can change on an as-needed basis. If the value didn't change, it would be called a constant. But variables can be subject to change. Now, in PowerShell, when you're going to declare a variable, there are a few rules that you want to adhere to. The first rule is that variable names always start with a $sign. So anytime that you see a $sign in PowerShell followed by a letter or a word, that's an indication that you're looking at a variable. Next, when you're assigning a variable, the variable name is followed by an equal sign. And then whatever comes after that equal sign is what you're assigning to the variable. So let's take a look at an example. I'm going to create a variable called $A. I'll just type $A, and then I'll set that equal to, and let's give this a numeric value. I'm going to use 1, so I'll type quotation marks, 1, quotation marks. And incidentally, pay attention to the quotation marks because this is actually something important when it comes to variable assignments, and it's something that I'm going to talk more about a little bit later on. For right now, the thing that you need to keep in mind is that I did use quotation marks when I did this variable assignment. So I'm going to go ahead and press enter. And when I do that, there's no visible output, but that's okay. That's the way that PowerShell is designed to work. What we can do if we're not sure if anything happened or not is we can tell PowerShell to display the contents of the variable that we just assigned. And there are a couple of different ways that we can do that. One way is to just type the variable name and press enter. So if I type $A and then I press enter, I get a value of 1 back. So I'm displaying the contents of the $A variable, and that variable is set to 1. So that's one way that you can display the contents of a variable. Another way is to use a write host statement. I could do something like this. And if I press enter, then I get a value of 1. Now, incidentally, I can't remember if I've talked about this or not, but the write host commandlet is the commandlet that PowerShell uses to display text on the screen. So let me give you an example. If I wanted to display the words hello, I could simply type write-host hello. And you'll notice that the text that is to be displayed on screen is enclosed in quotation marks. Apostrophes also work. You'll see that sometimes as well. So I'll go ahead and press enter, and you see the word hello appear on the screen. So that's how the write host command works. So I've shown you that you can use write host to output the contents of a variable. You can also use write host to display literal text, in this case the word hello. But you can also mix match these. So let's suppose that I wanted to use write host to display some text along with the contents of a variable. We can do that very, very easily. Let me give you an example. I'll type write host, and then I'll type the value of the a variable is $A. And you'll notice the $A is in green, whereas the literal text that's going to be displayed on the screen is in blue, indicating that PowerShell recognizes $A as being the name of a variable. So if I press enter right now, I get output that says the value of the a variable is 1. So we can use the write host command to display the contents of a variable. We can use it to display literal text, or we can use it to display a combination of text and the contents of a variable. So what else can we do with variables? Well, another thing that we can do is mathematical operations. We can add, subtract, multiply, divide, and do other types of things with variables. And that's actually something that's very common when you start getting into PowerShell scripting. So let's take a look at how this works. I'm going to clear the screen just to reduce some of the clutter, and I'll do that by using the CLS command. And we've still got a variable called $A. And you can see that $A is still set to 1. Now, let's declare another variable. I'm going to call this $B, and I'll set that equal to 1 as well. So if I type $B, we can see that $B is set to 1. And incidentally, the variable assignments that I'm making, you can use exactly the same technique to change the value of a variable. If, for example, I wanted to change B to 2, I could type $B equals 2. And if I type $B, B is now 2. I'll go ahead and change the $B variable back to 1. So you can see that $B is now 1. So I mentioned a moment ago that you can perform mathematical operations on variables. So let's take a look at an example of that. Now in PowerShell, you don't necessarily have to use variables if you're going to do math. You can just type numbers and then operators, and PowerShell will evaluate the expression. For example, if I just wanted to add 1 plus 1, I could type 1 plus 1 and press enter, and I get a result of 2. And incidentally, there's an entire video later on in this course on doing math with PowerShell. So I'm not really going to get into the math too deeply in this video. My real purpose is just to show you how variables work. So with that said, I've got a variable called $A that's set to 1. I've got another variable called $B that's set to 1. Let's go ahead and add those together. And the way that I'm going to do that is by typing $A and then plus and $B. So what do you think we're going to get when we press enter? Well, remember, $A is set to 1, $B is set to 1. I'll go ahead and press enter. And as a result, we get 11, not 2. So when we evaluated 1 plus 1, we got a result of 2. But when we added $A to $B, we got a result of 11. So what in the world is going on here? Well, remember back toward the beginning of this video, I told you to pay attention to the quotation marks in the variable assignment. When I assign $A, I set that equal to quotation mark 1 quotation mark. And I did the same thing with $B. You can still see it on the screen. As a matter of fact, right here, $B is equal to quotation mark 1 quotation mark. Well, the important thing to understand is that there are 3 types of data that you can assign to a variable in PowerShell. You can set a variable equal to a number, you can set it equal to a text string, or you can set it equal to an array. And I'll be talking all about arrays in a few minutes, so don't worry if you don't know what that means. But the thing is, when you use quotation marks in a variable assignment, that's a way of telling PowerShell that you want the contents of that variable to be treated as string data. And remember, string data is numbers and letters. So basically what I'm saying is that right now, PowerShell is treating the contents of the $A variable and the $B variable as plain text. And this text could be absolutely anything. PowerShell has no way of knowing that the text is just a number and that we're trying to add those numbers together. So that still doesn't explain why we got a result of 11. The reason for that is that $A contains a text string. $B also contains a text string. When we add those together, what we're doing is performing a concatenation, and we're jamming those two text strings together. Let me show you another example. I'm going to set $A equal to, I'll just say A. And I'll set $B equal to B. And then I'll say $A plus $B, and we get AB. So we're taking the contents of the two variables, both of which are text strings, and we're jamming them together. So that's why we were getting a result of 11 earlier. So what happens if we want to actually perform math, if we want PowerShell to treat this as a number? Well, there are two ways that we can handle that. The first and easiest option is to simply declare the variables in a way that causes PowerShell to recognize them as numbers. So all we have to do is drop the quotation marks. So for example, I could set $A equal to 1, and you'll notice that I didn't use quotation marks. And I'll set $B equal to 1, and again, no quotation marks. So if I display $A, it's set to 1, and if I display $B, it's also set to 1. So now if I type $A plus $B, I get a result of 2. So now PowerShell is recognizing the contents of the variables as numbers, and I'm able to add those numbers together and get a result of 2. Now, in this case, I've been working with variable names that are just a single character, $A, $B. And I've also been working with variable contents that are just as simple. I'm using the number 1 or the number 2 or the letter A or the letter B. But in the real world, variables can contain bigger numbers and they can contain longer text strings. Likewise, the variable names can be full words. And as a matter of fact, that's generally what you'll see in the real world, is that you'll see that most PowerShell developers use words as variable names rather than using letters like A, B, and C. So let's take a look at how the string concatenation works, but this time we'll go ahead and use some real variable names, and we'll use some longer strings. So what I'm going to do is I'm going to create another variable, and I'm going to call this one first name. Now remember, one of the rules that I mentioned earlier is that variable names cannot contain spaces. So that's why you see first and name jammed together. I'm going to set first name equal to my name, which is Brian, and I'll press enter. And if I type $first name, then you see that it contains the word Brian. Now, I mentioned a moment ago that you can't put a space in a PowerShell variable. Let's take a look at what happens if you try. Let me repeat the command, and I'm just going to put a space between first and name. And you'll notice immediately that the colors of the words on the screen have changed. So $first is in green, so PowerShell's recognizing that as a variable. But then name equals Brian changed to a different color. If I press enter, then I get an error message. Unexpected token, name equals Brian in expression or statement. So in other words, we've entered a variable name, and then we've entered something that PowerShell doesn't recognize after that. So $first is being treated as a variable name, and then name equals Brian is something that PowerShell doesn't know what to do with. Because remember, in PowerShell, every variable has to start with a $. So when I'm doing something like name equals Brian, PowerShell thinks of that as a variable assignment because I'm using a word, an equal sign, and a value, but there's no $sign in front of name. So PowerShell isn't quite sure what to do because every variable in PowerShell has to start with a $sign. So with that said, let me go ahead and put this back the way that it was. So now first name is equal to Brian, and then I'll define another variable. I'll call this last name. And I'm going to set this one equal to my last name, Posey. And I'll display the contents of the last name variable. So I get Posey as a result. And then if we wanted to perform a concatenation, we could say $first name plus $last name. And I get Brian Posey, but there's no space in between. So how would I add a space if I wanted to do something like that? Well, I could add a space at the end of Brian, Or there's a few other ways that I could do it. One of the easiest ways is to set up yet another variable. I'll call this space, and I'll set that equal to quotation mark, space, quotation mark. And then I could do something like $ first name plus $ space plus $ last name. And so then my name displays properly. Now, what if I wanted to be able to do something with my name later on? Well, I would actually have to use a variable assignment in a situation like that. So what I could do is I could repeat the same command, but go back to the beginning of that command and declare another variable. I'll call it full name, $ full name equals $ first name plus space, or plus $ space plus $ last name. And if I press enter, I get no visible result, but I could type $ full name, and then I see my name displayed. So that's just a couple of ways that you could do some string manipulation in PowerShell, and there are many, many more things that you can do with strings. They're kind of beyond the scope of this particular video. And incidentally, all of these variables that I'm declaring, you can use right host with those as well. I'm just entering the variable name as a quick and easy way of displaying it. If I wanted to use right host, I could do something like and you can see that right host does indeed continue to display the contents of the variable. Now, earlier, when we were dealing with our $A and $B variables, I mentioned that there were a couple of different ways to get PowerShell to do math. But I only talked about one of those methods, and that method, I assigned the variables as integers. So I said something like $A equals 1 without the quotation marks. And then I was able to act on the contents of $A and $B as numbers rather than having to treat them as text. But in the real world, you can sometimes run into situations in which numerical information has been entered as a text string and you need to take some kind of action on that, and redefining the variable as a number just isn't an option. Fortunately, there is a workaround in a situation like that. What you can do is you can type bracket int, and that's short for integer, and then the variable name. And that tells PowerShell that even though this is a string variable, we want to treat it as a number. So if I were to press enter right now, we're still just going to get a result of 1, but that 1 is actually being treated as a number rather than as a text string. So let me show you a better example of this. I'm going to declare a variable, $A, just like what we did before, and I'll set this equal to 1 in quotation marks. We're treating this as a text value. And I'll set another variable, $B, and I'll set that equal to 1. And again, I'm treating $B as a text string. So if I type $A plus $B, I get 11 because I'm concatenating two string values together. But if, on the other hand, I say bracket int, bracket $A, plus bracket int, bracket $B, and I press enter, now I get a result of 2 because I've told PowerShell that the contents of these variables should be treated as integers, even though they're actually text. Now, one of the big questions that often comes up when people are first learning PowerShell is whether or not variables persist across sessions. So let's take a look. So right now we've got variables that we've defined, for example, $A. If I were to open up another PowerShell window and type $A, $A isn't recognized. So even though I've got two windows open and $A has been declared in one window, it doesn't persist over to another window. So any variables that you declare are only valid within the current window. So let me close this, and I'm also going to go ahead and close my PowerShell window. And I'm going to go to the Start menu, and I'm going to reopen PowerShell and type $A, and you can see that $A is not recognized. So the point that I wanted to make is that when you close PowerShell, all of your variables are cleared, so you never have to worry about opening up a PowerShell window and having variables that are lingering from a previous session and messing up whatever it is that you're trying to do. Those variables are always going to be cleared out when you close the window. So with that said, let me go ahead and clear the screen. And I want to move on and talk about arrays. Now, arrays are really just a type of variable that contains multiple pieces of information. Because so far, every variable that we've set up has only contained a single piece of information. For example, I had a first name variable that contained my first name, I had a last name variable that contained my last name, and I had a full name variable that contained my first and last name, but that first and last name was being treated as a single value. It was BRIEN space POSEY. It was a single text string. Now, an array is different because an array can actually contain separate values that can be referenced separately. So let's take a look at how this works. I'm going to drop down to my root folder, and let's go ahead and set up an array. When you're creating an array, the very first step is to set up a variable name, and that part of the process works exactly like defining any other variable. I'm going to call this one my array. So $my array. Then, just as you would declare any other variable, we have to use an equal sign. And then we have to set that variable equal to something. So I'm going to set it equal to quotation mark a quotation mark. Now, if I just press enter right now, and I look at my array, we see that it's set to a. So all I've really done at this point is just create a string value and assign it to a variable. So we're not really dealing with an array just yet. If we want to turn this into an array, then what we have to do is repeat that command, but then add a comma, and then another value. So at this point, this truly is an array because we're assigning multiple values to the same variable. And we're not limited to 2. We could add a few more if we wanted to. And you'll notice that each value is separated by a comma. I'll go ahead and press enter. And if I output the contents of the variable, you can see that we have A, B, C, and D, and each one is on a separate line. So we've created an array containing 4 different values, and we've output the contents of that array. And incidentally, this also works with right host. The difference is that when we use right host, all of the array values are displayed on a single line, but PowerShell does give you a way of dealing with these individually or displaying each one on its own line if you want to. Now, one of the interesting things about PowerShell and arrays is that these are completely separate values from one another. And that means that you can reference them individually if you want. So let's take a look at how to do that. What I'm going to do is I'm going to type right host, and then I'm going to type $my array. And right now, the my array variable contains 4 pieces of information, A, B, C, and D. So each one of these pieces of information is assigned a position. So the way that we would reference an individual element within this array is by expressing its position. So I'll go ahead and enter a bracket, and then I'll enter 3, and then another bracket. And I'll press enter, and I get the letter D. So D is in the 3rd position of the array. Now the 3rd letter of the alphabet is C, not D. And yet, when I tell PowerShell I want to see the 3rd position in the array, I get a value of D. The reason for this is that array positions start at 0, not at 1. So if I look at position 0, I get a value of A. And then position 1 is B, and position 2 is C. So that's how we can reference individual positions within an array. Now, another thing that you need to know about PowerShell is that it's very, very, very common to assign a commandlet to a variable. There are countless reasons why you may have to do that when you're developing a script, and you'll see numerous examples of that throughout this course. So I want to go ahead and show you how that works. The thing that you need to know is that when you're assigning a commandlet to a variable, that commandlet is actually being treated as an array. So let's take a look at how this works. Let me go ahead and clear the screen. Now, PowerShell has a commandlet called get-process. And the get-process commandlet retrieves a list of all of the system processes that are running on the system. If I press enter right now, we get a list of all of the system processes that are currently running. Now, I mentioned a moment ago that PowerShell provides a way of us assigning a commandlet to a variable. So what I'm going to do is I'm going to create a variable called, I'll just call it $X. We could call this anything that we want, but I'm not feeling all that creative at the moment. So I'm just going to go with $X. And I'm going to assign $X equal to get-process. And there's no visible output when I do that, but if I display the contents of the variable, you can see that $X contains the same list that we saw a moment ago when I just entered the get-process command directly. Now, I mentioned that this commandlet and its output are stored as an array, and that means that we can reference individual items by their position. So if I were to type $X and then bracket 1 and then another bracket, I see one individual process from the list, and it's the process that's in position 1 of the array. So as I mentioned a moment ago, you're going to see countless examples of this throughout this course. So this isn't something that I want to get into super heavily right now. I just want to introduce you to the concept of taking a commandlet and then writing its output to a variable. Now there's one more thing that I need to talk about, and that's hash tables. Now hash tables are another type of array, but they're a special type of array because the arrays that we've worked with so far just contain multiple values, and we can reference those values by position. The thing that makes a hash table different is that it's made up of key value pairs. So in other words, each array position contains two elements. One of those elements acts as a key, the other acts as a value. So we can look up a value by its key. So one of the classic examples that a lot of PowerShell instructors use is a listing of the 50 states. They might use the state abbreviation as a key and the full state name as a value. So they might write a script that has a user enter a state abbreviation, and then PowerShell looks up that abbreviation in the hash table and then returns the full state name. So let's go ahead and take a look at how this works. Rather than using states, I'm just going to use months of the year. So to do that, I'm going to create a variable called $months. And I'm going to set that equal to, rather than entering a value directly, I entered an @ symbol. Anytime that you see an @ symbol, that tells PowerShell that we want to create a hash table. So I'm going to enter a bracket, and then I'll enter 1 equals January, because January is the first month, and then semicolon, and you separate key value pairs by semicolons. 2 equals quotation mark February, quotation mark, semicolon, and we'll do one more. 3 equals quotation mark March, quotation mark, and then brackets, and I'll press enter, and the variable has been created. So if I type $months, you can see its contents. Now, one thing that I want to point out is that we have a header at the top of this. So we have a name column, we have a value column, and then we have these dotted lines right here that separate the headers from the actual data. And you'll notice that looks very similar to what we had right here when we created an array based on the output of a PowerShell commandlet. So hopefully that'll give you a clue as to what's going on behind the scenes. So we've gone ahead and we've created a hash table called $months, and we've looked at the contents of that hash table. Now, what if we wanted to add additional data to this hash table? Well, we can easily do that. I'll type $months, and then I'm going to type period add, and let's go ahead and add April. So I'll open parentheses, and I'll type 4, quotation mark April, quotation marks, and then close parentheses, enter. So now let's take a look at the contents of our variable. And now we can see that April has been added to the list. And if I wanted to remove that, I could type $months .remove. And all I have to do is enter the key. And the key in this case is the number. So I'll type open parentheses, 4, close parentheses, because 4 is the number that corresponded to April. I'll press enter, And now if I look at the contents of the variable, you can see that April has been removed from the hash table. Now, as was the case with a regular array, we can easily look at the value in a particular position. As a matter of fact, I mentioned that you can use hash tables for lookups. So what if I wanted to look up the second month? Well, the way that I could do that is by typing $months, period 2. And I see that the second month is February. So that's how a hash table works. And again, I'm not going to get into this super deep in this video because you're going to see a lot of examples of this throughout the rest of this course. The purpose of this video is more to introduce you to the basic concepts. So as you can see, when we define a variable, that variable can contain numerical data, it can contain string data, or it can contain an array. And that can be an array that we define, it can be the output from a PowerShell commandlet, or it can even be a hash table. So that's how you work with variables in PowerShell. Hello and welcome back. In this video, I want to introduce you to the concept of modules. Modules are a mechanism that makes PowerShell extensible. So why do we need PowerShell to be extensible? Well, if you really stop and think about it, we've been using PowerShell commandlets as they relate to Windows Server. But Windows Server isn't the only product that Microsoft makes. They make a number of other server products. I'm talking about things like Exchange Server and SharePoint Server and all of the different System Center products and things like that. And every single one of those can be used through PowerShell. But PowerShell doesn't come with commandlets for Exchange Server and System Center Virtual Machine Manager and things like that built in. Instead, all of those ancillary commandlets that are related to those specific products are bundled into modules that come with those products. So you can extend PowerShell's functionality by importing modules that are related to specific functionality. And even in the case of Windows Server, not all of the commandlets are loaded by default. Some commandlets exist in separate modules. So what I want to do in this video is I want to show you what modules look like. I want to show you what modules do. And I want to show you how to add and remove modules on an as-needed basis. So let's go ahead and get started. Now, one of the big reasons why Microsoft uses modules, in addition to being able to make PowerShell extensible, is just to keep the number of commandlets manageable. So let me just show you how many commandlets are built into PowerShell before we even load any modules. So I'm going to type get-command. I'll press enter. And you can see a really long list of commandlets being displayed. I'm going to go ahead and press Control-C, or I guess I don't have to because it ended. So how many commandlets are actually there? Well, we can find out. Let me go ahead and set a variable. I'll type $A, and I'm going to set that equal to get-command. Now, rather than just outputting the contents of $A and displaying the same list that we've already seen, I'm going to type $A.count. And we can see that there are 2,303 commandlets that are loaded by default. And by importing modules, there are actually additional commandlets. So let me go ahead and clear the screen. And let's take a look at modules. Now, there are certain modules that are loaded by default every time that we use PowerShell. If I were to type get-module, you can see a list of the modules that are loaded in memory. Now, the Hyper-V module isn't loaded by default. That only exists because I was doing something related to Hyper-V earlier. And we can remove that module. We can type remove-module Hyper-V. And now if I type get-module, you can see that the Hyper-V module is no longer loaded. Now, I didn't uninstall the module, I simply removed it from memory. And if I wanted to add that back in, I could just type import module Hyper-V. And then if I type get module, you can see that the Hyper-V module is back. Now, in the old days of PowerShell, if you were going to use a commandlet that existed within an external module, you had to import that module before you use the commandlet. And in the case of a third-party product or something that's separate from Windows Server, you typically still have to do that. But when it comes to modules such as Hyper-V or Server Manager or things like that that are built into Windows Server, you don't usually have to worry about manually importing those modules. Let me show you what I mean. I'm going to remove the Hyper-V module. So let's confirm that it's been removed. So the Hyper-V module is no longer loaded. What I'm going to do now is I'm going to try to run a Hyper-V related commandlet. I'll type get-vm-computer name, and then I'll type Hyper-V, which happens to be the name of my Hyper-V server. I'll press enter, and we get a list of the Hyper-V virtual machines running on that server. Now, if I were to go back and type get module, you can see that the Hyper-V module was loaded automatically when I entered that get vm command. Now, why is that? Well, every module has a set of PowerShell commandlets that are associated with that module. For example, the Microsoft PowerShell Management module, which you can see right here, includes commands such as add computer, add content, checkpoint computer. So these are all commandlets that are native to that Microsoft PowerShell Management module. Similarly, the Microsoft PowerShell Utility module contains a set of commandlets of its own, including things like add member, add type, clear variable, and things like that. And so the Hyper-V module contains a set of commandlets that are specifically related to Hyper-V. We have things like add VM assignable device, add VM DVD drive, and the list goes on. So what if we wanted to check out the commands within a specific module? Well, one way that we could do that is to type get command, and then we could type -module, and then Hyper-V, which is the name of a module. I'll press enter, and here we see a list of the commandlets that are specific to Hyper-V. Another way that we can do it is to use where object. I could type get command, type symbol, where -object, and in case you're not familiar with the where object commandlet, it's essentially a filter. It allows you to filter a list of objects by a certain criteria. So in this case, we're going to filter by module. So I'm going to use a bracket and then $_dot source. And incidentally, when you use the get command commandlet, the module is listed in the source column. So that's why we're using $_dot source. So I'm going to be looking for commands where the source is equal to, so -eq for equals, and then I'll set this equal to Hyper-V. And I'll press enter. And so now we see only the commandlets that are included in the Hyper-V module. Whereas if I just typed get command by itself, then we see a mixture of commandlets from all of the modules that are currently loaded into memory. This includes everything from the Active Directory module to the Hyper-V module, and you can see some of those right here. So here's one from the Hyper-V module, here's DISM, here's the Microsoft PowerShell Management module, the Microsoft PowerShell Utility module. So all of these commandlets are coming from a variety of different modules. So there's one last thing that I want to show you. I mentioned a moment ago that Microsoft sometimes groups commandlets into modules just as a way of keeping things manageable and keeping there from being too many commandlets that all get lumped together. So in case you're wondering, we can find out how many commandlets exist in a particular module. It's relatively easy to do. What I can do is repeat the same commandlet that I just typed, the get command where object source is equal to Hyper-V, and I'm going to assign that to a variable. So I'll say $A, and we could use any variable name we want. I'm just using $A. I'm going to say $A equals get command where object source is equal to Hyper-V. I'll press enter, and so now if I look at the $A variable, I see all of the commandlets that are related to Hyper-V. These are the commandlets from the Hyper-V module. And I can do kind of the same thing that I did earlier, $A.count. And we can see that there are 245 PowerShell commandlets in the Hyper-V module. So that's just a quick introduction to modules. Now, one of the really interesting things about modules is that you can create your own module. And in doing so, you can even create your own PowerShell commandlets. And I'm actually going to be showing you how to do that a little bit later on in this course. So I'll see you in the next video. One of the fundamental truths involved in working with PowerShell is that you're going to make mistakes. It doesn't matter how much experience you have, errors occur in PowerShell. Sometimes those errors occur as a result of doing something incorrectly. Other times it can be something as simple as a spelling error. It doesn't matter how much experience you might have, you're going to make the occasional error. I make mistakes in PowerShell all the time, and if you haven't seen any of those mistakes in the videos so far, I guarantee you're going to see me make plenty of mistakes before the course is over. The important thing is to learn from those mistakes. And part of that is being able to understand what the error messages are really telling you when PowerShell does display an error. Now, unfortunately, PowerShell has a huge variety of error messages, so I'm not going to be able to talk about all of them. But I do want to show you some of the more common error messages that you're likely to encounter in the real world. Probably the most common error message is this one. This is the infamous term not recognized error. This is one that I spent quite a bit of time in a previous video discussing, and it occurs when you type something that PowerShell doesn't understand. What this error really means is that you've tried to enter a command and PowerShell doesn't recognize what you typed as being a valid command. So in this case, I just hit a bunch of random keys on the keyboard, F, G, G, F, D, F, and because that wasn't a valid command, I got the term not recognized error. Now, this is by far the most common error that you're going to see in PowerShell, but it's certainly not the only one. So I want to show you some of the other errors that you're likely to run into from time to time. Let me go ahead and clear the screen. So one of the errors that I tend to encounter from time to time stems from simply mistyping a file name. Let me show you what I mean. If I open up File Explorer and go to my scripts folder, you can see that I've got a file in the scripts folder called readme.txt, and it's spelled readme.txt. Now, the contents of that file aren't really important for the purposes of this video. What is important is that sometimes you can make a typo when you're trying to access a file. So what I'm going to use is the getChildItem commandlet. If you're not familiar with the getChildItem commandlet, it lists the contents of the current folder. It's very similar to the old dir command that we had in the days of DOS. I'll go ahead and run getChildItem by itself just so you can see what it does. So you can see it displays the contents of the current folder. And if I were to type dir, it does the exact same thing. So what I'm going to do is I'm going to type getChildItem, and then I'm going to follow that with a path and file name. So I'll type C:\scripts /readme.txt. And if I press enter, then I see the README file that I showed you a moment ago in File Explorer. But now let's go ahead and introduce a typo. So I'm going to repeat the command, but I'm going to change the period to a comma, just as a way of illustrating what would happen if you accidentally hit the wrong key on the keyboard. After all, the period and the comma are right next to each other, and I couldn't tell you how many times I've typed a comma instead of a period or a period instead of a comma. So let's go ahead and press enter, and I get an error message. So let's look into this and see what this error message is really telling us. Now, one of the things that you'll find about PowerShell is that generally speaking, the most valuable information in an error message is typically going to be found on the first 3 lines. I mean, PowerShell gives you a lot more information than that. You have all of this beyond the first 3 lines, but I've probably never actually delved into all of that because a lot of it's more or less meaningless. You can get everything that you need off of the first 3 lines. So what do we see right here? Well, first we have get-childItem, and then colon, and then cannot find path. Now, just the section that I've got highlighted tells me something really important. This tells me that I didn't mistype the name of the command because it's the getChildItem command that's returning the error message. So this isn't one of those where I just misspelled the commandlet that I wanted to use or something like that. Now, the actual error is cannot find path, And then PowerShell gives us the path, /scripts /readme, and then we have an apostrophe. And then it tells me that it can't find this because it doesn't exist. Well, the reason it doesn't exist is because the file is called readme.txt, not just readme. And you'll notice that the .text part is missing. Now, it doesn't explicitly spell that out, but if you go down a little bit further, down to the third line, we have get-child item, /scripts /readme, text. So this is the part where it went wrong. Now, you'll notice this line right here where we have just a squiggly line and a plus sign. What PowerShell tries to do with this line is it tries to show you the point in the command where the command failed. And every great once in a while, that will actually be helpful. But most of the time, the line gets it wrong. Because, for example, in this case, the command failed right here, and yet this squiggly line continues on to the end of the .txt. So that's one example of an error that you might see in PowerShell. Let's take a look at a few others. Sometimes you can get error messages when you're declaring a variable. So I'm going to set up a variable. I'll just call it $V. We could call this anything. It doesn't really matter. And I'll set this equal to this is a test. And I'll press enter. And I get an error. So what happened here? Well, if you take a look, $V is highlighted in green, and then we have equals, and then we have the word this highlighted in yellow, and then is a test highlighted in white. Just the way that this is highlighted is kind of a clue as to the way that PowerShell interpreted this. But let's take a look at the error message. We have this, and then the term this is not recognized as the name of a cmdlet function, script file, or operable program. So we got a term not recognized error. This is the same error that we got when I entered a bunch of random keys on the keyboard. So what's going on here? Well, you have to think about the way that variable declarations work in PowerShell. When you declare a variable in PowerShell, there are a few different things that you can potentially assign to a variable. You can assign a number to a variable, such as $V equals 1. That's valid. If I type $V, we get 1. You can also assign string data to a variable. I could say $V equals, and I'll put it in quotation marks this time, this is a test. And now if I look at $V, it contains this is a test. But the third thing that you can assign to a variable in PowerShell is a commandlet. For example, I could say $V equals get-process. And if I look at $V, then I see all of the processes that are running on this machine. So let me backtrack a few commands. And this is the command that I entered that had produced the error. So one of the things that you might have noticed is that when I entered string data into the $V variable, that string data had to be enclosed in quotes. An apostrophe will work too, incidentally. But when I assigned a command to $V, commands don't get enclosed in quotation marks. You just enter it in the way that you see right here on the command line. So what happened when I forgot the quotation marks around the this is a test string, PowerShell tried to interpret that as being a command that I wanted to assign to the $V variable. And because this is a test, a valid command name, that's why I got the term not recognized error message. So that's what's going on there. So what else can we do? Well, let me go ahead and clear this out. Now, a moment ago, I showed you the get process commandlet. I'll go ahead and type that again without the variable. And if I just enter this command as is, I get a list of all of the processes that are running on this machine. Now, one of the things that's often done with processes is to select a specific process from the list or to select a specific field. So let's suppose that I wanted to narrow this down and just look at the names of the processes. One way that I could do that is by typing get-process, pipe symbol, select-object, and let's look at the name column. And when I do that, I get a list of all of the process names. Now, let's go ahead and repeat that. But what I'm going to do this time is I'm going to forget the pipe symbol. I'm going to do that intentionally. We have get process select object name. And I'll press enter, and we get an error message. So let's take a look at what PowerShell is telling us here. So the first thing that we have in this error is get-process. This tells us that the get-process portion of the command was valid. We're not getting a term not recognized error. PowerShell actually recognizes the get process commandlet. So then the next thing that we have is a positional parameter cannot be found that accepts argument name. Now, what in the world does that mean? The vast majority of the PowerShell commandlets accept multiple parameters. Those parameters are essentially things that get appended to the commandlet in order to get a specific output. Let me show you an example of that. I'll type get-process, and we'll specify a process name. I'll type PowerShell. And so when I do that, I see the PowerShell process because I entered the process name as a parameter. But remember what I said a moment ago. Most PowerShell commandlets accept multiple parameters. So if we go back to the command that triggered the error, we had get-process, that was totally valid, and then we forgot the pipe symbol. So what ended up happening is that PowerShell looked at this select object, and because the first parameter that the getProcess commandlet looks for is a process name, it assumed that select object was the name of a process running on this machine. Incidentally, select object is not the name of a process, but that's the way that this particular command interpreted this statement. So it treated select object as a process name. Then it got to the name portion of the command. And what it was looking for there is another parameter to go with the getProcess command. But there's no parameter called name, so that's why we got the error message. Now the error description makes a little bit more sense. A positional parameter cannot be found that accepts the argument name. And if you want to see what those parameters look like, this is a little bit off topic, but if you want to see what the parameters look like, you can just type get-help, get-process, and what you get is the syntax. So if I go up here, you can see that we have a name parameter. That's where I typed in PowerShell a moment ago. And then we have some other parameters that are accepted as well. Computer name, module, file version, info, and there are some others. So that's why that particular error was triggered. So let's take a look at another example of an error. What I'm going to do is clear the screen, and then I'm going to type roughly the same command that I entered a moment ago. I'll type get-process. This time I will include the pipe symbol, and then I'm going to type select object, and then name. And assuming I haven't misspelled anything, this is a totally valid command. It'll give us the names of all of the processes that are running on this machine. And it does. But having said that, let's go back and repeat that command, and this time I want to introduce a spelling error. I'm going to add an extra E to the end of name, so name is now misspelled. I'll press enter, and here's what we get, black screen. So what happened? Well, actually, we're not just getting a black screen. Let me scroll up a little bit. So right here, you can see the command that I entered, and then you see a column header with name misspelled, and then that's empty. Well, the reason why that happens is because if you use the select-object commandlet, and then you specify an invalid object, which is essentially what we did by misspelling name, then PowerShell is going to give you an empty column. So the reason why we had all of this blank space beneath the name column is because PowerShell is going through that list of processes, so we've got a blank line for each and every process. Let me show you what I mean. Actually, I'll clear the screen, and I'm going to repeat that command, but what I'm going to do is I'm going to type name, spelled correctly, add a comma, and then name spelled incorrectly. I'll press enter, and now if I scroll up, you can see the two columns. We have name, which is valid, and name, which is misspelled. So they appear side by side, and you can see that we have blank space beneath the name for every single process on this machine. So if you unexpectedly get a lot of blank space in PowerShell, that's what's probably going on. Now there's one more thing that I want to talk about. Let me go ahead and clear the screen, and I want to go back to something that I said a few minutes ago. Earlier I was talking about variables, and I set up a variable called $V, and I mentioned that you could assign a text string to a variable, you could assign a number to a variable, or you could assign a PowerShell commandlet to a variable. And then I went on to say that if you were going to assign a text string to a variable, then what you had to do is enclose that in quotes. For example, I could say $V equals quote, hello world. And now $V equals hello world. So that's how you assign a text string to a variable. And I also showed you that if you do this without the quotes, then you get a term not recognized error because PowerShell interprets this as you trying to assign a commandlet to the variable. But what happens if you use the opening quotes and forget the trailing quotes? Well, let's find out. So what I'm going to do is I'm going to type $V equals quotation mark, hello world, and I'm going to intentionally forget the quotation mark at the end and press enter. What I get is PowerShell dropping me down to a blank line. And what this means is that PowerShell is asking for what's missing. So if you get something like this, most of the time, the best thing that you can do is just press Control C, and that will drop you back down to the command prompt and give you the opportunity to try again. Now, forgetting a trailing quotation mark isn't the only time that you're going to see that. You'll also see this if you forget a bracket. So let me show you what that looks like. I'm going to use a different command. I'm going to use get-process. And I'm going to set up a filter just to give me an excuse to use a bracket. So I'll add a pipe symbol and then where-object bracket $__name -eq for equals PowerShell. And I'll press enter, and what this does is it retrieves the PowerShell process. The where object portion of the command filters out every process except for the process whose name is equal to PowerShell. So that's what the command is supposed to do. But if I repeat this command and I forget the trailing bracket, then I get exactly what you saw earlier when I forgot the ending quotation mark. So once again, you can just press Control C, and that will drop you back down to the command prompt, and you can try again. So there's one last thing that I want to show you before I wrap up this video. I'm going to go ahead and close out PowerShell, and I'm going to open up PowerShell version 7. Now, we haven't really talked about PowerShell version 7 just yet. It's something that I'm going to install in the very last lesson in this course. But PowerShell 7 has a get error commandlet that you can use to get more detailed information about an error message. So I wanted to at least quickly mention that and show you what that looks like. So I'll go ahead and open up PowerShell 7. Now, the important thing that you need to know about PowerShell 7 is that it's not included with Windows. This is something that you actually have to go download and install yourself. And again, if you go check out the very last lesson in this course, I'll show you how to do that. But for right now, I want to show you how error handling works in PowerShell 7. So what I'm going to do is I'm just going to type right host, but I'm going to misspell right host. And I'll press enter, and I get an error message. And this is the term not recognized error that you'll see over and over again in PowerShell. But the main thing that I wanted to show you is that PowerShell 7 has a commandlet called get error. I'll type get, and then error. And what this does is it retrieves really detailed information about the last error message that you encountered. So if you scroll up, you can see just how much information PowerShell actually gives you. So you can see the actual error message right here. The term right host with an extra T is not recognized as the name of a commandlet function. Script file or executable program, check the name. Or if a path was included, verify that the path is correct and try again. Now, this is probably going to be enough information to be able to figure out what went wrong. But if you're a developer and you need some more information, well, PowerShell 7 gives you lots of information that you can fall back on to help figure out what in the world went wrong. So that's not really something that I'm going to be using throughout this course, but I wanted to at least mention the existence of this particular feature. So that's going to do it for this video, and hopefully the next time that you run into an error in PowerShell, you'll be able to use the techniques that I've shown you to help figure out why you're getting that particular error. As I explained in the previous video, PowerShell errors can sometimes be kind of convoluted and difficult to understand. One of the things that you can sometimes do to make things a little bit easier is to create custom error messages. So you can have PowerShell display an error message of your own choosing rather than displaying the custom error messages. So why might you want to do this? Well, the technique that is used to create custom error messages is really simple to do, but it's the sort of thing that you would typically only include in an advanced script. Now, why is that? Well, typically, when you're creating a custom error message,
you're going to use that error message in response to a command that hasn't worked quite the way that it should. So if you've ever developed a web application, you know that a lot of the web programming languages require you to write code that results in HTML output. And if that HTML output isn't rendered just right, then you get an error. Well, PowerShell can work the same way. You can include commandlets, command fragments, parameters, and just about anything else that you can imagine in variables. And then you can combine those variables together to form a command string. But when you do that, there's not always a guarantee that everything is going to come together perfectly, and sometimes a malformed command can end up producing an error message. So that's where custom error messages come into play. You can use a custom error message as a way of telling either yourself or the person who's using your script what went wrong. It's something that I do all the time in the scripts that I write for myself. So in this video, I wanted to show you how to create custom error messages. Now, in order to do this, I need to skip ahead just a little bit. We're not going to be talking about scripts in depth until the next video, but the technique that I'm going to show you requires scripting. So I'm going to show you what a script looks like just so you can get a feel for it. But if you would rather watch the video on scripting first, then go ahead and jump ahead to the next video and then come back to this one. And this one may make a little bit more sense. But I'm going to do a lot of hand-holding in this video just because I haven't had the opportunity to talk about scripting just yet. So the main thing that you need to know about scripting for the purposes of this video is that a script is really nothing more than just a text file that has a .ps1 extension. And that text file contains one or more PowerShell commands. So let me show you a really simple example of a PowerShell script. I'll go ahead and open up File Explorer. I've got a scripts folder, and one of the scripts that I'm going to be using in the next video is hello world.ps1. I'll go ahead and open this up. Now, if you've ever taken a programming class, then you know that the first program that most programming students are asked to write is a really simple program that does nothing more than display the words hello world on the screen. And that's exactly what this script does. The CLS command that you see right here clears the screen, and then the write host command displays the words hello world. That's it. That's all this does. So let me just show you what this looks like. I'll switch over to PowerShell. And the way that you run a script in PowerShell is by typing /, and that's the slash that's on the question mark key, and then the name of the script, .ps1, and I'll press enter, and you can see that this script clears the screen and displays the words hello world. That's all it does. So now that I've shown you that script, let me go ahead and close that out. And I'm going to load the script that I'm going to be using for this video. So what we have is a very simple 4-line script. The first line is try. Now try is a way of telling PowerShell that you want to evaluate a command. And so within the try command, we have write host, open parenthesis, apostrophe. The first command that you entered was valid, apostrophe, close parentheses, bracket. So what we're going to do is we're going to evaluate the command write host. The first command that you entered was valid. Then the next command is catch. Now catch will only end up executing if the first command was actually invalid. So in the catch command, we have catch write host. The first command that you entered was invalid. So then we have another try, and there's a write host command, and it says the second command that you entered was valid. And then there's another catch command, and it has a write host command indicating that the second command that you entered was invalid. Now I realize that this sounds a little bit convoluted, and there's a lot going on here. But here's the really simple way of understanding this. The very first line of code is going to evaluate the write host command. If that command works, then that command is going to be executed. If it doesn't work, then the catch command is going to be executed. So in other words, if the write host command is correct, then you're going to see the phrase, the first command that you entered was valid, displayed on the screen. If that command didn't work, then instead you're going to see the text, the first command that you entered was invalid, displayed on the screen. And the same thing goes for the third and fourth commands. The third command validates another write host command, and if that command is correct, you're going to see that write host command's output displayed. So you're going to see text saying the second command that you entered was valid. If, on the other hand, that write host command is invalid,
then the catch is going to kick in and you're going to see an error message saying the command that you entered was invalid. So let's take a look at what this looks like in practice. Now, as it stands right now, both of these write host commands, and I'm talking about this command right here and this command right here, both of these are constructed properly. So what we should see is simple output that says the first command that you entered was valid and the second command that you entered was valid. And the reason why we're going to see that is because this section of code right here does not contain an error. So we're going to see the output say the first command that you entered was valid. If this portion of code did contain an error, then PowerShell would actually end up executing this instead. And we have the same thing down here. Right now, this block of code does not contain an error, so we'll see the words the second command that you entered was valid appear on the screen. If, on the other hand, this section of code did contain an error, then we would see this line of code right here execute instead. So let's take a look at what this looks like. The name of my script is catcherror.ps1, so I will switch over to PowerShell. I will switch over to my scripts folder. And I'll go ahead and execute the script. And we can see that the first command that you entered was valid, the second command that you entered was valid. So that's exactly what was supposed to happen. So let me go ahead and minimize this. And what I want to do now is I want to introduce an error into the second try command. So I'm going to change this from write host to write hosts, which is an invalid command. Normally, this would generate an error within PowerShell. In fact, if I were to select this and copy it, and then switch over to PowerShell, and then just paste that command, here's what would normally happen. We would receive an error message because write hosts is an invalid command. If, on the other hand, I were to do the same thing, but take the S off of hosts and just change this back to write host, then the command would run as intended. But as it stands right now, we've got an error that we've introduced. So let me go ahead and save this out. And I'll switch back over to PowerShell and go ahead and clear the screen. And I'll run my script. So this time the output indicates that the first command that you entered was valid because we haven't made any changes there. But now we see a message saying the second command that you entered was invalid. And we're getting that custom error message because we ended up making a change to the write host command, changing it to an invalid command. So what we're seeing here is a custom error message. Now you can get a little bit more creative with these custom error messages. So I just want to take a second and show you something really silly that I made as a way of conveying a custom error message. Now, I can't take full credit for this because I once saw somebody do something similar with a JavaScript, but all of the code that you're about to see is my original code. So let me go ahead and minimize PowerShell, and I'll close this catch error script out. And I want to open a script called clippy.ps1. Now, you might remember Clippy of Microsoft fame. It used to be a part of Microsoft Office back in the early days. So what I'm doing is I'm using a really long and complex write host command to display a custom error message. And you can see that this particular command looks pretty convoluted. Now, what I wanted to show you is I'm doing a try, and I'm just including invalid command because that is an invalid command. So I'm trying to force an error at this point just so that my catch statement will execute. Now, as before, I have write host, open parenthesis, quotation mark, and then there's another quotation mark, and close parenthesis at the end right here, and then a bracket to end the catch statement. And then everything in between those two quotation marks is just raw text. This is text that's going to be displayed on the screen, with the exception of this R and N that you'll see periodically. So we have an R and an N here, an R and an N here, an R and an N here, and there's several of these scattered throughout this script. Now, this character right here, this isn't the apostrophe. This is kind of, I don't know what the correct name for it is, but it's basically a backward apostrophe. It's on the tilde key. It's the key that's just to the left of the number 1 on your keyboard and just above the tab key. So when you have the apostrophe R, that's a return character. And then when you have the apostrophe N, I'll call it apostrophe, it's not really apostrophe. But when you have the apostrophe N, that's new line. So anytime that you have this apostrophe R, apostrophe N, then that tells PowerShell to go down to the next line and go to the beginning of the line. So what we're doing is we're creating multi-line output. Now again, I'm doing this to do something silly, but if you need to construct a detailed error message, and that error message is going to consume multiple lines of text, using this apostrophe R, apostrophe N, and using that as a separator between various blocks of text is a way that you can accomplish that within a single right host statement. So if you need to produce a really long and detailed error message, and that error message needs to span multiple lines, then what you can do is enter all of your text within a single right host command and separate the lines of text using this apostrophe R, apostrophe N. And once again, this isn't actually an apostrophe. I'm just calling it that because I don't know what it's actually called. But it's on the tilde key, which is just above the tab key on your keyboard, and just to the left of the number 1. So with that said, let's just go ahead and execute this script and see what it looks like. So as you can see, this error message displays a really crude drawing of Clippy of Microsoft Office fame, and there's a speech bubble that points to Clippy, and I use that speech bubble to convey the error message. So that's just something silly that we can do with a catch statement in PowerShell, but I did this to convey the idea that you can create longer error messages that consume multiple lines of text. So now that I've shown you that script, there's one more script that I want to show you. At the very beginning of this video, I mentioned that custom error messages were useful in situations in which you're assembling a command on the fly, and you need to find out if that command is valid or not before you attempt to execute it. So I want to open up one more script where I'll show you how to do exactly that. And that script is 2-6.ps1. I'll go ahead and open that up in Notepad. And here's the script. Now, I know this is a little bit more complicated than the Hello World script, but believe it or not, it does exactly the same thing as what you just saw, minus the clear screen part. I didn't include a clear screen command. Now, for right now, just ignore these 3 lines right here that are highlighted in blue. Because in PowerShell, anytime a line starts with the pound sign, like what you see highlighted in blue right now, that line is treated as a comment, which means that PowerShell ignores everything on that line that comes after the pound sign. So PowerShell isn't even acknowledging that these lines exist. From a functional standpoint, our script consists solely of what you see right here in blue. So let's take a look at what this does. The first line declares a variable called $A, and we're setting $A equal to the words right host. Then we're declaring another variable, $B, and we're setting $B equal to an apostrophe. Then we're declaring a variable called $C, and we're setting $C equal to hello world. Then we're declaring one more variable called $D, and we're setting $D equal to $A plus $B plus $C plus $B. And then this line right here outputs the contents of the variable $D. So let me show you what happens if I run this script. I'll switch over to PowerShell, /2-6.ps1, and I get the text right host hello world. And you'll notice that hello world is in apostrophes. Now, why did I show you this? Well, maybe it's a little bit early to be talking about advanced scripting, but in PowerShell, the vast majority of the scripts that you're going to run into in real life simply use hard-coded commands, like what you've already seen. If I switch back to my script, $A equals right host. That's a hard-coded command. This command is always going to do the same thing every time it's run. $B equals apostrophe. That's another hard-coded command. $C equals hello world. That's another hard-coded command. But in some of the advanced scripts, you might not always have the luxury of hard-coding commands. If you're not quite sure what you're going to need a command to do, there are techniques that you can use to assemble PowerShell commands on the fly using the contents of different variables. You bring those variables together to form a command, and then you execute that command. So that's kind of what I'm doing right here. The difference is that, at least so far, I'm not actually executing that command. The line $D tells PowerShell to display the contents of the $D variable which the $D variable is write host hello world, but it doesn't actually execute the contents of that variable. Right now, it's just treating it purely as a text string. So what if we wanted to execute this? Well, then we have to use a PowerShell command that I haven't talked about yet called invoke expression. And there's nothing special that you need to know about invoke expression other than that it's used to execute the contents of a variable. So $D contains a PowerShell command, and invoke expression tells PowerShell to execute that command. Now, right now, this line of code is commented out, so it doesn't do anything. But let's go ahead and remove the comment. So I'll remove the comment, and I'll save my change. And let's go back to PowerShell and rerun the script. So we see write host hello world, and that's because of this line right here that just displays the contents of $D. But then PowerShell actually displays the words hello world. And the reason why it's doing that is because of this invoke expression line right here. Invoke expression actually executes the command that is stored in $D. Now, I know that's a lot to take in just for the sake of creating a custom error message, but I needed to lay a little bit of groundwork before I show you how to create a custom error message. So one of the big problems that you can sometimes run into if a PowerShell script assembles commands on the fly is that a command might be assembled incorrectly. This can especially happen in really complex PowerShell scripts. So what do I mean by that? Well, let's drop this last $B from the command. And then let me rerun this. So I'll go ahead and save this out and switch over to PowerShell. And I'll go ahead and clear the screen by typing CLS. And I'll go ahead and run the script. So let's take a look at what happened. We've got this line right here, $D, that displays the contents of the $D variable. And the contents of that variable are write host, apostrophe, hello world, and it's missing the apostrophe at the end. And the reason that apostrophe is missing is because I took away that $B in the line where I declared the $D variable. So then I had my invoke expression command. And the invoke expression command treated the contents of $D as a command and executed that command. Well, the problem is the $D string is missing the ending apostrophe. So when PowerShell attempted to execute that command, we got an error because the command was malformed. So this is what can happen in the real world whenever you begin assembling commands on the fly. So if something like that happens, you have a couple of choices. You can either allow PowerShell to display an error message like this one, which can be really hard to decipher, or you can create your own custom error message. And the advantage to creating your own custom error message is that you can give yourself some helpful information. You can say something like, the command failed at line X, or something like that. You can do something to give yourself a hint as to what went wrong so that you can have an easier time debugging the script. So let's take a look at how that might work. I'm going to switch back over to my script, and I'm going to go ahead and put the plus $B back in the variable declaration line. And I'm going to comment out the invoke expression line. So let me save my changes. So right now, if I run the script, it shouldn't do anything other than display the command, which it does. And what I want to do is uncomment these last two lines. So what PowerShell does is it will try to run whatever happens to be in between these brackets. Now, right now, this is invoke expression $D, but this could be anything. As long as it's a valid PowerShell command, you can put anything that you want in there. Then we have this line catch. So here's what happens. PowerShell is going to try to run this command right here. If that command succeeds, then PowerShell will let it run just as normal. You don't have to worry about doing anything special. If, on the other hand, this command generates an error, then PowerShell is going to drop down to this line right here where you see the word catch, and it's going to execute whatever command happens to fall between these brackets. This is where the custom error message comes into play. Because in the catch section, I'm using write host, you made a mistake, and your script didn't work. So this is my custom error message. Now, it's worth noting that this technique can be used to do a lot more than just creating a custom error message. because you can actually have multiple lines of code in the try section and in the catch section. So you can have really elaborate error traps that you set up. But for right now, all we're really doing is we're trying the command that we assembled on the fly to see if it works or not. If it works, we're going to let it run. If it doesn't work, then we're going to display a custom error message. So let's take a look at how this actually works. So I'm going to switch back over to, or actually let me save my changes. And then I'm going to switch back over to PowerShell. And I'll go ahead and clear the screen. And let's run the script. So the script displays the contents of that $D variable. And then it runs the invoke expression, $D, which gives us an output of hello world. So everything worked just fine. So let me go back to the script. Now, this invoke expression $D is commented out, so that's not executing at all. Instead, what actually executed was this line right here. So PowerShell tried to execute this. It executed fine, so it just let it be, and it executed in the normal manner. Now, let's go ahead and get rid of this last $B in my $D declaration line. I'm going to remove that. I'll save my changes, and this will cause that same error that I showed you earlier to occur. Let's go ahead and run the script, and what you'll see is that error message is gone, and it's been replaced by the custom error message. So now when I run the script, I get an error message saying you made a mistake and your script didn't work. And you can see right here that I dropped the ending apostrophe, and that's the reason why we got that error message. At any rate, this is how you would go about creating a custom error message in PowerShell. And keep in mind that even though I used this custom error message as a way of validating commands that were assembled on the fly, you don't have to use it in that way. You can put anything that you want in a try statement. So if, for example, I wanted to just comment out everything that I've done in this script. So we'll forget all about ABCD, and we'll forget about this invoke expression. What you could do is something really simple. We could put a command such as write host, hello world. And so right now, the try and the catch lines are the only lines of the entire script that aren't commented out. So I'll go ahead and run this. And we get hello world as the output. If, on the other hand, I introduce a mistake in this line, I'll delete a character. And I run the script, then my custom error message is displayed. And the reason why that happens is because the statement that's in between the brackets in the try command is no longer valid because I've introduced an error. So that's how you create custom error messages in PowerShell.
Lesson 3 is where we start building PowerShell scripts. I'm going to keep things simple in this lesson, and the most advanced thing that we'll be doing is creating a simple function within a script. For the most part, this lesson focuses on teaching you some key scripting fundamentals. The topics that I'll cover in this video are building a PowerShell script, configuring the execution policy, creating a function, silencing errors, mathematical operators, comparison operators, assignment operators, logical operators, interactive authentication, and automatic authentication. Hello and welcome back. In this video, I'm going to talk all about PowerShell scripting. Now, before I show you how to create your first script, there's something that I need to talk about. You see, I've had a number of people suggest over the years that PowerShell scripts are really the sort of thing that only professional developers need to worry about. In reality, though, you don't have to be a professional developer to use a PowerShell script. Believe me when I say that I myself am not, by any stretch of the imagination, a professional developer, and yet I use PowerShell scripts all the time, and I know a number of other people who are in the same boat. So why would a non-developer create a PowerShell script? Well, there are countless reasons, and in all honesty, I could probably spend this entire video talking about all of those reasons. But let me just throw out a couple of quick examples. One example is that PowerShell scripts are useful for performing repetitive tasks.
Let's pretend for a moment that you've got some sort of task that you need to do through PowerShell, and there's a chance that you may have to do that again in the future. It's going to be a lot easier to create a script and then just be able to reuse that script at a later date when you have to perform the task again, than to have to sit down and figure out the steps all over again and try to remember the command syntax and that sort of thing. So PowerShell scripts are great for automating those repetitive tasks. PowerShell scripts can also be used for scheduled tasks. So what am I talking about here? Well, Windows has a component called the task scheduler that runs tasks on a scheduled basis according to a clock. And you can actually set up a PowerShell script to run according to a schedule. Now, you can't just take a PowerShell script and give it to Windows Task Scheduler and tell it to run. There are a couple of other steps that you have to do. And I'll get into that in some of the later videos. But just know that you can use Windows Task Scheduler to schedule a PowerShell script to run on a periodic basis. So why would you want to do that? Well, in my own environment, I have a script that I created quite some time ago that goes out and checks the health of all of the hard disks on the various systems that I use every day. And if it finds that a hard disk is in an unhealthy state, then it will send me a notification so that I know to replace that disk. And I've got that script set up to run on a scheduled basis. So those are just a couple of examples of how you might use PowerShell scripts in your day-to-day life. So now that I've talked about that, let's take a look at how to create a PowerShell script. Now, in the very first video in this course, I showed you how you could use PowerShell ISE as a script development environment. But in that video, I mentioned that I prefer to use Notepad simply because it's lighter weight and the screen's a little bit less cluttered. So before you can use Notepad to create a PowerShell script, there's something that you need to know. So let me show you what this looks like. What I'm going to do is open up File Explorer, and I've created a PowerShell script called test.ps1. Now this script doesn't really do anything, and it uses some commands that we haven't even talked about yet, but let me go ahead and open it up. Now, as I talk about scripting, I'm going to start out with a script that's even simpler than this one, but let me just quickly step through the script just for the benefit of anybody who might be curious. The script starts with a function declaration on the very first line. It uses the word function. And then whenever you create a function, you have to name that function. I'm calling this function do something. Then the function block is contained in these brackets right here. So the function code begins here and it ends right here. And the only thing that this particular function does is assign a variable. The variable is named $a and it's assigned a value of 1, 2, 3, 4. The very last line of code calls the function. So we're calling the function assigns the value of 1, 2, 3, 4 to a variable called $a, and then it ends. That's all it does. And as I said, as we talk more about creating functions, I'm going to start with something even simpler than this. But I needed to use this particular function just for the sake of demonstration so that you can see an issue with using Notepad. So you can see what this looks like right here. Now I'm going to leave this open on the screen, and I'm going to open up PowerShell. And let me shrink the window just a little bit so that I can have my script and PowerShell open on the screen at the same time. Now this particular script is saved to the Documents folder, so I'm going to go to the Documents folder. I'm going to type CD for change directory, Documents, and then I'm going to use the type command. The type command is a leftover from the days of DOS, and what it does is it displays the contents of a text file. So I'm going to type, and then the name of the file, which was test.ps1. So as you look at this, you can see that the first line of the script looks correct, but the second line appears to be corrupt. Whereas the script shown in Notepad shows $a equals apostrophe 1, 2, 3, 4 apostrophe, PowerShell shows something completely different. It shows $a equals and then what appears to be some corrupt characters. So my script isn't corrupt here. What happens is that recently Microsoft made a change to Notepad. And whereas Notepad used to save files in one file format, now it saves files in a different format. So let me show you how to fix this. This is really important if you want to use Notepad to write PowerShell code. So what I'm going to do is go to File and go to Save As. And if you look right here, you can see that the encoding is set to UTF-8. That's the new default encoding standard for Notepad. Previously, Notepad used ANSI. So if we switch this from UTF-8 to ANSI and click Save, Then it's going to ask me if I want to replace the file. I'll choose yes. And now the file is saved in ANSI format. So let's repeat the command, type, and then the file name. And now everything looks correct because the file is now saved using ANSI encoding instead of UTF-8. But it's also one of those things that if you don't take the time to do that up front, then some of your PowerShell scripts may appear to be corrupt. Incidentally, this is a little bit off topic, but Microsoft made one more change to Notepad that might be helpful to know. Let me click on Notepad, and I'm just going to add a random character. And when I do that, you'll notice that up in the upper left corner, just above my mouse pointer, an asterisk appeared just to the left of the file name. That asterisk indicates that there are changes within the file that haven't been saved. So sometimes when you're working in Notepad, it can be tough to remember to save, and you may not always remember if you've saved the file or not. Looking for this asterisk is a handy way of knowing whether or not the file has been saved. Now, I realize that I did that kind of quickly, so let me just go ahead and close this out. I won't save it. And let me open it up again in Notepad. So if you look at the file name, there's no asterisk in front of the T in test, where my mouse pointer is in the upper left corner of the window. Now if I add a random character, you'll immediately see that asterisk appear just above where my mouse pointer is. I'm going to do it now. And there's the asterisk, indicating that a change has been made to the file and that change hasn't been saved. If I were to save this, then the asterisk goes away. So let me go ahead and close this out. And now I want to talk about how to create a PowerShell script. So what I'm going to do is close all of these windows. I'm going to open up PowerShell. So the first thing that I need is a place to save my script. So I'm going to use the cd or change directory / command, and that's going to drop me down to the root directory. And I'm going to create a new folder called scripts, and we'll save all of the scripts there. I'm just going to type md for make directory, scripts, and the scripts folder has been created. If I type dir, you can see the scripts folder. Now, incidentally, dir is an old DOS command, and so is cd and md and some of the other commands that I've been using. You might be wondering why I'm using the old DOS commands as opposed to doing things the PowerShell way. Because really these commands that I've been using are just aliases for updated PowerShell commandlets. Well, there are two reasons. One is because I grew up in the days of DOS. This is what I'm used to, so this is easy for me. The other thing is that sometimes using the old DOS commands is just easier than using the PowerShell commands. Let me show you what I mean. I'm going to type rd, that's remove directory, scripts, and that's going to get rid of the folder that I just created. If I type dir, you can see that it's gone. So let's go ahead and recreate that folder, but we'll do it the PowerShell way. Remember, I created the folder by using md scripts. That's all it took. To do it in PowerShell using a PowerShell commandlet, I have to type new -item, and then I'll type -path space quote // quote space -name space quote scripts quote space -item type space quote directory quote enter. And that creates the scripts folder, whereas if I had done this using the DOS version, I could have just typed md scripts like that. So you can see how much shorter the DOS command is. Similarly, if I wanted to verify the creation of this folder, the DOS command is dir, whereas the PowerShell command is get child item. So now that we've created a folder that we can use to store the scripts, let's go ahead and create a script. To do that, I'm going to go ahead and launch Notepad. And I'm going to create a very simple script. I'm going to start out by typing cls
That's the old DOS command for clear screen. And then on the next line, I'm going to type write host. Write host is the PowerShell commandlet that's used to display text on the screen. And I'm going to add a space and quotation marks, and I'll type hello world. Now, in case you're wondering, hello world is the name of the very first program that most programmers learn in school. They simply write a very simple program that displays the words hello world on the screen. And that's exactly what we're doing right here. This is the very simplest script that I could think of. So let's go ahead and save this. And I'll save this to the scripts folder. And I'll call this hello world.ps1. And for whatever reason, Notepad is trying to use UTF-8 encoding again, so I'm just going to change this back to ANSI and click Save. And so now let's go ahead and run the script. I'm going to switch over to PowerShell, and I'm going to switch over to my scripts folder. And the way that you run a script in PowerShell is to type /, and that's the slash that's on the question mark key, and then the name of the script. So when I press enter, the screen should clear and you should see the words hello world displayed on screen. I'll go ahead and do that now. So we've just run our very first PowerShell script. So that's how you create a script in PowerShell. Now before I move on, I want to go ahead and open up PowerShell ISE just so that you can see what the script looks like in there. So here we are in PowerShell ISE, and what I'm going to do is I'm just going to retype the script and I'm going to save it with a different name. So the first line was CLS. Second line was write host. And then hello world. And you can see how PowerShell ISE uses syntax highlighting, so different parts of the command are in different colors. That can make it a little bit easier to sort out any problems that you might have as you write more complex scripts. So I'll go ahead and save this. And I'm going to save it to the scripts folder. And I'll call this hello world2.ps1. I'll click save, and the script's been saved. So let's say that we wanted to execute this particular script. We could obviously open up the same PowerShell window that we had open a moment ago and run it from there. As a matter of fact, I'll go ahead and do that. I'll switch over to PowerShell and I'll run hello world2.ps1. And you can see that the script runs, or we can run it directly from within PowerShell ISE. And I would need to do the same thing. I'll type cd / to drop down to the root folder, cd scripts to go to the scripts folder, and then /hello world2.ps1. And so there we have our hello world script run from directly within PowerShell ISE. Now, you might be wondering why I bothered to create a second script when I could have just loaded up the first one. The reason is because I wanted to show you how tabbing works. So what I'm going to do is just go up to File and go to Open. And I'm going to choose my original Hello World script, and I'll open that. And you can see that that script is open on a separate tab. So right now we have two tabs open with two different scripts. The two scripts are basically identical to each other, but it is two completely separate scripts. The reason why I wanted to show you this is because as you get into more complex scripting, you may find it necessary sometimes to work on multiple scripts at the same time, or to refer to a script that you've already written as you're writing another one. And this is a handy way of being able to do that. So with that said, that's how you write a PowerShell script. Now there's one more thing that I need to quickly mention before I end this video. And that is that you may run into a situation, if you're trying this on your own, where the script just doesn't run. You may receive an error message when you attempt to run the script rather than anything happening. One of the big reasons why that happens is because of something called an execution policy.
An execution policy is a security feature that's built into PowerShell, and it's designed to prevent an attacker from being able to run a PowerShell script on your system, or to keep a user from accidentally executing a PowerShell script. And depending on what version of Windows that you're running, there may be an execution policy that's in place by default that keeps you from running PowerShell scripts. So I'm going to be talking all about execution policies in the next video. So if right now you're unable to run a script, don't worry. The next video will show you how to run that script by making a simple change to your execution policy. Hello and welcome back. In this video, I want to show you how script execution policies work. Because every once in a while, you may find that you're unable to run a script due to the execution policy that has been set on the machine. So let's take a look at what that looks like. I'm going to run one of the scripts that I created earlier called hello-world.ps1. So I'm already in my scripts folder. I'll type / hello-world.ps1. And when I do that, I get an error saying file c:/script/hello-world.ps1 cannot be loaded because running scripts is disabled on the system. And then it tells me where to go for more information. So what happened? Well, this is where execution policies come into play. Execution policies are designed to prevent scripts from running in certain situations. For example, you may have a system that contains a lot of sensitive information, and you might want to block PowerShell scripts from running on that system so that nobody can use a script for malicious purposes. Incidentally, execution policies are not foolproof because there are workarounds. So an execution policy can act as a safeguard, but it's not a 100% guarantee that nobody can launch a PowerShell-based attack against the system. So it's important to practice defense in depth. So with that said, how do we change this? How do we set this system to have an execution policy that's a bit more permissive? Well, the first thing that we need to do is to figure out what execution policy has been applied to this system. And the way that we do that is by typing get-execution policy. And you can see that right now the execution policy is set to restricted, which prevents scripts from running on the system. So we could set this to unrestricted by typing set-execution policy unrestricted, and I'll press enter. Now I see a prompt asking me if I want to change this. It says the execution policy helps protect you from scripts that you do not trust. Changing the execution policy might expose you to the security risks described in the About Execution Policies help topic and then it points to the Microsoft website. Do you want to change the execution policy? So I'll press Y for yes. And if I repeat the get execution policy commandlet, you can see that the execution policy is now set to unrestricted. And incidentally, restricted and unrestricted aren't your only options. There are some other execution policies that you can use, such as remote signed, meaning that scripts that come from a remote source, such as the internet, have to be digitally signed in order to be allowed to run. So let's go ahead and try to run our script now that the system is unrestricted. And you can see that the script runs no problem. So is that it for execution policies? Well, not quite. Because one last thing that I need to talk about with regard to execution policies is the policy scope. The policy scope determines what the policy actually applies to. So let me show you what this looks like. I'm going to type get execution policy. And then -list. And so when I do that, you can see that there are actually several items within the scope column. We have machine policy, user policy, process, current user, and local machine. So what this means is that we can bind an execution policy to various levels of the system. So if we were to set an execution policy at the machine policy scope, for example, then what that would do is it would make it so that the execution policy applies to this particular machine. So right now you can see that the unrestricted policy applies to the local machine. So in other words, that policy applies to any PowerShell scripts that are running on this machine. And the machine policy scope works in essentially the same way. We also have a user policy scope. And what that does is it allows you to bind an execution policy to a particular user. So when that user attempts to run the script, then PowerShell is going to check to see what the execution policy is for that user. We can also bind an execution policy to an individual process. So what that means is that every time you open a new PowerShell window, you're essentially launching a new process. So you can have an execution policy that applies to one PowerShell session or one PowerShell window, but not another. That's where the process scope comes into play. And then we have current user, which applies to the currently logged in user. So let's go ahead and take a look at how you would set an execution policy based on a process. So what I want to do is I want to type set execution policy. And I showed you a moment ago that when we had an execution policy of restricted, scripts weren't allowed to run on the system. So I'm going to set this back to restricted, but I'm only going to set a restricted execution policy for the process scope. So I'll type dash scope process dash execution policy restricted. And I'll press enter. And I'll press Y to accept the change. And then I'll type get dash execution policy. And we can see that it's restricted. If I were to repeat that command and then add the list parameter, we can see that the policy is restricted at the process scope level. So now let me go ahead and open up another PowerShell window, effectively launching a new process. And so from within this window, I will go ahead and type get dash execution policy. Dash list, and you can see that the execution policy at the process scope level is undefined. So what that means is that I can run scripts within one window, but not in another. So if I were to try my Hello World script in this window, it should run. And it does. But if I were to switch back over to the other window, and try running the exact same script, that script is blocked from running because we've created a restricted process scope level execution policy. And because that execution policy does exist at the process level, it affects the current PowerShell process, but not other processes that may be launched. So that's just a sample of how execution policies work in PowerShell. Hello and welcome back. In this video, I want to show you how to create functions within PowerShell. Functions are useful because they allow you to reuse code. This is particularly useful if you've got a really long and complex script. Rather than having to write the same block of code over and over again, you can write it once and then call that function as many times as you need it. Even if you don't have to reuse code, functions can be useful for making scripts a little bit easier to organize. So I'll show you how functions work as we go along throughout this video. The first thing that I'm going to do is to open up PowerShell. And then I'm going to switch over to my scripts folder. As you may recall, we created a script in one of the earlier videos called Hello World. Now that script is ridiculously simple, but I'm going to go ahead and use it to illustrate how functions work. So what I'm going to do is to make a copy of that script. And to do that, I'm going to use an old DOS command called copy. And all we have to do is enter the file name, which is helloworld.ps1. And then I have to enter the new file name. So this is what the new file or the copy of the Hello World script is going to be. So I'm going to call this helloworld3.ps1. And if I type dir, you can see that we now have a helloworld3.ps1 file. So let's go ahead and run the script just to make sure it still works. And in case you don't remember, or in case you missed one of the earlier videos, this script simply clears the screen and it displays the words Hello World. So I'll go ahead and run my Hello World 3 script. And the script does work. So now let's go ahead and incorporate a function into this script. So I'll go ahead and open up Notepad. And I'll open the hello world 3.ps1 script. So here's our code. Now, if we want to incorporate a function into the script, then the first thing that we have to do is go up to the top and enter the word function. Anytime PowerShell sees the word function, it tells PowerShell that a function is about to begin. Now, every function in PowerShell has to have a name. So I'm going to call this function display hello world. Now you'll notice that when I entered display hello world, I separated the word display and the word hello world with a dash, similar to the way that PowerShell does with its native commandlets with the verb-noun syntax. Now you don't have to do that. You can call a function anything that you want as long as it's not a reserved word. Now, what do I mean by a reserved word? Well, if you look down at the very last line, you can see that right here we have write host. That's a native PowerShell commandlet. It's the commandlet that causes text to be displayed on the screen. Write host, because that is a native PowerShell commandlet, that's a reserved word, so I couldn't call a function write host. If I did, I would get an error. As a matter of fact, let's take a look at what that looks like. I'm going to go ahead and just change this to write host. And I'll save this. And let's just run it. And when I do, I end up getting an error saying missing function body and function declaration. This is kind of PowerShell's way of saying that it's confused because I started to declare a function and then I used a PowerShell commandlet. I never gave the function a name. In actuality, I did give the function a name, but that name was a reserved word, hence the error message. So let me go ahead and minimize this. And I'm going to go ahead and go back to the name that I was using. But I never answered my original question. Why is it that I chose to use the verb-noun naming convention when I declared a function? The reason why I did this is because it is possible to create standalone functions. I'm talking about functions that exist outside of a script. And by using standalone functions, you can actually make your own PowerShell commandlets to use over and over again from any script that you want. And I'll be showing you how to do that later in this course. But just as a best practice, I like naming my functions using the verb-noun naming convention, whether they're going to be standalone or whether they're going to be specific to an individual script, just because sometimes you might start out by using a function within a single script and then later decide to break that function out and use it elsewhere. So we've entered the word function, we've given our function a name. What else do we have to do? Well, the next thing that we have to do is to use a pair of brackets. Let me go ahead and do that. So in PowerShell, anything that falls between these two brackets is considered to be a part of the function. Anything that exists outside of the brackets is considered to be a part of the main body. So right now, the script is perfectly valid. It doesn't really do anything different than what we did before, but it is a valid script. Let me go ahead and save this. And I'll switch over to PowerShell, and I'll run the script. And you can see that the script runs just fine. Now, even though we've created a function, that function doesn't actually do anything. So let's step through what we've got and take a look at how this works. So the very first line of code is our function declaration. Normally, when a PowerShell script runs, it begins by executing the very first line of code, and then it executes the second line, and then the third line, and so on and so forth. Now, in this case, things work a little bit different because when you execute the script, PowerShell sees the word function, and it knows that a function is something to be executed later on. So it will make note of the function name, but it's not going to execute this line or anything inside of the function. So PowerShell is going to look for this closing bracket right here. And this tells PowerShell that it's the end of the function. So PowerShell is going to drop down to here and begin executing code. So at that point, it sees the clear screen command, which it executes. and then it sees the right host command, which it executes, and then it reaches the end of the script. So our function doesn't do anything at this point. It's never even being executed. So let's go ahead and change that a little bit. So the next thing that I want to do is just add some space in between the two brackets, and then I'm going to move my right host hello world command into the function. And then I'm going to remove the right host hello world command from the end of the script. And let me go ahead and save my changes. So let's take a look at what happens when we run the script, and then I'll come back and step you through it. I'll go ahead and run the script. And in this case, the screen clears, but we don't see the hello world text. Now, why is that? Well, think about the way that I said that functions work. PowerShell sees the word function, and it knows that this is all code to be executed later on. So it looks for the end of the function and then begins executing. So very first and last code in the script body is clear screen. There's nothing else there. So PowerShell executes the clear screen command, and then the script ends. That's it. That's the whole thing. So what would we have to do if we wanted to call this function so that the words hello world would be displayed? Well, all we have to do is enter the name of the function. Let's go ahead and do that. The function was called display hello world. So I'm going to go ahead and add that. I'll save my script. So now when the script runs, PowerShell sees the word function. It knows that the function is code to be executed later on, so it completely ignores any code within the function. It drops down to the main script body. It clears the screen, and then it calls the function. So this function call sends PowerShell up here. It looks for this bracket because it knows that that's the start of the function block, and then it executes any code within the function, beginning with this line right here. And then it reaches this bracket. And that bracket tells PowerShell that this is the end of the function and that it should drop back to the main body at that point. So then if there were any commands right here, this is where PowerShell would pick up. So let's take a look and just verify that this script runs. I'll go ahead and save this because I can't remember if I saved it or not. And I will switch back over to PowerShell. I'll run my script. And now the words hello world are being displayed once again. So we've created a function. We've actually made that function do something. The function displays the words hello world on the screen, and we've called the function. Now there's one more thing that I want to do. I'm going to switch back over to my script, and I just want to add a few lines of code here just so that you can see exactly how this is working. So I want to add a right host command right here. And I'm going to say PowerShell is executing the function. And then I'm going to come down to my main body. I'll add a line right here saying that PowerShell is about to call the function. And then one more thing that I'm going to do is I'm going to add a couple of comments to the script. Comments are just lines of text that PowerShell ignores, and they're good for documenting your scripts. They can help to alleviate confusion. So I'm going to add a comment to the function. I'll just say, this is the function. And I'll also add a comment to the main body. Now remember, comments are completely ignored, so PowerShell doesn't do anything with them. Okay, so I've added a number of different lines to this script. Let's take a look at how this works. So remember, normally when you execute a PowerShell script, the script executes sequentially, starting with the first line, the second line, and so on. So when you execute this script, the first thing that PowerShell is going to do is start with the first line, but it sees that the first line is a function. So it knows to ignore anything within the function. It makes note of the function name, but it ignores the function contents. So it sees that the function code begins here and it ends here. Next, we reach the main script body. This is where PowerShell actually begins executing. Now, the first line in the main body right here is a comment, so PowerShell ignores that. So then it gets to this line right here. The main body is executing. So we'll actually see the words "the main body is executing" appear on screen. Next, PowerShell clears the screen, and I'm actually going to get rid of this line just because I don't want the screen to clear. I want you to be able to see how this executes. So then the next line of code is right host PowerShell is about to call the function. So you're going to see a line of text appear on the screen indicating that PowerShell is still in the main body, but it hasn't called the function yet, but it's about to call the function. So then the third line of code is display hello world. This tells PowerShell that you want to execute the function. And that function is named display hello world. So at that point, the script is going to jump up here to the function because the function is called display hello world. It's going to go to this line first, which is a comment, so that gets completely ignored. And then it goes to this line, which will display the text on the screen indicating that PowerShell is executing the function. At that point, it moves on to this line, and we're going to see text displayed on the screen that says hello world. Then PowerShell picks up where it left off in the main body because it's reached the end of the function as signaled by this bracket right here. So at that point, PowerShell is going to execute this line of code right here, because when a function ends, the script goes back to the main body and picks up where it left off. So the function call, this line of code right here, was the last line that got executed, which means that PowerShell is going to pick up right here when it returns from the function. So we're going to see the words "the script has returned to the main body" displayed on the screen. So let me save my changes to the script. And let's go ahead and run the script. So here we can see the main body is executing. PowerShell is about to call the function. PowerShell is executing the function. Then we have hello world, because that's what our function was really designed to do, was to display the words hello world on the screen. And then we see a line indicating that the script has returned to the main body. So hopefully that illustrates how the function is actually working, where the function is being called, and what happens when the function completes and the script begins processing the main body once again. So that's how functions work in PowerShell. Every once in a while, you may run into a situation in which you need to hide an error message in PowerShell. Now, I'm not talking about covering up a buggy script so that nobody sees that it doesn't work. What I'm talking about is a script that has been tested and is proven to work, and it's all good, but there's a chance that bad user input or perhaps an unanticipated data set might cause an issue that is unforeseen, in which case you want to hide an error message. This is particularly true if it's a script that you're going to be giving to somebody else to run, and you don't want to get phone calls over error messages that really aren't all that important. So in this video, I want to show you how to hide an error message in PowerShell. So before I do, let me show you what I've done to set up for this particular demo. I'm going to open up File Explorer, and I'll go to this PC and my C drive, and you can see that I've created a folder called Data. And within that data folder, I've created 5 more data folders: Data 1, Data 2, Data 3, Data 4, and Data 5. And the contents of these folders really aren't all that important. All I did was simply copy some of the files out of the Windows System 32 folder. I'm just using these files so that I have something in the data folder. The actual contents aren't important. What is important is that I've gone into the folder called Data 3 and I've revoked all of the rights. So it's impossible to open this folder. If I click on it, I get an error message. So this is where my error that I'm going to introduce in the next demo is going to come into play. I'm going to try to look at the contents of this folder, but the appropriate permissions don't exist, so I'm going to get an error message. So that's how I'm going to demonstrate the error suppression technique that I'm about to show you. So let me go ahead and close out File Explorer, and I'll open up PowerShell. So what I want to do now is switch to my data folder. I'll type cd \, and then cd data, and that's going to put me in my data folder. And if I type dir, I can see the contents of that folder. So you can see the data 1, data 2, data 3, data 4, and data 5 folders that I created earlier. Now, one thing that I want to point out while I'm in here that's a little bit off topic. You'll notice that I use the dir command to display the contents of the data folder, which is totally fine. As I discussed in the very first video in this course, dir is a leftover from the days of DOS. And most of the old DOS commands are supported in PowerShell, at least in some way. But there's a limit to the extent to which these commands are supported. Let me give you an example. Back in the days of DOS, if you were to enter the dir command and then append /s, then that would show you the current directory, plus it would show you the contents of any subfolders. But that doesn't work in PowerShell. If I were to type that command and press enter, I would get an error. So PowerShell supports the dir command in its native form, but it doesn't support any parameters with it. So how do we take a look at the contents of these subfolders? Well, what we need to do is use the getChildItem commandlet. That's a native PowerShell commandlet that does basically the same thing as dir. I press enter. You can see that the getChildItem commandlet produces the same output as the dir command. And the reason for that is that the dir command is an alias to the getChildItem commandlet. So essentially they're the same command. But what if we want to look at the contents of the subfolders? Well, what we need to do is to append the recurse parameter. Let me show you what that looks like. The recurse parameter tells PowerShell that we want to look at the current folder, but we also want to look at the contents of all of the subfolders. So I'll go ahead and press enter, and you can see the output. Now, the interesting thing here is that PowerShell did produce an error. That error may have flashed across the screen a little too quickly to see, but it did indeed produce an error. So how do we know that? Well, there are a couple of ways that we can tell. The most obvious is to just scroll up to the top, and you can see the error right here. So here you can see the contents of the data 2 folder, and then we have an error message, access to the path, data 3 is denied, and then we see data 4 and data 5. Another way that we can tell that there was an error is by using the error variable. Now in PowerShell, there are certain reserved variables that are created by default by Windows, and $error is one of those variables. It will show you errors that have occurred. Let me show you what this looks like. If I press enter, you can see the most recent error message. So we have access to the path c:/data/data3 is denied, and then it goes on and explains that there was an error that this path doesn't exist. And the reason it says that it doesn't exist is because the necessary permissions were not in place. So what can we do about this? Well, let me go ahead and minimize this. And I want to open up a web browser because there's something I want to show you. So I'm going to go to Google. And I'm going to type getChildItem. And what you see here is that Microsoft actually maintains a web page for every native PowerShell commandlet. So if you ever need help with the syntax of a particular commandlet, you can simply search on that commandlet and you'll come to a page just like this one. So these pages are basically used to show you the syntax of the various commandlets. Now here's what I wanted to show you. If you look at this section right here where my mouse pointer is, you can see the various parameters that work with the getChildItem commandlet. For example, here's the recurse parameter that we used a moment ago to look at the contents of the subfolders. So the vast majority of these parameters are specific to the getChildItem commandlet. There might be other commandlets that use similarly named parameters, but these aren't parameters that are supported across the board by every conceivable PowerShell commandlet. Now, having said that, if you look at the very bottom, we have something called common parameters. Now, common parameters refer to parameters that more or less are universally supported by the native PowerShell commandlets. There might be a couple of commandlets out there that don't support the common parameters, but by and large, most do. So these are parameters that you can append to almost any PowerShell commandlet and use on an as-needed basis. So what do these common parameters include? Well, let me open up another tab here. And we'll go to the common parameters name screen. So here we have a list of all of the common parameters, starting with confirm, and then debug, and then we have things like error action, error variable, out buffer, out variables, pipeline variables, and so on and so forth. Now, the one that we're really interested in is error action. Error action allows us to tell PowerShell what to do if it happens to receive an error while it's running a commandlet. So let me show you how error action works. Let me go ahead and close out the web browser and switch back to PowerShell. And I'll go ahead and clear the screen just to make it a little bit neater. Now, when we ran the getChildItem commandlet earlier, PowerShell displayed an error message, but it kept on going. So let me go ahead and repeat that command. So you saw that an error message was indeed produced, but PowerShell didn't stop when it got to the error message. It just kept on going. Now, that's the default behavior, and that corresponds to an error action called continue. Now, we could instead use an error action called stop. So the way that I would do that is repeat the command that I just entered, and then I'll add dash error action, and then stop. Now, when I run this command, what's going to happen is that PowerShell will execute the getChildItem commandlet and begin looking at the contents of the subfolders. But when it hits that error, then it's going to put the brakes on the operation and bring everything to a stop. It's not going to continue beyond the error. So here's what that looks like. So you can see as soon as PowerShell hit that error, it brought everything to a stop. Sometimes that's the desired behavior. Now, if we wanted to put everything back to the way that it was, then what we would do is repeat that command and change stop to continue. And you can see now that everything works as it did before. The error is still there, but PowerShell more or less ignores the error and continues. Now, stop and continue aren't the only options. Another option is inquire. We could simply ask the person who's running a particular script what they want to do in response to an error. So let me show you what that looks like. I'll change continue to inquire. And this time when PowerShell hits the error, we get an error message even though it's not in red. It says access to the path C:/data/data3 is denied. And then we're asked what we want to do. We can hit yes to continue, yes to all, H to halt the command, S to suspend. I'm just going to press A for all. I'll press enter, and the command continues. Now, another option is to silently continue. I'll change inquire to silently continue. And I'll press enter. And this time we don't see the error message. So let me scroll up to the top and show you what happened. So here's my command, getChildItem-recurse-error action silently continue. And we looked at the contents of the data folder. Then we moved on to data 1, and then data 2. And then we jumped from data 2 to data 4. And then we looked at data 5, and then the command ended. So data 3 completely got skipped. Now, in reality, it wasn't actually skipped. It's just that PowerShell tried to query the data 3 folder. It got an error message, and it hid that error message so that we wouldn't see it. And then there's one more option that we can use, and that's called ignore. And if I press enter, we see that the output is exactly the same as silently continue. So what's the difference between ignore and silently continue? Well, remember that error variable that I showed you earlier, $error?
Well, if you choose to ignore, then the error message doesn't get written to the error variable. If you choose silently continue, then the error message does get written to that variable. So that's how that works. Let me go ahead and clear the screen. And there's one more thing that I want to show you. Now, when we've been using the common parameters and we've set an error action to stop or continue or silently continue or whatever, that's specific to one command. Now, you may end up in a situation where you're writing a large script and you find that you're having to append error actions to a lot of different commands. What you can do instead is to use one of those reserved variables that I was talking about earlier. This variable is called $error action preferences. It's a long variable name for sure. PowerShell allows you to perform math simply by typing in an arithmetic expression. So for example, if you wanted to find out 2 plus 2, you could type 2 plus 2 and press enter and you would get a result of 4. So with that said, let's try a division by 0. In math, you can't divide by 0. On any calculator, any computer program, that will produce an error. So if I were to say 20 divided by 0, I would get an error message. And you can see PowerShell did indeed give me an error message saying that there was an attempt to divide by 0. Now, let's go ahead and try to suppress this error. So I'm going to type 20 divided by 0, and then space dash error action. Silently continue. And I'll press enter. And when I do, we receive an error message. Now, why is that? Well, think back to what I showed you earlier. Error action was a common parameter, and common parameters are associated with PowerShell commandlets. When I enter a direct mathematical expression like 20 divided by 0, I'm not using a PowerShell commandlet. And because I'm not using a commandlet, I can't use any of those common parameters. So what that means is that a suppression technique such as setting error action to silently continue isn't going to work because I didn't use a commandlet. But the nice thing about the error action preferences variable is that when I set that, it will suppress errors regardless of whether they came from a commandlet or not. So let's take a look at that. I'm going to go ahead and type $. Actually, before I do that, let me go ahead and type get-child item -recurse and press enter. And you can see that the error message is indeed being displayed when I do that because I'm not using the error action, so I'm not telling PowerShell to suppress an error. So now that I've done that, let me go ahead and type $error action preferences. And I'm going to set that equal to silently continue. So now that variable is set. So if I repeat my get-child-item-recurse command, remember this generated an error message a moment ago. If I press enter, oh, and it looks like I made a typo. So you'll notice that I typed get error action preferences with an S on the end. It should have been $error action preference, not preferences. So let me try that again. That's the reason why we got the error message right there, is because I did make that typo. So let's try that again. I'm going to set error action preference, not preferences, to silently continue. I'll press enter, and now we'll repeat the get-child-item-recurse command. And this time we can see that the error is suppressed. So we have the data2 folder, data3 is hidden, and we move on to data4. Now let's also try that 20 divided by 0. And nothing happens because PowerShell is suppressing the error. And that's done because I set the error action preference command to silently continue. So that's how you go about suppressing an error in PowerShell. In this video, I want to show you how to do math in PowerShell. Now, PowerShell makes it relatively easy to do math, but the technique that you'll have to use is going to vary depending on what type of math you're trying to do. So let me show you how this works. Now, the nice thing about PowerShell is that if you're just doing simple addition or some other arithmetic operation, then you can enter whatever you need directly at the command line. Let me show you an example. Let's suppose, for example, that I wanted to add 2 plus 2.
Well, all I would have to do is type 2 plus 2 right on the command line, press enter, and I get an answer of 4. I'll show you what that looks like. I'll type 2 plus 2, I press enter, and I get my answer of 4. And if I were to include this in a script, then I could do this in exactly the same way. I would simply place 2 plus 2 on a line within the script, and I would get an answer of 4, or I could map the result to a variable, or there are any number of different things that I could do. Now, the same basic technique also applies to other arithmetic operations. So let's take a look at a few. Let's suppose that I want to do subtraction. All I have to do is enter two numbers separated by a minus sign and press enter. I'll show you an example. I'll type 10 minus 5. I'll press enter, and I get an answer of 5. Simple enough. And things work the same way for multiplication. If, for example, I wanted to type 3 times 4, I'll press enter, and I get an answer of 12. And of course, division works the same way. I could type 12 divided by 3 and press enter, and I get an answer of 4. So that's how basic arithmetic is done in PowerShell. And in case you're wondering, PowerShell does respect order of operations. So if, for example, I were to type something like 2 plus parentheses 3 times 3, close parentheses, and press enter, then I get an answer of 11. So order of operations states that you have to perform any math that's in parentheses first, and then from there you have to do multiplication and division, and then after that's done, then you can perform addition and subtraction. And if you were to vary from that order of operations, then you would get a different answer. So PowerShell does indeed respect order of operations. In this case, it's going to do 3 times 3 first because 3 times 3 is in parentheses, plus its multiplication. So that gives you an answer of 9, and then you add 2 to that, giving you your answer of 11. So PowerShell does respect order of operations. Now, if you want to do anything more advanced than this, you have to use a completely different technique. Let's suppose, for example, that I wanted to calculate 2 to the third power. If I were to type 2, and then the exponent sign, and then 3, and press enter, well, I get an error because PowerShell doesn't know how to do that. Now, there are a couple of things that I could do to work around this. One thing that I could do is just work this out through arithmetic. 2 to the third power is really just multiplying 2 by itself 3 times. So I could do something like 2 times 2 times 2, and that would give me an answer. So that fulfills 2 to the third power, but that's really a roundabout way of getting the answer. There is a better way of doing things. The trick is that you have to delve into the .NET framework. Now, if that sounds like some of the scary developer territory, don't worry, because this is a lot easier to do than what it sounds like. Let me show you how this works. I'm going to go ahead and clear the screen. And what we need to do is call a .NET class called system.math. Now, even though this class's name is system.math, it's usually just referred to as math. So it's the math class. So the way that we call a .NET class is by entering a bracket, followed by the class name, in this case math, and a close bracket, and then 2 colons. And that tells PowerShell that we want to call a .NET class rather than calling a PowerShell commandlet. So from there, all we have to do is enter the name of the class that we want to call, followed by the mathematical operation that we want to perform. So let me give you an example. Let's suppose that I wanted to find the square root of 64. All I would have to do is type sqrt, open parentheses, 64, close parentheses, and press enter. And I get my answer of 8. So by using that simple command, I've called the .NET class of math, and I've told .NET that I want to find the square root of a number. Now this raises an important question. How did I know that sqrt was the command to find the square root? Well, anytime that you're calling a .NET class, that class is made up of what's known as methods. In this case, those methods are mathematical operations. For example, sqrt or square root is a method within the .NET class known as math. So what we can do is tell .NET to give us a name of the methods that are included in this particular class, so that way we know what we can do. Let me show you how this works. What I'm going to do is enter the math class again. And then from there, rather than calling a specific method, I'm going to type a period, and then I'm going to type get methods. Now, in PowerShell, commandlets are made up of verb-noun combinations, and they're separated by a hyphen. But remember, in this case, we're calling a .NET class. So because we're working with .NET rather than native PowerShell, there's no hyphen involved. So it's just get methods. And so I need to end that with a double parenthesis, and I'll press enter. And I get this great big long list of all of the methods that are included in that class. And you can see that there is just an overwhelming amount of information here. So this isn't super helpful to us. So how can we narrow this down a little bit? Well, one thing that we can do is to take a look at just the method names. And for that, we can actually use native PowerShell. Let me show you how this works. I'm going to repeat the command that I just entered, and then I'm going to enter the pipe symbol. Remember, in PowerShell, the pipe symbol is used to separate two commands. Now, the first half of this command refers to .NET, but the second half, I'm just going to use native PowerShell, and I'm going to use select object, and then I'm going to choose name. So by doing this, I'll get a list of the names of all of the methods within the math class. Now, when I enter that, I get a pretty long list, and in some cases, you may find that there's some repeats on the list. So what I find to be helpful is to append the unique parameter to the end of the command that I just showed you. I'll go ahead and repeat the command, and I'll append -unique. And that tells PowerShell that we only want to see the unique methods within the class. And so there's our list of results. So these are all of the different mathematical functions that we can perform based on the math class that's a part of the .NET framework. I'll go ahead and scroll up just a little bit so that you can see some of these. So the basic idea here is that you can call any one of these methods by using the same technique that I showed you at the beginning when I showed you how to find a square root. So let's take a look at another example. Right here we have a method called round. So this allows us to round a number. Let's take a look at how we would use that. Now earlier I showed you how to find the square root of a number by typing bracket math bracket colon, and then we called the square root method, and then we appended a number. I think I used 64. If I press enter, I get the result. So rounding works in the exact same way. What I would do is replace square root with round, and then give it a number that I want to round. And then I press enter, and that number gets rounded to the nearest whole number. So that's just a quick example of how you can perform a mathematical function in PowerShell by calling a .NET class. Hello and welcome back. In this video, I'm going to be talking about PowerShell comparison operators. Now, what are comparison operators? Well, as the name implies, comparison operators are operators that you can use to compare two values to one another. For example, you could use comparison operators to find out if two values are equal, if they're not equal, if they're similar. So there's a lot that you can do with comparison operators. Now, I'm not going to be talking about every single comparison operator in existence because, quite frankly, there are a lot of them and some of them are relatively obscure. But what I am going to do is I'm going to be sure to cover all of the ones that you're likely to encounter in the real world. So let's get started by talking about equality comparison operators, starting with equals. Now, equals, or -eq, is used to find out if two values are equal to one another. So let's take a look at how this works. I'm going to begin by declaring two variables. I'll start with $A, and I'll set that equal to 5. And I'll create another variable called $B, and I'll set that equal to 8. So I've created two variables, and let's just check the value of those variables. I'll type $A, and that's equal to 5, and I'll type $B, and that's equal to 8. So what if we wanted to find out if $A was equal to $B? They're not equal, but what if we wanted to find out if they were? Well, it's very important to remember that there's a difference between the equal sign and -eq, which is the comparison operator for equals. Because if I were to just say $A equals $B, well then that's an assignment operator. what I would actually be doing is setting $A equal to $B. So in this case, $B is 8, $A is 5. But if I were to run this, it would make $A equal to 8. As a matter of fact, let's go ahead and do that. So now if I were to check the value of A, $A is equal to 8. And if I were to check the value of $B, $B is equal to 8 because I told PowerShell to make $A equal to $B. But that's not what the equality comparison operator is. The equality comparison operator checks to see if two values are equal. It doesn't make them equal. So there's a big difference there. So let me go ahead and set $A back to 5. And I'm just choosing arbitrary values. These numbers are meaningless. And we'll check and make sure that $A does indeed equal 5. And it does. So what if I wanted to find out if $A was equal to $B? Well, the way that we would do that is by typing $A -eq for equals, and then $B. And if I press enter, I get a value of false because $A is not equal to $B. Remember, $A is equal to 5, $B is equal to 8, and 5 does not equal 8. So that's why we get an output of false. Now, in PowerShell, you can actually take action on these comparison operators. I'm not going to show you a whole lot in this video about how to take action on a comparison operator because that's something that we're going to be doing extensively in some of the later videos, but I want to at least give you a taste of how this works. So what I can do is I can build an if statement based on a comparison operator. So remember, right now, $A equals 5, $B equals 8. So let's suppose that I was creating a script and I needed a line in there to find out if these two values were equal. I could do something like if, and then parentheses, $A -eq for equals, $B. Then I have to provide something for the statement to do if those two values are equal. And I would enclose that in a bracket. And I would say right host. And really, you could make this action anything. I'm just using right host because it's something simple. Quotation mark, they are the same. And then bracket. And if I press enter, I get nothing. And the reason why I got nothing is because these two values are not the same. But let's go ahead and make them the same. I'll type $A equals 8. And then I'll rerun that statement. Now PowerShell tells me that those values are the same because they are the same. $A is 8, $B is 8. Now, just as PowerShell has a comparison operator that you can use to find out if two values are equal, there's also a comparison operator that you can use to find out if two values are not equal to one another. In other words, if those two values are different. And that operator is -ne for not equals. So let's take a look at how this works. I'll type $A -ne $B, and I get a value of false. So let's try this in the context of a statement like what I used a moment ago. So just as a reminder, $A is currently 8, $B is also currently 8, so the values are equal. So let's go ahead and retype that if statement that we had a moment ago, but I want to change equal to not equal. And we also need to change the text, otherwise this won't make sense. So I'm just going to change this to they are different. And when I press enter, I get no results because right now $A and $B are equal. I would only get a result if the values were different from one another. So let me go ahead and set $A to something different. And then I'll rerun that statement. And now I get an indication that these two values are different. So that's how the not equal operator works. So another operator is greater than. And the way that greater than works is it compares two values to find out if one is greater than the other. So remember, right now, $A is set to 5, $B is set to 8. So B is greater than A. So what I could do is I could say $A -GT $B, and when I press enter, I get a value of false because B is the bigger of the two. If I were to rearrange these terms and type $B -GT $A, then I get a value of true because $B is greater than $A. And just as we can use a greater than operator, we can also use a less than operator. and that's LT, and it works exactly the same way as greater than. I just changed G to L. So now I'm checking to see if B is less than A, which is false. And if I rearrange this, I can check to see if $A is less than $B, and I press enter, and I get true, because $A is 5, which is less than $B, which is 8. And then there's another variation on this. We can check to see if values are greater than or equal to one another. And the way that that works is, rather than using GT for greater than, I just use GE for greater than or equal to. So we could say $A dash GE $B. I get a value of false. And if I reverse this, $B dash GE $A, I get a value of true because B is greater than A. And as you've probably already guessed, if these values were the same, then I would also get a value of true. So I'll set $A equal to 8, and I'll repeat that command, and I get a value of true. And if I were to reverse these terms, I also get a result of true because the two values are equal to one another. And as you've probably already guessed, we also have a less than or equal to operator. And that works exactly the same way. We use LE rather than GE, so LE for less than or equal to. And I should get a result of true when I press enter because these two values are equal, which I do. And if I set $A back to 5, and I run the comparison again, I get a value of true because A is 5, which is less than B, which is 8. And if I were to reverse these terms, I should get a value of false because $B is 8, $A is 5, and 8 is greater than 5, not less than or equal to 5. So that's how the equality operators work. Now, PowerShell has another type of comparison operator called a matching operator. And matching operators tend to deal with string data, whereas equality operators deal more with number data. There are situations in which you can use string data with equality operators, and you'll definitely see some examples of that as we go through the course. But for the most part, equality operators are used for numerical data, and matching operators are used for string data. So what kinds of matching operators are there? Well, let me go ahead and clear the screen. And I want to get started by talking about a matching operator called like. Now, what like does is it checks for string matches to certain patterns. So let me show you how this works. I'm going to type get-process and press enter. And when I do, I get a list of all of the processes that are running on this machine. So what if I wanted to pick a particular process out of the list, but I don't know exactly what that process is? Say, for example, I wanted to pick out the PowerShell process. And I know that the listing for PowerShell is sort of kind of like PowerShell. It might even say PowerShell, or it could be some variation of PowerShell. Well, this is where a matching comparison operator would come into play, because I could look for something that looks similar to the word PowerShell. Here's how it works. I'll type get-process, and then I'll use the pipe symbol, and I'll type where-object, and then bracket $_ dot process name. And incidentally, process name is the name of the column that contains the process name. If I scroll up, you can see this column right here called process name. So that's where that came from in my command. At any rate, I'll type $_ dot process name, and then -like, that's my comparison operator, and then quotation mark, asterisk, PowerShell, asterisk, quotation mark, and bracket. Now in PowerShell, anytime that you see an asterisk, that's a wildcard. So what I'm doing is I'm searching for processes that contain the word PowerShell. And the asterisk before and after PowerShell in this command mean that I don't really care what comes before PowerShell or after PowerShell. I just completely ignore that. So any process that has PowerShell in its name, regardless of whether that's the full name or if it's a partial name, I'll get a result on that. So if I press enter, I see the PowerShell process. So that's how a like operator works. We also have a not like operator. So let me go ahead and repeat this command. And what I'm going to do is I'm going to change like to not like. And when I press enter, what I should get is a list of every process except for the PowerShell process. And that's what I end up getting. Now, another matching operator that we can use is called match. And match is very, very similar to like, but the big difference is that like tends to work a little bit better with wildcards, in other words, the asterisk. So if you're not entirely sure of what you're looking for, you're generally better off using like. But if you know the exact value or something really close to the exact value, then you can probably get away with using match. So let me show you how this works. I'm going to type $A equals quotes hello world. And then what I'm going to do is I'm going to type $A and then dash match, and then quotation marks world. And I'll press enter, and I get a value of true. And the reason why I got that is because $A contained a string that said hello world. So then in the second command that I typed, what I did was I used the match operator to check to see if the word world appeared in the string that was assigned to the variable $A. And $A contains a string that says hello world, and world is a part of that. And so my result ended up being true. Now we also have a not match operator. So if I were to type the same command all over again, but change this to not match, then I would get false, because world does appear in the string that's assigned to $A. So we have a match. So if I'm checking for not match, then I get a value of false. Now, if I were to switch this up a little bit and change world to worlds, then that value would change to true, because the word worlds doesn't appear in the string hello world. We also have something in PowerShell called a replacement operator. A replacement operator can be very handy if you're writing a script that does a lot of text manipulation, because it allows you to take a value and replace it with something else. So let's take a look at how this works. I'll go ahead and clear the screen. And what I'm going to do is I'm going to create a variable called $A, and I'm going to set that variable equal to hello world. I'll press enter, and let's confirm the contents of the variable. So $A does indeed equal hello world. Now, let's say that I wanted to change this from hello world to hello everyone. What I can do is I can type $A, that's the variable that contains the string hello world, and then dash replace, quotation mark world, quotation mark, comma, quotation mark everyone, quotation mark. So if I press enter, you see the string hello everyone. Now, there's one interesting thing about this that you need to know. If I type $A to output the contents of my variable, you can see that $A still equals hello world. We haven't changed the contents of the variable. All we did was produce a string in which we replaced the word world with the word everyone. So what if we wanted to assign this to a variable? Well, we would have to use a variation of this command. And the way that we would do that is by setting up another variable. I'll say $B equals $A dash replace world, comma, everyone. And so if I output the contents of these variables, $A still equals hello world. $B equals hello everyone. So that's how a replacement operator works. And then in PowerShell, we also have something called a containment operator. A containment operator checks to see if a collection contains a value. But the thing about it is the value that you're looking for has to be exact. So let's take a look at how this works. I'm going to create a variable $A, and I'm going to set $A equal to the word PowerShell. And we'll check the contents of the variable. So $A does indeed equal PowerShell. So now let's take a look at the contains operator. I'll type $A dash contains, and let's see if it contains the word shell. And we get a result of false. And the reason for that goes back to what I said a moment ago, that whatever it is you're searching for has to be exact. Now, there's one more type of operator that I wanted to mention, and that's not contains. So if I change contains to not contains, then my result should be true. But let's take things a step further. Let's change shell to PowerShell. So now we're checking $A, which contains the word PowerShell, not contains PowerShell. So I should get a result of false, which I did. So then if I repeat this command one more time and I change not contains back to contains, I should get a result of true because $A, which is the word PowerShell, does indeed contain PowerShell. And my result is true. So that's how comparison operators work in PowerShell. Hello and welcome back. In this video, I want to talk about something called assignment operators. Now, you've already seen an example of an assignment operator in the last video and probably in some of the earlier videos as well. An assignment operator is really just an operator that assigns a value, typically to a variable. So you've seen things like $A equals 5. And what we've done there is we've actually done an assignment. We've assigned the value of 5 to a variable called $A. So that's, believe it or not, an example of an assignment operator. But there are other ways that we can assign values to variables besides just using the equal sign. There are actually several of them. So in this video, I want to show you some of the options that exist for assigning values to variables and for manipulating values through assignments. So let's go ahead and get started. As you see, I set the value of $A equal to 5. And if I type $A, we can see that it contains 5. I'm going to go ahead and define another variable. I'll call this one $B. And I'm going to set $B equal to a text string. I'll make it say hello. And if I output the value of $B, it does indeed say hello. So I've assigned two variables, $A and $B. $A contains a numeric value of 5. $B contains a text string that says hello. So when I created $A and $B, I used an assignment operator of equals. $A equals 5, $B equals hello. Now, as I mentioned a moment ago, equals isn't the only assignment operator that we can use. Another assignment operator that we can use is plus equals. Now, plus equals works a little bit different depending on whether you're dealing with text or whether you're dealing with something numeric. In the case of something numeric, then plus equals increases the value contained in a variable by an amount that's specified. So let's take a look at how that works. As I mentioned a moment ago, we created a variable called $A, and it's a numeric variable. It holds a value of 5 right now. So what we can do is we can say $A and then plus equals, and then any value that we want to add to A. So if we wanted to add 5 to the existing value, I could type 5 and I'll press enter. And now if I type $A is equal to 10 because $A started out with a value of 5. And then I said $A plus equals 5, which adds another 5 to the 5 that was already there. And I ended up with a value of 10. So that's how plus equals works if we're dealing with numerical data. Now, if we're dealing with text strings, then what plus equals does is whatever you specify gets appended to the end of an existing string. So let's take a look at how that works. As you'll recall, I created a variable called $B, and right now $B holds a value of hello. So let's say that I wanted to change hello into hello world. What I could do is I could say $B plus equals quotation mark space world quotation mark and press enter. Now if I type $B equals hello world. We started with hello and then we said $B plus equal world, and that changed the variable $B into hello world. Now we can actually do the same thing with minus equals, but there is a caveat. Minus equals doesn't work with text strings. It only works with numbers. So a moment ago, I showed you how to use plus equals to add a value to a variable. We can use minus equals to subtract a value from a variable. So let's go back to the $A variable that we set up earlier. I'll type $A, and it currently has a value of 10. So what I can do is I can say $A minus equals And let's subtract 3. So I'll type 3 and press enter. And now if I type $A, we get a value of 7 because we've subtracted 3 from 10. We can also do the same thing with multiplication. Now, the multiplication operator works a little bit differently depending on whether you're working with numerical data or string data. I'll show you some examples of both. So let's start out by taking a look at $A. $A currently equals 7. So if we wanted to multiply $A by 2 for whatever reason, we could type $A asterisk equals, and asterisk is used for multiplication in this case, and then 2, and when I press enter, then what's going to happen is the value that's contained in $A, which is 7, is going to be multiplied by 2. So if I type $A and press enter, we should get 14, because we multiplied 7 by 2 to give us 14. Now, I mentioned a moment ago that this particular operator works in kind of a strange way when we start dealing with text data. So let's take a look at how that works. I'm going to go ahead and clear the screen just to give myself a little more room. And we've got a text string that we already set up. It's assigned to a variable called $B. If I type $B and press enter, you can see that $B contains the string hello world. Now, when we start talking about multiplication assignment operators with regard to string data, what we're really doing is we're telling PowerShell that we want to repeat the string. So let me show you how this works. $B is equal to hello world, and let's say that I wanted to repeat that one time. What I can do is I can say $B asterisk equals and then 2. And what that tells PowerShell is that I want to see the words hello world twice. I'll press enter, and then let's output the value of $B. And you can see hello world, hello world. And the reason why the word world is jammed together with hello is simply because there isn't a space after world or before hello. But PowerShell has changed $B so that the string that was in there was repeated. So we now have 2 instances of hello world. There is also a division assignment operator. And division assignment operators work in roughly the same way as multiplication assignment operators, but the difference is that they don't work with text strings. They only work with numerical data. So let's take a look at how this works. If I type $A, $A is currently equal to 14. Let's suppose that we want to divide $A by 7, which would give us a value of 2. The way that we would do that is by typing $A slash equals, slash is the division sign, and then 7. So I'm telling PowerShell I want to divide $A by 7. I'll press enter, and then if I type $A, I should get a value of 2, which I do. Now let me show you another assignment operator. I'm going to go ahead and clear the screen. And what I'm going to do now is I'm going to assign a new value to A. I'm going to set A equal to 10. I'll type $A equals 10. And then what I'm going to do is I'm going to type $A and then percentage equal followed by 3. I'll press enter. And let's take a look at what's in $A. I get a value of 1. Now, why in the world did that happen? Well, if you think about it, 10 divided by 3 is 3.3333 and so on. But what we did here is we divided 10 by 3, and that gave us 3 with a remainder of 1. So what we've actually done is we've assigned the remainder to $A. So whenever you use percentage equals, that's saying to PowerShell that you want to divide the variable by the specified value and then assign the remainder to the variable. And then one more thing that we can do is that we can tell PowerShell that whatever number is in a variable, we want to increase that by 1 or decrease it by 1. And that's really simple to do. So let's take a look at how this works. I'll type $A, and $A is currently 1. If I wanted to increase that by 1, I could type $A plus plus. I'll press enter, and then if we look at the value, $A is now equal to 2. If I wanted to do that again, I could type $A plus plus, and $A is now 3. We'll do it one more time. $A plus plus, and $A is now 4. And the same thing works with decreasing the variable's value. What I could do is I could type $A minus minus, and then if I look at the value, $A has decreased by 1 and is now 3. So those are the assignment operators that exist in PowerShell. Hello and welcome back. In this video, I want to show you how logical operators work within PowerShell. Logical operators consist of things like AND, OR, XOR, NOT, and that sort of thing. So let's take a look at how this works. I want to begin by talking about the AND logical operator. The AND logical operator is used to determine whether two separate conditions are true or not. So let's take a look at how this works. What I'm going to do is type parenthesis 1 -eq 1. And I talked about -eq a couple of videos back. That's an equals comparison. So I'm checking to see if 1 equals 1. And if I were to just press enter right now, then PowerShell should evaluate the statement and come back with true, which it does. Then I'm also going to check to see if 1 is equal to 2. And I should get a value of false returned because 1 does not equal 2. So let's take a look at the AND operator. What I'm going to do is repeat the same two statements that I just did. 1 equals 1. But I'm going to separate the two statements by -and. So I have 1 equals 1 and 1 equals 2. So I'm asking PowerShell if these two statements are true. Now, in order for me to get a value of true returned from evaluating this expression, both statements would have to be correct. The first statement would have to be correct, and the second statement would have to be correct. Now, in this case, my first statement is 1 equals 1, which is correct. Now, my second statement is 1 equals 2, which is incorrect. Now, because both statements have to be correct in order to get a value of true returned, I'm going to get false when I press enter. And indeed I do. Now, if I were to repeat this statement and change this 1 to 2, now both statements are true. 1 does equal 1, and 2 does indeed equal 2. So if I press enter, I should get a value of true because both statements are true. Now, as I go throughout this video, I'm just going to primarily be using numerical comparisons similar to what you've seen. But one thing that I do want to back up and mention is that you're not limited to working just with numbers. You can work with variables, and you can even work with string variables if you want to. Well, let me just show you a quick example of that. And then for the other types of operators that I'm going to talk about, I'm going to just stick to using numbers like what I've done here. But let's just go ahead and do a quick example of string variables. So I'll type $A equals, I'll set this equal to hello world. And we'll set up another variable called $B, and we'll set this one equal to PowerShell. So let's just check the contents of the variables. $A is hello world. $B is PowerShell. So let's repeat what we just did, but let's use these variables instead of using numbers. So I'll type open parentheses, $A dash EQ, $A dash and, $B dash EQ, $B. And I should get a value of true because the contents of $A are obviously equal to the contents of $A, and the contents of $B are equal to the contents of $B. It's the same variable. And indeed, I do get a value of true. Now, if I were to change one of these and check to see if $B was equal to $A, I'm going to get false because one of the two conditions here is going to be false. B does not equal A. Therefore, one statement is false. And because we're using an AND operator, the whole thing is going to be false. And indeed, we do get a value of false. So what happens if we set these two string variables to be the same thing? So $A now says PowerShell, $B also says PowerShell. So let's repeat this. So now we're checking to see if $A equals $A, which it does because we're comparing a variable to itself. And then we're also checking to see if $B equals $A. Those are also the same. So I should get a result of true. And I do. So that's how AND works. As I mentioned, I'm not going to be spending a lot of time on string comparisons throughout this video. I just wanted to show you that all of these operators that I'm going to be talking about can be used with numbers, but they can also be used with strings and with variables. So with that said, let me go ahead and clear the screen. And I want to turn my attention to another logical operator called OR. So let's go ahead and do the same thing that we did earlier. So I'm just going to type the same thing that I did earlier, parentheses 1 -eq 1, close parentheses. And instead of typing and like I did earlier, I'm going to replace and with or. One equals 2, close parentheses. So what are we doing here? Well, just like before, we're evaluating two conditions. The first of those conditions is does 1 equal 1? And the second of those conditions is does 1 equal 2? Now, in order for or to be satisfied, either one of these can be true. So they don't both have to be true. I'll go ahead and press enter, and I should get a value of true. And the reason why I got that is because 1 does indeed equal 1. Now, obviously, the second condition, 1 equals 2, is false. But when you use or, only one of the statements has to be true. They don't both have to be true. So because of one of the statements, 1 equals 1 was true, I get a result of true. Now, if I were to change this to 2 equals 1, now both statements are false. So neither condition is being satisfied, and I should get a result of false. Similarly, if I were to set both of these to be true, I should get a result of true. And remember, we're comparing two statements, and only one of them has to be true, but it's okay if they're both true. If they're both true, we'll still get a result of true, just as we would if only one of the two comparisons was true. So let me go ahead and clear the screen, and we'll take a look at another one. Now, the next one that I want to look at is something called XOR. If I were to repeat the command that I just did, 1 equals 1 or 2 equals 2, I got a result of true because both statements were true. What XOR does is it allows one of the two conditions to be true, but only one of those conditions. So if I were to replace OR with XOR, then this should become false. And it does. And the reason for that is that with XOR, one of the conditions can be true, but not both of them. So if I were to repeat this, and I change one of these values so that one of the two comparisons that I'm making now becomes false, then the result should change to true. So you can see that we have one true statement, one false statement, and the entire expression evaluated as true. So what happens if we make them both false? Now both statements are false, and if I press enter, I get a result of false, because in order for XOR to be evaluated as true, one and only one of the conditions being evaluated has to be true. So the only way that you're going to get a result of true is if one and only one of these statements is true. So let me go ahead and clear the screen. And there's one more that I want to show you. The one that I want to show you is not. And the way that we use this is -not. And then we need an expression. So I follow -not by an expression that is true. If I press enter, I get false. So I'm checking to see if the expression in the parentheses is not true, but the statement in the parentheses is true, and that causes me to get a value of false. I know it's a word salad. It's a little bit confusing. But if I were to change one of these values so that this expression is no longer true, now I get a result of true. Incidentally, every once in a while in PowerShell scripts, you'll see -not replaced with an exclamation point. So you might see something like exclamation point 1 equals 2. And you can see that this works exactly the same way as -not. Now, throughout this course, I'm going to be writing PowerShell code in long form because I think it's a lot easier to understand that way. But in the real world, you may occasionally run into situations in which you see abbreviations like this used. So with that said, I'm going to go ahead and clear the screen. And I've discussed all of the logical operators that I'm going to be covering, but there's one more thing that I want to quickly mention before I end the video, and that is that you're not limited to using a single logical operator in a statement. You can create compound statements that make use of lots of logical operators. Let me show you an example of this. I'm going to define a couple of numerical variables. I'll go with $A, and I'll set that equal to 30. And $B, and I'll set that equal to 10. So let's check these. $A is 30, $B is 10. Okay, so we've created a couple of variables. Now let's take a look at a compound statement. So we have open parentheses, $A, and we'll say greater than $B. So $A greater than $B. $A is 30, $B is 10. So this part of the expression is true. And if I were to just press enter right now, we would get a result of true. So let's repeat that, and I'll type -and because we want to make a comparison. And then rather than a single set of parentheses, I'm going to put two sets of parentheses. Now remember, in math, there is an order of operation, and statements within parentheses are always evaluated first. So what that means is that because I'm putting a statement inside of double parentheses, that's going to be evaluated before the first statement that I typed. And that's going to become important in just a second for a reason I'll show you. So next I'm going to type $A -LT for less than 20, close parentheses, -or, open parentheses, $B -LT for less than 20. So there's our statement. So we have $A greater than B and $A less than 20 or $B less than 20. Now, because the or statement appears inside of parentheses, that's going to get evaluated before anything else. So $A has a value of 30. Is 30 less than 20? No, it isn't. So that part evaluates as false. Next, within our or statement, we have a comparison of $B, which equals to 10, and we're checking to see if 10 is less than 20, which it is. So that part is going to evaluate as true. Now, because this is an or statement, only one of the two comparisons has to be true. $B less than 20 is true, so the entire or statement is going to ring up as true. Now let's look at the other side of this expression. We have $A greater than $B. Again, $A is 30, $B is 10, so that part is true. So we have a true statement, an and statement, and then we have a compound expression that also evaluates as true. So when we use an and statement, both sides of the and statement have to be true in order for the statement to evaluate as true. So when I press enter, we should get true as a result. And we do. So that's just an example of how you can create compound statements using logical operators in PowerShell. Hello and welcome back. In this video, I want to talk about interactive authentication, because sometimes in PowerShell, you need to perform a command or a script against a remote server rather than executing it against the local system. Now I'm going to be spending all of Lesson 9 talking about running commands against remote systems, but I want to go ahead and give you a little preview of what we're going to be covering in Lesson 9, because the next video is all about automated authentication. So I wanted to go ahead and throw in a really short video on interactive authentication just to kind of set the framework and give you a taste of things to come. So with that said, let's go ahead and get started. When you perform interactive authentication, what you need to do is give the user who is running the script a login prompt so that they have an opportunity to enter the credentials that are going to be required by whatever action is about to be performed. Typically, that is establishing a remote session or running a command against a remote system. The command that's used to display an authentication prompt is get credential. Let me show you what that looks like. So as you can see, when I entered the get credential commandlet, I was given a Windows PowerShell authentication window that asked me to enter a username and password. Now, nothing really happens when I enter this username and password. Let me show you. I get a visual indication that the system received the authentication credentials, but we're not really doing anything with those credentials. So typically what you'll find is that if a script requires interactive authentication, in other words, a prompt to get a username and a password from the user, then what will typically take place is that get credential commandlet that I just showed you will be mapped to a variable so that it can be used to do whatever it is that needs to be done. So let me show you an example of that. I'm going to type $cred, that'll be the name of my variable, and I'm going to set that equal to get credential. And now I see the exact same prompt for a username and password. So I'm going to go ahead and enter some authentication credentials. And I'm taken back to the command prompt. So once again, nothing visible really happens, but I now have those authentication credentials mapped to a variable called $cred. So that means that if I type $cred, you can see the same output that I had just a moment ago. So what can we do with this variable now that we've got it? Well, I'm really kind of getting beyond what I wanted to cover in this video because I'm going to be spending all of lesson 9 talking about remote sessions, but let me just show you what a remote session looks like and how you access a remote session. And incidentally, you do have to enable PowerShell remoting on the remote system before this will work. But the way that you would launch a remote session is by typing enter -ps session -computer name and then the name of the system that you want to create a session with. I'll use my Hyper-V server. And then -credential, and then the credential variable, which in this case is $cred. And you'll notice that the PowerShell prompt changed. Now I have the word Hyper-V in brackets, as you can see right here where I've highlighted. And the reason why that happens is because the command prompt has actually been redirected. Commands that I enter now are no longer being directed toward the local system, but rather to my remote Hyper-V server. So I can do anything that I want on that server, assuming that I have the necessary permissions. And then when I'm done, all I have to do is exit the PowerShell session that I've created. And that's done by way of the exit-ps session commandlet. And you can see that my PowerShell prompt returns to normal, meaning that my remote session has now ended. So that's just a taste of some of the things that we're going to be talking about in lesson 9. So in this video, I talked about interactive authentication, but in the next video, I'm going to be talking about automated authentication. In other words, building the authentication credentials into a script or into a file that the script can call so that there's no visible prompt for a username and password. Sometimes that's necessary because you may need a script to launch on demand, do a particular job, and then terminate without actually having to involve an administrator in the process. So automated authentication is something really critical if you're trying to use scripts to resolve situations on the fly. So that's what I'll be talking about in the next video. I'll see you there. Hello and welcome back. In this video, I want to talk about automatic authentication for PowerShell. In other words, you may have a script that needs to run unattended, and that script may need certain permissions, but it can't prompt a user to enter a set of credentials because that script is running unattended. So in situations like that, you have to come up with a way of supplying PowerShell with the credentials that it needs. Now, there are any number of different ways of accomplishing this, so I'm going to show you one particular technique. Let me go ahead and open up File Explorer. And I've got two scripts that I've written for this video. The first one being 3-10. I'll go ahead and open that up. So here's the script. So what's going to happen is when I run the script, it's going to declare a variable called $mypassword. You can see that right here. And I'm setting that equal to read host. So I'm going to be prompted to enter a password. Now, I don't have any text associated with the read host commandlet, so I'm never actually going to see a prompt. I'm just going to see a blank space, and I'll need to enter a password. And that password will be entered as a secure string. And then I've got a pipe symbol, and I'm telling PowerShell to convert it from a secure string. So next, I've got another line where I'm referencing the my password variable. That's the variable that contains the password that we just entered in response to read host. And that's going to take that password and write it out to a file using the out-file command. And I'm setting the file path equal to c:/scripts/password.txt. So I'm going to be creating a file called password.txt that will contain my password. So with that said, let me go ahead and close this out. And let's go ahead and run the script, and that's 3-10.ps1. So again, there's no visible prompt, but I know that this script exists for the purposes of capturing a password. So I'll go ahead and enter a password. Now, before I press enter, I want to go back to my script for just 1 second. Now, you'll notice that as I typed the password, that password was masked by asterisks. And the reason why that happened is that I've got the -as_secure string parameter associated with the read host commandlet. And that tells PowerShell that I want to mask the input. At any rate, let me go ahead and press enter. And the script ends. So now we should have a file in our scripts folder called password.txt. Let's go ahead and check it out. So if I scroll down, here we have a password.txt file. Let me go ahead and open this up in Notepad. And here's what the encrypted password looks like. So you'll notice that I only typed a few characters. I didn't type 01000D08C9DD and on and on and on. So what we've done is we've captured the password, we masked it so that nobody could see what we were typing, and then PowerShell encrypted that password and wrote it out to a file. Now, this is where our word of caution is in order, because even though that password is encrypted, anybody who has that file can use that file in place of a password. So if they have possession of the file and they know PowerShell, they don't need to know your password. They can just use that file in place of a password. Plus, it's beyond the scope of this course, but there actually is a way to decrypt this and get a password from an encrypted value. So that's just something to be aware of. The reason why I mention this is because it's super important to make sure that you protect this file. You'll want to store it where nobody has access to it other than what needs access to it. So you'll want to protect this just as strongly as you would protect a password. Now, having said that, in this case, I'm storing the encrypted password in a file. But I've also seen real-world situations in which somebody uses a very, very similar technique and produces an encrypted password, but actually stores that encrypted password inside of the PowerShell script so that PowerShell doesn't have to go and reference any external password file. And the advantage behind doing that is that you can kind of disguise the encrypted value within the script, make it look like it's there for something else, so that if somebody happens to pick up that script and starts looking through it, unless they know PowerShell really well, they may not realize that that's actually an encrypted password in the script. They'll think that it's something else and not realize that that's an encrypted password that they're looking at. So with that said, let me go ahead and close this, and I want to show you how to use this encrypted password that we've created. So you'll notice that I've got another file here, and that file is 3-10b.ps1. I'll go ahead and open that. And this script is really simple. So all we're doing here is we're setting $user equal to my username. We're setting $file equal to the path and file name of our password file. And then we're setting up a variable called my credential. And we're setting that variable equal to a new object of type system.management.automation.psCredential. Then we're supplying a few parameters, namely the argument list parameter, which you can see right here. And for the argument, I'm using $user as the username, and then there's a comma, and normally PowerShell would be expecting a password right here. But rather than supplying a raw password, what we're doing is we've got a parentheses, and then we're telling PowerShell get content $file. Remember, $file is a variable that points to the path and file name of the file containing our encrypted password. So we're using the get content commandlet to read in the contents of that file. And then we're converting that file to a secure string from its encrypted value, and that will allow us to use that encrypted value as a password. So you won't actually see anything, but the my credential variable will be populated with a set of user credentials, a username and a password, and that can be used for authentication. So you're going to be seeing several examples of this later on in the course when we get to the section on remote connections. This is just to get you ready for that and show you how passwords work in PowerShell. So with that said, let me go ahead and switch over to PowerShell, and we'll run the script. And as I mentioned a moment ago, there's no visible output, unfortunately, because really all we've done is declare a variable, but that variable contains our credentials. But just to keep things interesting, let me show you what would happen if you were to manually type these commands. So we'll start with the $user equals my username. Next, we'll copy the $file equals c:/script/password.txt. I'll go ahead and copy that, and we'll paste that into PowerShell. And so now, if I type $user, you can see that $user is set to my username. And if I type $file, you can see that it points to a path and a file name, namely the file containing our encrypted password. So then, I'll switch back over to my script, and I'll copy the my credential line. I'll paste that into PowerShell. And let's take a look at the my credential variable. And you can see username is my username, and then password is system.security.securestring. So in other words, using this technique isn't going to cause PowerShell to reveal the password, but it is confirmation that PowerShell is storing a password in the my credential variable. So that's how passwords and password files work in PowerShell.
In the previous lesson, you learned how to create a simple script. In Lesson 4, I introduced you to some concepts that have the potential to make your scripts much more useful. Those concepts include passing variables to a function, global variables and local variables, creating loops, creating a progress bar, switch statements, sorting PowerShell output, and building modules and standalone functions.
In one of the earlier videos, I showed you how to create functions in PowerShell. Now, functions, as helpful as they are of limited use unless you are able to pass information to a function and get information out of a function. So how do we pass information to a function? Well, typically we do that in the form of a variable. We pass a variable to a function, we have the function take action on that variable, and then we get some result from that function. So in this video, I wanted to show you how to pass a variable to a function. So let's take a look at an example. I'm going to go ahead and open up my scripts folder. And I'm going to open up a script called 4-1-1. So here's the script. And this is actually just a really simple script. And you'll notice that the very first thing that we have is a function declaration. Now, initially, this looks like any other function in that we have the word function, and then we follow that function declaration with a function name. In this case, the function is called get-myvms. But then you'll see that we have something new that we haven't covered in any of the previous videos. And that's this parentheses, $server parentheses. What this is an indication that we're going to be passing a variable called $server to the function. I'm going to skip ahead a little bit and go down to the script body. And you can see that I've got a comment right here saying script body starts here. So the first thing that we have in the script is the CLS command that tells the script that we want to clear the screen. Next, we have a variable declaration. I'm setting up a string variable called $server, and I'm assigning this variable a value of Hyper-V. So I'm just adding the word Hyper-V to this variable. Now, Hyper-V is actually the name of a particular server on my network. And as the name would indicate, it's a Hyper-V server. So we're populating a variable called $server with the name of a Hyper-V server on my network. And obviously, if you have a different server on your network, you would want to replace the word Hyper-V with whatever your server name happens to be. So then the final line that we have in the main script body is get-myvms. And as you'll recall, get-myvms also happens to be the name of our function, which you can see right here. Now you can see that we're following get-myvms with the variable $server. And if you look up at the function declaration, you can see that we have $server right here. So what we're doing is we're populating the $server variable. We're passing that variable to the function through this statement right here. And then what this does right here, where we have $server in parentheses, is it tells the function that it should expect to receive a variable. And we're going to call that variable $server. So what does the function itself do? Well, you can see that we've only got 3 commands in the function. The first command is a write host command. Let me kind of move over here. We have write host. The Hyper-V server name that was passed to this function is $server. And the only reason why this particular line of code exists is just because I want to prove that we are indeed taking the value of that variable and passing it to the function. And then once it's in that function, we can echo the contents of that variable. That's the only reason that line exists. So it's going to tell us the name of our Hyper-V server. Then the next line of code that we have is another write host statement. And then it just displays the words the virtual machines on this server are. So this line of code right here doesn't really do anything by itself other than display literal text saying the virtual machines on this server are. And then the third command within the function is get-vm. Now, get-vm is a PowerShell commandlet that retrieves the virtual machines on a Hyper-V server. And get-vm can include several different parameters. One of those parameters is a computer name. And the computer name is the name of a Hyper-V host. So we're appending the computer name parameter followed by the $server variable. And remember, the $server variable contains the name of my Hyper-V server. So what this line is doing is it's telling PowerShell get VM, which retrieves a list of virtual machines from a Hyper-V server named and then the server name. In my case, the server is called Hyper-V. So let's take a look at how this works. I'm going to switch over to PowerShell. And let's go ahead and run the script. Okay, so the first line of output is the Hyper-V server name that was passed to the function is :Hyper-V. And if you remember from our script, we actually declared that $server equals Hyper-V. So we've populated this variable, we've passed it to the function. So this line of code right here proves that the contents of that variable have indeed made it to the function. So let's switch back over to the script. Next, we have the virtual machines on this server are, and that's just that literal text value from the second write host statement. And then we ran the get-vm-computer name Hyper-V, and that retrieves a list of the virtual machines residing on that Hyper-V server. So you can see we have VM1, VM2, VM3, and right now all of these virtual machines are powered off, which is fine. I only created those virtual machines just so that I could demonstrate how this particular script works. So with that said, let's go ahead and clear the screen. And I want to show you a second script. And the reason why I created a second script is to demonstrate the fact that you can pass more than one variable to a function at a time. And oftentimes in production environments, you'll find that you need to do this. So let's take a look at how to pass multiple variables to a function. So I'm going to go ahead and close out the script that we had open. And I'm going to open up a script called 4-1-2. So this script is extremely similar to the one that you just saw, but I'm doing something just a little bit different. Rather than starting with the function, let's start with the script body. So once again, I've got a comment saying script body starts here. Then we're clearing the screen. by way of the CLS command. Next, we have the $server equals Hyper-V. That's exactly the same as what we had in the previous script. We're creating a variable called $server, and we're adding the name of a Hyper-V server to that variable. In this case, we're adding the word Hyper-V because that's the name of my server. Then we've got something new. We've got another variable declaration right here, $VM. And I'm setting $VM equal to VM1. Now, as you may recall, VM1 was the name of one of the virtual machines on my Hyper-V server. So I'm creating a variable called $VM, and I'm populating with the name of a virtual machine. And then finally, I'm calling the function. So I've got get-myVMs, which again was the function name. You can see the function declaration right here, followed by the function name, get-myVMs. And this time I'm passing two variables to it instead of one. So I've got server1, and then I've got $VM. And you'll notice that I didn't have to do anything special with these variables. They're not separated by a comma. They're not in parentheses. I haven't done anything other than just list the variables that I want to pass to the function. Then if you look up here at my function declaration, you can see that get-myVMs is followed by parentheses, the first variable name, comma, and then the second variable name, and then close parentheses. Now, the one thing that I do want to point out here is that you do have to pass the variables to the function in a certain order. Now, it doesn't matter what order, as long as you're consistent. So you can see that down here I'm passing $server, and then my function is receiving $server. I'm passing $VM, and then my function is receiving $VM. So I'm passing the variables in the same order that I'm receiving them in. You don't want to switch up the order. So let's take a look at what the actual function body does. And I'm doing something just a little bit different here. So the first line of code is very similar to what you saw in the previous script. I have a write host statement, and then it says the Hyper-V server name that was passed to this function is, and then $server. So I'm passing the server name to the function, and this line just confirms that the value contained within that variable was indeed passed to the function. And then the next line of code does something very similar. We have a write host statement, and then we have text indicating the name of the virtual machine that was passed to the function is $VM. So $VM contains the name of a virtual machine, in this case VM1, and this line of code just confirms that VM1 was indeed passed to the function. Then we have another write host statement, write host, the virtual machines on this server are, and this line doesn't do anything except just display text saying the virtual machines on the server are. And then finally, we have our get-vm statement. Now, you'll recall that the previous script used get-vm-computer name $server. So the portion of this command that is highlighted in blue right now is identical to what we had in the previous script. We're targeting the get-vm command toward a specific Hyper-V server, and that server name is contained in the $server variable. But we're doing something new here. We've got $VM. And the reason for this is that the get-vm accepts a virtual machine name as input. So if you specify a specific virtual machine when you use the get-vm command, it will display information for that one virtual machine as opposed to displaying all of the virtual machines on the entire server. So what this command does is it tells PowerShell we want to retrieve a list of virtual machines from the server called Hyper-V, but we only want to look at one specific virtual machine. That virtual machine is called VM1, and the value VM1 is stored in a variable called $VM. So let's take a look at what this script does. I'll switch over to PowerShell, and we'll run the script. So we have the Hyper-V server that was passed to the function is Hyper-V. So remember, we declared the $server variable equal to Hyper-V, so that's our server name. And then we passed that variable $server to the function. And then we had our function set up to receive that variable $server. And then we executed this line of code right here, which displayed the contents of that variable. So that's where that first line of output is coming from. Next, we have the name of the virtual machine that was passed to the function is VM1. And we're doing exactly the same thing in our script. So we have a variable $VM equal VM1. We're passing $VM to the function. And then in the function declaration, we're receiving $VM, which contains the value of VM1. And then we've got a write host command right here saying that the name of the virtual machine that was passed to the function is, and then it outputs the contents of that $VM variable, which is VM1. So then the next thing that we have is the virtual machines on the server are, and then because we only told PowerShell to look at a specific virtual machine rather than looking at all of the virtual machines, the only virtual machine that is displayed is VM1. So that's how the script works. So as you can see, we've successfully passed multiple variables to a PowerShell function. Hello and welcome back. In this video, I want to take the opportunity to discuss global variables and local variables. Now, we're not really going to be making extensive use out of local variables in this video series, but it's still an important concept to understand, because sometimes a script may not work quite the way that you want it to unless you know how to tell the difference between a global variable and a local variable. So let me show you what I mean. I'm going to go ahead and open up my scripts folder. And I'm going to open up 4-2.ps1. So here's my script. And this is actually a really simple script, but I'll go ahead and step you through it. So the very first line of the script is a function declaration. So PowerShell is going to ignore this until the function is actually called. So we skip all of this because that's all part of the function. And then PowerShell arrives here. This is just a comment line that tells where the script body begins, so PowerShell completely ignores this line. So the very first line of code that PowerShell is actually going to execute is this line right here, get-mydata. Now get-mydata isn't the name of a PowerShell commandlet. Instead, it's the name of the function that I declared at the top of the script. Because remember, every function has to have a name. So if you go up to the top, you can see that we have function and then get-mydata. So get-mydata is the name of the function. So this line right here is actually calling that function. So what does the function do? Well, the very first thing that the function does is it declares a variable called $myvar, short for my variable. And I'm setting that equal to get-process PowerShell. So what does that do? Well, the get-process command retrieves a list of all of the processes that are running on the system. And there's actually a process named PowerShell, assuming that you've got PowerShell open. So I'm just telling PowerShell that I want to look at the PowerShell process as opposed to looking at the entire list of processes. For the purposes of what I want to show you with the script, I need to keep the output from the get-process commandlet short, and the easiest way to do that was to specify one individual process rather than looking at all of the processes. So just for the sake of demonstration, let me switch over to PowerShell, and I'll show you what this looks like. If I type get-process, I get a great big long list of all of the system processes. But if on the other hand, I type get-process PowerShell, I only see the PowerShell process. So with that said, let me go ahead and switch back to my script. So I'm setting a variable equal to get-process PowerShell. So the output that you just saw a moment ago is going to get written to the $myvar variable. Next, we have a write host line right here. And this is just going to add a blank line to the screen. And I'm adding a few blank lines throughout the script just to make the output a little bit easier to read. Then we've got another write host statement. And this write host statement is going to display the words function output on the screen. So that way we can tell which output is being generated by the function versus which output is being generated by the main script body. And then we have another write host command to insert a blank line. And then we're printing the contents of the $myvar variable. So this is where we'll see the output that's identical to what you see right here. So at that point, we're going to return to the main script body, picking up with this line right here. So PowerShell is going to insert a blank line because of this write host statement. Then it's going to execute this line right here, and display the words script body output. So that way we can tell that the script is running from the main body at this point, as opposed to continuing to process the function. The script is going to insert another blank line because of this write host command, and then it's going to print the contents of the myvar variable. So let's take a look at how this works. I'm going to switch back over to PowerShell, and I'll go ahead and clear the screen. And let's run the script. So here's what the script results look like. So let's step through this. The very first thing that we see is function output. Then we see the PowerShell process, just as we expected. Then we see script body output, and then beneath that, nothing. So why is that happening? Well, you'll notice that within our function, we displayed the words function output, and those words were indeed displayed in our output. You can see that right here. Then we displayed the contents of the $myvar variable. And if I switch back over to the output, you can see that right here. So everything in the function executed exactly as expected. Then we get down to the main body. And PowerShell is set up to display the word script body output, which you can see right here. And it did that. You can see script body output. Then it's set up to display the $myvar variable. And that's exactly the same variable that we displayed right here. And yet PowerShell displayed nothing. So why is that? Well, it all comes down to the difference between local variables and global variables. So let me show you what I mean. We initially declared the $myvar variable inside of the function, and that makes that variable local to the function, meaning that we can use that variable to our heart's content inside of the function, but we're not going to be able to use it outside of the function. So that's why when we printed the contents of the $myvar variable right here, the contents displayed normally because we were still inside of that function. But then we dropped down to the main script body and we tried displaying that variable's contents again. We got nothing. And the reason for that is that the variable was local to the function, so the main script body knows nothing about that variable. So this raises the question that if you're writing a script and you need to declare a variable in a function, but you need that variable to still be valid when you get back to the main script body, how do you do it? Well, believe it or not, this is actually a really, really easy problem to fix. And when I say easy, I really mean it. I'm not kidding around. You can fix this with one word. The way that we fix this is by going up here to our variable declaration. Now, one of the things that I talked about early on in this video series is that when you declare a variable in PowerShell, you always start with a $sign followed by the variable name. That's always the way that you do things. But there's one big exception to that. If you need to designate a variable as being a global variable, which means that it's valid inside of the function and inside of the script body, then the way that you do that is by inserting the word global between the $sign and the variable name. So I'll go ahead and do that. I'll type global. And we need to insert a colon, and that should fix the problem. So let me go ahead and save this. And then I'll go back to PowerShell, and then we'll run the script. So this time we see function output, and we see the expected output. Next we see script body output, and then we see the output there as well. So now our variable is valid inside of the function and outside of the function. And keep in mind, we only needed to do that because we initially declared that variable inside of the function. Had we initially declared that variable inside of the main script body, that wouldn't be necessary. So that's how you set up a global variable in PowerShell. Hello and welcome back. In this video, I want to show you several different types of loops in PowerShell. Now, for the purposes of this video, I'm assuming that you know what a loop is. For the uninitiated, a loop is simply a mechanism within a script that causes a block of code to execute over and over again so long as a particular condition is true, or until a particular condition becomes true. So let's take a look at some examples of some loops. Now, I'm going to be showing you 6 different scripts in this video, and the first 4 of those scripts are going to produce identical results.
Even so, we're going to use different methods to arrive at those results. I'm just trying to keep things as consistent as I can from one type of loop to the next so that you can see the difference between the various types of loops. So let's take a look at the first script. So this is what we call a for loop. The very first line of the script is just a comment. In PowerShell, any line that begins with a pound sign, like what we have here, is a comment, and that's completely ignored. So the first real line of code right here is for. The next thing that we do is we set a condition right here. And there are three elements to this. The first element is $i equals 1. And what we're doing right here is declaring a variable. We're creating a variable called $i, and we're giving it an initial value of 1. The next element is $i-lt11. -lt stands for less than. So we're setting up a condition. We're looking to make sure that $i is less than 11. Remember, we started out $i as 1, and we're making sure that it's less than 11. And then the last part of this tells us what we want to do with I. So every time this loop runs, we're going to increment I. That's what the plus plus is. It means increment $i by 1. So the first time that this loop runs, $i is going to be equal to 1. It's going to check to make sure that $i is less than 11, which it is because it's equal to 1. And then it's going to increase $i by 1. So $i will then become 2. The whole thing repeats again. So now $i is 2. PowerShell checks to make sure that $i is less than 11. So at 2, it is less than 11. And then $i gets incremented by 1 again. So it becomes 3. And the whole thing repeats up until we get to 11. At that point, $i is no longer less than 11, and then the loop ends. So what are we doing within this loop? Well, we could do just about anything that we want. So in this case, I've just got a very simple write host statement, and I'm outputting the value of $i. So when we run the script, we're going to see a counter go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And remember, we won't get to 11 because we're checking to make sure that $i is less than 11. And then when the counter reaches 11, then what's going to happen is the loop is going to end, and then we're going to hit this line of code right here, which is going to display text on the screen indicating that the loop has ended. So let's take a look at how this works. So I'll go ahead and run my script. And as predicted, we see the values 1 through 10, and then we see a message indicating that the loop has ended. So that's how that works. Let me go ahead and clear the screen. And I'll close the script, and we'll move on to the next one. So the next type of loop that I want to show you is a do-while loop. And we've got all of the same basic elements going on. So we're beginning with a comment. And remember, comment lines begin with a pound sign, and they're ignored. So PowerShell doesn't do anything with this line right here. Then we get to the first real line of code, $i equals 1. So once again, we're creating a variable called $i, and we're giving that variable an initial value of 1. Next, we've got the word do, and this tells PowerShell that we want to do something. Well, what are we going to do? Well, the do loop consists of everything in between these two brackets. So in this case, we're doing two things. The first thing that we're going to do is to use the write host command to output the value of $i. The next thing that we're going to do is to increment the value of $i. So we've got $i plus plus. Incidentally, we could just increment $i by 1 by saying $i plus 1, but this is generally easier. So then we reach the end of the loop. Now, we need a condition in order to break the loop, otherwise this would be an infinite loop, and that's where the while statement that you see right here comes into play. So we're going to perform the tasks defined within this loop while $i is less than 11. So we're going to start with a value of 1. We're going to output the value of $i, which is 1. We're going to increment it by 1, changing the value to 2. At that point, we're going to check to make sure that $i is less than 11. It is. So we're going to jump back up here. We're going to perform the write host command again, write the value, which is now 2. We're going to increment $i by 1, changing its value to 3. We're going to make sure that $i is less than 11. 3 is less than 11. So we're going to jump up here, print 3,
and then repeat the entire process until $i is no longer less than 11. At that point, the loop ends, and then we drop down to this line of code right here, indicating that the loop has ended. So let's take a look at how this works. And once again, we get the exact same output that our other script gave us. So with that said, I will clear the screen. And let me minimize PowerShell and close the script. And let's take a look at the next one. This script is an example of what's known as a do until loop. This works very similarly to what you've already seen. So once again, our very first line is a comment. Our first line of real code is the same as what we had in the last script. We're declaring a variable called $i and we're setting its initial value to 1. Once again, we also have the word do, just like what we had in the previous script. And then we've got some brackets. And whatever falls between those brackets represents this body. So again, we've got right host $i and then $i++. So up until this point, this script is identical to the one that I just showed you. There are no differences whatsoever. The real difference comes in on this line right here. You'll notice that now we have the word until. So we're going to repeat this loop until a particular condition is true. And what is that condition? $i is equal to 11. So let's take a look at how this works. We set $i with an initial value of 1. We use the right host command right here to display the value of $i, so that's going to be 1. We increment $i, changing its value to 2. Then we drop down to this line right here. $i is not equal to 11, so the loop repeats. We come up here, we use the right host command to display the value of $i, which is currently 2. Then we drop down to this line, we increment $i by 1, changing its value to 3. We come down to this line, we check to make sure that $i, which currently has a value of 3, is less than 11. It is. So then we perform the loop all over again, and we keep doing that until $i is equal to 11. At that point, the loop ends, and then we come down to this line of text right here, which uses the right host commandlet to display the text saying the loop has ended. And as you've probably already guessed, the output is exactly the same as what we had before. So here you can see the script's output. I'll go ahead and clear the screen and minimize PowerShell. And I'll close the script and we'll move on to the next one. And this is the last script that's going to produce an identical output. Now this one is a little bit different from what you've seen. You'll notice that the length of it is a little bit longer, and the actual type of loop that I'm doing is the same as something that you've already seen. We're doing a do while loop. So here's the do command, and then here's the while command. So you've already seen this type of loop, but I'm doing something a little bit different in the loop. Because as before, I started out with a variable declaration. I'm setting $i equal to 1. Then I've got my do command, and then an opening bracket indicating the start of the loop body. And I've positioned that bracket in a slightly different place. The position really doesn't matter all that much. Then, just like before, I'm using the right host commandlet to display the value of $i, which it begins with an initial value of 1. But then what I'm doing is I'm embedding an if statement within the loop. I'll come back to that in a second. The important thing here is that we have a while statement down at the bottom, and the condition that I'm checking for is $i is greater than 0. Now, as you'll recall, I set up the loop with an initial $i value of 1, which is fine. But right here, we have a line of code that increments $i by 1, just like what we have been doing. So I starts out at 1, and it only gets higher. It increments by 1 each time the loop runs. So I becomes 1, and then 2, and then 3, and 4, and so on and so forth. Now, our while statement checks to see if I is greater than 0, and the loop will continue to run as long as that's true. Now, $i is getting bigger, not smaller. So we're never going to hit a situation in which $i is not greater than 0. So what we've really created here is an infinite loop. Well, that's where this if statement comes into play. So what I've done is I've set up an if statement, and we're checking to see if $i is equal to 10, and then I use the word break. What the break command does is it forcibly ends a loop. So even though our while condition right here is never going to be satisfied, this if condition is going to be satisfied. And when it becomes satisfied, then the break command is going to kick in and terminate the loop regardless of anything that's specified in the while statement. So yes, it would be a lot easier to just have a simple do while loop and use a condition that is going to eventually be satisfied and use that to end the loop. But sometimes in the real world, things can get a little bit messy, and you may have to embed breakpoints into a script in order to make it function properly. So as soon as that break happens, then PowerShell is going to jump down to this very last line right here and use the right host commandlet to display text indicating that the loop has ended. So I'll go ahead and switch over to PowerShell, and I'll run the script. And you can see that the output is identical to the other scripts that we've already run. I'll go ahead and clear the screen. And I'll go ahead and close out that script and switch to the next one. Now for this script, we're going to be doing something totally different. This is going to be a for each object loop. So what this is we can create a loop based on the contents of an array. And I've tried to make this sort of kind of like a real world example, but at the same time keeping things simple. So for this one, I'm just going to step you through a really simple for each object loop, and then the next script that I'll show you actually does something practical. So let's take a look at how this works. So the very first line, just as before, is a comment line. It doesn't do anything. Our first line of actual code is right here, and what we're doing is we're setting up a variable called servers. And the @ symbol right here indicates that the servers variable is going to be an array. And I'm pre-populating the array with several pieces of text. I'm adding server 1, server 2, server 3, and server 4 to that array. So we have a variable called $servers, and it contains all of these pieces of text. So the next thing that I'm doing is I'm setting up the for each loop. And what we need in order to make this work is a variable that hasn't been declared yet. And we can call this anything. It doesn't really matter what we call it so long as we're not using it elsewhere. Now, my array is called $servers because it's essentially just a list of servers. So what this variable that I'm setting up right here is going to do is it's going to deal with one item out of that array at a time. So in this case, that one item is one individual server. So I chose to just use the name $server. So for each $server in $servers, in other words, for each server in the list of servers, we're going to perform a particular task. In this case, all I'm doing is writing the server name using the right host commandlet. And you'll notice that this falls between brackets here and here. So this is the loop body. Whatever is between these two brackets is the task that's going to be repeated over and over. Now, in this case, we don't have a greater than, less than statement, anything like that, that's used to determine the flow of the loop or the number of times that the loop executes. Instead, what's going to happen is that the loop is going to execute one time for every item on my list. In this case, one time for every item within the $servers array. And then once that array has been depleted, in other words, we have run the loop for each item within that array, then the loop is going to end, and then we're going to drop down to this line right here, which uses the right host commandlet to display text on the screen indicating that the loop is completed. So when we run the script, what we're going to see is a list of the servers. So the loop says for each $server in $servers, so for each server in the list of server, write the server name. So what's going to happen is the loop is going to engage. It's going to display server 1, and then the loop is going to move on to the next item. So we're going to see server 2 listed on the screen, followed by server 3, and then server 4. And then at that point, the loop is going to terminate, and then we're going to see a message saying that the loop is completed. So that's how the script works. Let's go ahead and run this. I'll go ahead and press enter, and you can see that the loop has displayed all of my server names followed by a message saying that the loop is completed. So let me go ahead and clear the screen. And we've got one last script to look at. Now, I promised you that we would do something a bit more practical for this last script. And right away, you can see that this script is a bit more complicated than the other scripts that we've done. Even so, this is very similar to the script that I just showed you. Once again, we're doing a for each object loop. So how does this work? Well, just like the last script, I set up a variable called $servers, and I made that variable an array by using the @sign. And we're populating this with a list of server names. But rather than just using server 1, server 2, etc., I'm actually using real server names. And in this case, these are all Hyper-V servers. Now, I think I briefly mentioned Hyper-V in one of the earlier videos, but if you're not familiar with Hyper-V, it's Microsoft's virtualization platform. Hyper-V is a role that you can install on top of Windows Server and use that role to host virtual machines. And those virtual machines can run Linux or Windows or whatever you want to run in them. So in this case, I've got 4 Hyper-V servers, and each one of those Hyper-V servers are running a few virtual machines. So we've got our list of Hyper-V hosts, and then just beneath that, I'm setting up the for each loop, just like what we did in the previous script. And then I'm setting the for each loop up to look at $server and $servers. So once again, we're looking at each individual server within a list of servers. Now, where this really differs from the previous script is in the loop body right here. Once again, the loop body is anything that falls between this bracket and this bracket. So all of this is the loop body. So what are we doing here? Well, let me scroll over just a little bit. So the first command in the loop body just displays the server name. But in this case, I've added a little bit of extra text to it. So we're going to see text that says, these are the virtual machines hosted on server. And then you'll notice I've got the $server variable. This causes the server name to be displayed. Technically, I don't need a write host command to display the contents of a variable. I can just type the variable name, and that works just as well. So the next thing that I'm doing is I'm creating a variable called $VMs. And this variable is going to hold the names of the virtual machines that exist on a server. So I'm setting $VMs equal to the get-vm commandlet. Now the get-vm commandlet is native to PowerShell, and it retrieves a list of all of the virtual machines that are hosted on Hyper-V. From there, what I'm doing is I'm specifying the computer name, and I'm populating the computer name parameter with the name of the server that we're currently examining in our loop. So the next thing that I'm doing is I'm using the write host commandlet to display $VMs. Remember, the $VMs variable contains a list of the virtual machines on the current host, but we're following $VMs with .name, because when we retrieve the list of virtual machines or VMs, each one of those virtual machines is going to have a number of different attributes associated with it, and the attribute that we're really interested in is the name. And this is something that I'll probably get into in a lot more depth in some of the later videos. But just know for right now that write host $VMs.name outputs a virtual machine name. Next, I've got write host, and then I'm just providing some empty space. This just makes the output a little bit more legible. And then at the very end, we have a write host command indicating that the loop is completed. So what's going to happen is we're going to go through this loop body for every server in the list. So PowerShell is going to look at a server called Hyper-V1. It's going to say, hey, these are the virtual machines that are hosted on server Hyper-V1. Then we're going to retrieve a list of those virtual machines. We're going to use the write host $VMs.name command to display those virtual machines. We're going to insert a blank line, and then we're going to move on to server Hyper-V2. And then for that server, we're going to display some text saying these are the virtual machines that are hosted on server Hyper-V2. We're going to get the list of virtual machines and display them, insert a blank line, and then move on to Hyper-V3, and so on and so forth. So let's take a look at what happens when we execute this script. So we see all of the lines of text saying these are the virtual machines hosted on server Hyper-V1, Hyper-V2, Hyper-V3, Hyper-V4. And then beneath that, we see things like VM11, VM17, VM32, VM6. These are the names of individual virtual machines that are hosted on these servers. So that's how this script works. So we've actually set up a loop to do something practical. we're using that loop to go out and query a series of Hyper-V servers and return data off of those servers and present it in a way that we can make sense of that data without having to go in and query each individual server. So that's just a small sample of some of the things that you can do with loops in PowerShell. Being that I talked about loops in the previous video, I wanted to take a moment and show you how to create progress bars. The reason for this is really simple. When you get into advanced PowerShell scripting, oftentimes loops are associated with long-running processes. And it's helpful to create a progress bar so that you can show whoever's running the script that the script hasn't locked up. Now, I've seen a number of progress bars in PowerShell, typically when I download a script off GitHub or something like that. And I have to be honest with you, I always assumed that those progress bars were just coded by hand, that somebody took the initiative to write a progress bar. In actuality, though, PowerShell has functionality built in to create a progress bar. So it's very, very simple to create a progress bar. Let's take a look at how this works. I'm going to open up File Explorer, and I'll go to my scripts folder, and I'm going to open up a script called 4-4-1. So here's the code for creating a progress bar. And you'll notice right here that I've got one line commented out. I'll come back to this line a little bit later on. So let's take a look at what we've got going here. The very first line of code is a for statement. So we're setting up a loop. This should look really familiar from the previous video. So we're setting up a for loop. We're setting a variable called $n equal to 1. So that's our starting value. Our condition is we're checking to see if $n is less than or equal to 100. And if it is, then we're going to run the code within the loop block, and then we're going to increment $n by 1 using the $n++ statement. So that's how this loop works. So what are we actually doing within the loop? Well, we're using this command right here, write progress. That's the PowerShell commandlet that's used to create a progress bar. And you can see that I'm doing this in two different ways. The first way, we're not actually going to display the bar. Rather, we're simply going to display the percentage of the task that has been completed. So you'll notice the first thing that we do right here is set an ID number equal to 0. Now, this ID 0 is kind of meaningless in this particular case, but it's going to come into play with the second script that I'm going to show you in a few minutes, because you can have multiple progress bars being displayed at the same time. And when you do that, you have to assign each progress bar an ID number. So in this case, we've only got one progress bar, so this doesn't really mean anything. But I wanted to at least introduce the concept of an ID to you. So in this case, we're setting the ID equal to 0. Now, what else are we doing? We're displaying some descriptive text showing $n. That's the value up here that we're basing our loop on. Remember, we're setting $n equal to 1 initially. And then we're appending a percentage sign to $n. So we're pretending that going from 1 to 100 in our loop is reflecting some sort of percentage of completion. So we're showing $n percent complete. That's what this does right here. And then the only other thing that's happening in this loop block is that we're running a command start-sleep, and we're setting that equal to 250 milliseconds. Now, what the start-sleep commandlet does is it introduces a delay. And the only reason why I'm introducing a delay is just because this particular machine is fast enough that if I didn't have this delay in here, the entire progress bar would complete instantly and you wouldn't be able to see what's happening. So let's take a look at how this works. Let me open up PowerShell. And it looks like I'm already in my scripts folder. So let me go ahead and run the script. And you can see the text from our script. This was the $n percentage complete. And you can see that we have this nice blue bar, and we didn't have to create the blue bar. PowerShell is doing that for us, and we have a message saying processing. So we can see the percentage complete. We see a message indicating processing, and we've got this nice blue bar, and this was all done with a single line of code. And then when the progress bar completes, we're taken right back to where we left off. So let me switch back to my script. So the write progress commandlet was what did everything that you just saw. Remember, the ID 0 doesn't really do anything in this context other than just assign an ID number to the progress bar. And the only thing that we had was $n%complete. Everything else was done automatically. So, as I mentioned, there are a couple of different styles of progress bars that you can create. So what I want to do is I want to comment out the line that we just ran. So I'll put a £sign here, and then I'll come down and I'm going to remove the £sign from the next line of code so that we execute this line instead. Now, once again, we're executing the write progress variable, but we're doing things just a little bit differently in this case. This time, I've got a parameter called activity, and you can see that it says task in progress. And then we have -status, and then $n%complete. So things are going to look a little bit different this time. Let's go ahead and run the script. Actually, let me save this, and then I'll run the script. So you see task in progress, we have the %complete, and this time we've actually got a progress bar moving across the screen. Now, if I were to switch back to my script, and let me get this on the screen at the same time, you can see that under activity, we actually said task in progress. And then right here, we have task in progress. So whatever text we include in quotation marks right here is what's going to appear in that progress bar. So if I were to simply change this to progress as opposed to task in progress, and then save this and run it again, you can see that now this says progress instead of task in progress. I'm going to put this back to the way that it was. And then for status, we have $n, that's my loop variable, %complete. And you saw that reflected in the progress bar too. And we can change that as well. If we were to change complete to completed by adding a D and then save this out and run the script again, now we see a percentage and we see the word completed instead of complete. So I'm going to go ahead and change that back as well. And I'll go ahead and save this. And there's a second script that I want to show you. So I'm going to go ahead and close out the script. And I'll switch over to File Explorer, and I'm going to open another script called 4-4-2. Now, this script works very similarly to what you've already seen, except this time we're starting with a for each loop. So we've got for each, and then we've got $n, and then in 1 to 100. So we're setting up a loop counting from 1 to 100. And we're using the variable $n as the value that's going to be incremented as this loop progresses. So what do we have next? The next thing that we have is a write progress statement, which you've seen a couple of examples of already. And then we're setting ID 0, which you saw a moment ago as well. Then we have -activity, and then overall task in progress, and then -status, and $n%complete. So you've seen all of this before. But what we're doing that's different is we're setting up a secondary loop. You can see that we have another for each statement right here. And then we're setting up $P in 1 to 100. So we have one loop that's going to count from 1 to 100 based on the variable $n. And then we have a nested loop that's going to count from 1 to 100 using a variable called $P. So we've set up a nested loop. Now, my write progress statement is the same in both lines, but with two very subtle differences. First, we have ID 0 in the first line, and then we have ID 1 in the second line. So we're running write progress twice, and we're setting up a separate ID for each one. Another difference is that we have a different description for the activity. In the first one, we have overall task progress. In the second one, we have subtask in progress. So why am I doing that? Well, you've probably seen really long, complicated installers that have an overall progress bar, but then they have another progress bar that shows the progress of whatever installation task is currently being done. So that particular task progresses to the end, and then the overall progress bar moves a little bit, and another subtask begins. So what we've created here is an example of a progress bar that has a secondary progress bar illustrating subtasks within the main overall task. So let's take a look at what this looks like. I'm going to go ahead and switch over to PowerShell, and let's run the script. So at the top, we see our overall task in progress, and right now that's 3% complete. And then beneath that, we have subtask in progress. And you can see that we're completing a number of subtasks, and each time that we complete a subtask, our overall task increments just a little bit. So what I wanted to show you here is that we can have multiple progress bars on the screen at the same time. In this case, I'm using two. I'm using one for an overall task and one for a subtask, but we could have as many of these as we wanted. So that's how you create progress bars in PowerShell. One of the big differences between a good script and a great one is the way that you handle user input. I think back to when I was a teenager and I wrote a simple database application for a charity group that I was associated with at the time. And what I found was that this particular application that I wrote worked great, just as long as whoever was using it entered exactly the right thing. If they entered something unexpected, however, then the program typically delivered unpredictable results because I hadn't bothered to handle the user input. In other words, if the user typed in something unexpected, then it resulted in unpredictable behavior because I didn't do anything to get rid of that unanticipated input. So that's part of what I want to talk about today, is dealing with user input. And I'm going to be doing that through something called a switch statement. Now, it's worth noting that a switch statement isn't just used for input handling. It's also extremely useful for situations in which you want to take a variety of different types of actions depending on what it is that the user has put in. It's a lot simpler than writing a million if-then statements. So let's take a look at how this works. Now, for the purposes of this video, I've created a script, and this script does something super simple. All it does is it takes the character that the user has entered, and then it tells you what the user typed. So let me show you what this looks like. So as you can see, the script asks me to type a letter from A to D, and if I type A and press enter, I get a message saying that I typed A. Now, admittedly, I kind of cheated when I wrote this application because I took the easy way out. I wrote it with 2 lines of code. Let me show you what I did. You can see the lines of code right here. Just ignore everything below it because all of that is commented out at the moment. So I started out by declaring a variable, $A, and I set that equal to read host. Read host is the PowerShell commandlet that accepts user input. And I set the text that's associated with that read host statement to enter a letter from A to D. So when this line of code executes, the user sees a prompt telling them to enter a letter from A to D, and whatever the user types in is added to the $A variable. And then the next line is just a simple write host statement that says you typed, and then whatever the contents of the $A variable happen to be. So this is the simple way of asking the user for input and then echoing what that user typed in. The reason why I wrote these 2 lines of code is to illustrate the point that if all you're interested in doing is echoing user input, then there are way easier ways of doing it than what I'm about to show you with a switch statement. A switch statement, even though I'm only using it to echo user input, is capable of doing so much more. The reason why I'm simply creating a switch statement that echoes user input is because I'm trying to keep things simple. I want to illustrate the concept rather than trying to write some big fancy script for you. So with that said, Let me go ahead and comment out these 2 lines of code. Actually, before I do that, let me go back to PowerShell. And you can see the script that's still on screen from earlier. It asks the user to enter a letter from A to D. I typed in A and it says you typed A. But what happens if I type an out of range value? What happens if I type Z, for example? Well, I just get a message saying that I typed Z. There's nothing there to indicate that I typed an invalid character. What if I entered something other than a letter? Maybe I want to enter the number 1. Well, I just get a message saying you typed 1. So there's no logic in place that filters out an invalid input. That's where the switch statement comes into play. So let me switch back to my script. And I want to comment out these lines. And I'm going to uncomment out the script down below. So let me save my changes. And I'll go back to PowerShell. And let's run the script again. So I see a prompt that's identical to what we had before, asking me to enter a letter from A to D. And I'll type A. And it tells me I typed A. So right now, this looks exactly like what we already did, but there are some differences. For example, the code that I had earlier was case sensitive. If I had entered a lowercase a, it would have echoed a lowercase a. This is case insensitive. So if I type a lowercase a, it still says you typed and displays an uppercase A. Let's see what happens if I enter Z. I get a message saying you typed an invalid letter. So I'm handling that user input by presenting an error message rather than just echoing any random character that the user happens to type. And the same thing happens if I enter 1. Again, you typed an invalid letter. So let's take a look at how this code works. So this script starts off exactly the same as what we had a moment ago. I'm declaring a variable called $A, and I'm setting that equal to read host, enter a letter from A to D. So the user who runs the script sees a message saying enter a letter from A to D, and then whatever they enter is written to a variable called $A. Next, you'll see a statement called switch. And a switch statement isn't unique to PowerShell. Most programming languages have a switch statement, although some languages call it something slightly different. What a switch statement is it's an alternative to a bunch of if-then statements. It's designed to simplify your code. So you can see that I have switch and then in parentheses $A, meaning that I want to take the input from the $A variable and feed it into my switch statement. The switch statement is everything between this bracket and this bracket. So what are we doing? Well, the lines within a switch statement are made up of 2 parts. First, there's the input, then there's the response. So the input in this line is A. So if I type A, then PowerShell is going to recognize that an A was typed, and because A was typed, then it triggers the response, which is right here. So you have a command, write host, you typed A. What if I had typed B? Well, PowerShell would get to this line right here, and it would see, okay, I should only execute this line if A was typed. Well, A wasn't typed, so let's go to the next line. Well, this line should only be executed if B was typed. Okay, B was typed. The $A variable contains a value of B. So let's execute whatever is in this block right here, which happens to be a statement saying, write host, you typed B. So PowerShell would execute this command, and you would see the words you typed B appear on the screen. And I'll just go ahead and do that. So I type the letter B, and that line of code is executed. You see the phrase you typed B appear within PowerShell. Now, what about that error handling that I did earlier, where when I entered the letter Z or the number 1, there was a statement saying you typed an invalid letter? Well, that's all done by this line of code right here. And you can see that it's set to default. So this is telling PowerShell that unless I entered something that appears on one of the earlier lines, such as A, B, C, or D, if I entered anything else, then it should execute this command right here, which is write host, you typed an invalid letter. So the words you typed an invalid letter are going to appear on screen. And then the switch statement ends right here. Now, one thing that I want to be sure and point out right here is that, again, I designed this particular script to be really simple. So we're not doing anything fancy here. The only thing that I'm putting in these responses is simple write host statements. In the real world, what you would typically see is that in the script, say somebody pressed A, well then they would be taken to a function instead of there being a write host statement that appears right here. Another thing that I want to be sure and point out is that in this particular script, I'm evaluating user response, but switch statements don't have to be used that way. Let's suppose that you've got some automated process within a really complex PowerShell script and you want to evaluate a variable that was computed. You could use a switch statement to evaluate a computed variable. It doesn't have to be something that was entered by an end user. Remember what I said before, switch statements are basically an alternative to if-then statements. So if you've got a block of code that would normally require a lot of if-then statements, you could replace that block of code with a switch statement, which is a lot easier to use. So how's this a substitute for if-then statements? Well, just think about the way that the switch body works. This could be expressed as if $A equals A, then write host you typed A. Then the next line could be interpreted as if $A equals B, then write host you typed B. And then we go on to the next line. If $A equals C, then write host you typed C. So you can see we're saving ourselves a lot of coding by using the switch statement rather than writing a bunch of if-then statements. So that's just an example of how a really simple switch statement works. What's interesting is that switch statements can actually handle multiple variables at once. And typically you won't need to do this for user input, but if you've got a complex PowerShell script that is dealing with a lot of computed values, there are use cases in which a single switch statement might be used to handle multiple variables. So let's take a look at how that works. I'm going to go ahead and comment out some of these lines. And then I've got a more complex example further down. So I'm going to remove the comment lines from that. And let me save my changes. Now this example is very, very similar to what I just showed you. The only difference is that we're dealing with two variables instead of one. So the first line is identical to what we've already had. $A equals read host, enter a letter from A to D. This is exactly the same as what we used in the previous script. Then we have a second line that is almost just like it. $B equals read host, enter a second letter from A to D. So the user is going to be prompted for two different letters. But then take a look at the switch statement right here. Rather than only having $A in parentheses, we have $A and $B. So we're passing two separate variables to one switch statement. And the switch statement itself is identical to what you saw earlier. I haven't made any changes whatsoever in this part. So let's take a look at what this looks like. I'll go ahead and switch back over to PowerShell. And let's run the script. So enter a letter from A to D. I'll go ahead and enter A. Enter a second letter from A to D. I'll enter B. And then I get messages saying you typed A and you typed B. So what happens if I enter these letters in reverse order? I'll enter B and then A. And you can see that PowerShell tells me you typed B, you typed A. So it does maintain the order of the input. Also, the script should continue to filter out invalid input, even if only one of the variables is invalid. So let's try some invalid entries. I'll type A for the first one and then Z for the second one. And you can see you typed A and then you typed an invalid letter. If I reverse that by typing Z and then A, I get you typed an invalid letter and then you typed A. And if I enter two invalid values, I get 2 messages saying you typed an invalid letter. So that's an example of how you would pass 2 separate variables to one switch statement. Now that's not something that is super common to do. It's probably not something you're going to do very often in the real world, but I just wanted to show you that it is possible to do that. So that's how you use a switch statement in PowerShell. Hello and welcome back. In this video, I want to show you how sorting works in PowerShell. So to demonstrate the sorting process, I'm going to use the getProcess commandlet, which you've no doubt seen numerous times throughout this course already. In case you haven't watched any of the previous videos, the get-process commandlet returns a list of all of the various processes that are running on the system. Now, when you use the get-process commandlet, there are several different tabs of information that are returned. If I scroll up, you can see that we have things like handles, npm, PM, WS, CPU, ID, SI, and process name. And there are others that you can access by using select object. But right now, this list is sorted by process name. So you can see that the first one starts with A, and then we jump down into the C's, and then D's, E, F, and so on and so forth. But we can actually sort this list by other criteria. So let's suppose that rather than seeing a list of processes that are sorted alphabetically, what if we wanted to instead see a list of the processes that are consuming the most CPU resources? Well, what we could do is we could sort the output by that CPU column that I showed you. Let's take a look at how to do that. I'm going to type get-process, and then I'll use the pipe symbol, and then I'll pipe the output from the getProcess commandlet into sort-object. Sort-object is the commandlet that PowerShell uses for sorting information. And because we want to sort by the CPU column, I'll type CPU. And then we have to tell PowerShell what order we want the results sorted. So I'll sort them in descending order. So I'll type -DESC. And then I'll press enter. And so now you'll notice that the list of processes is no longer in alphabetical order. The very first process on the list is service host, which starts with an S. Then we get into M, and then a couple of S entries and P. And we have a D down here. So this isn't in alphabetical order anymore. Instead, it's ordered by CPU use. So the very first result has 197.63 listed in the CPU column. Then we drop down to 160.75 and then 55.77. And then the numbers get smaller and smaller as we go down the list. Now, this is a pretty long list of results. What if we wanted to do the exact same thing that we just did, but shorten the list a little bit? Well, we can very easily do that as well. So let's suppose that all we wanted to see was the process name, the CPU usage, and we wanted to shorten the list so that we only see the first 10 results, so the 10 processes that are consuming the most CPU time. Well, that's relatively easy to do. What we can do is we can type get-process, and then pipe symbol. Once again, we'll type sort-object, CPU-DESC. So far the command is exactly like what I showed you a moment ago. But I'm going to add another pipe symbol. And then I'm going to pipe the output from the sorted list into select object. And then we're going to look at this column right here. So we're going to include the process name. And the name of the process name column is process name without a space. So we'll type process name, comma, CPU. And then I'm going to add a dash and then first and 10. So what this will do is this will show us the 10 processes that are consuming the most CPU resources, and we're only going to see the process name and the amount of CPU resources that are being consumed for those 10 processes. And here's the results. And incidentally, you can sort based on any of these columns using the exact same technique that I just used. And we can also shake things up a little bit by looking at the processes that consume the least CPU resources. So I could repeat the command and change first to last. And maybe I want to look at the last 5 instead of the last 10. So these are the 5 processes that consume the least CPU resources. So you can see the system idle process at the very bottom of the list with no CPU consumption whatsoever, not even measured. And then just above that, we have 4 entries that each have 0 CPU utilization at the moment. Now there's one more thing that I want to show you. You might have noticed that sometimes there are multiple instances of a particular process. So take a look at the list that was just returned, for example. We got 5 results, and 3 of those results pertain to service host. So what if we wanted to know how many instances of a particular process there were? Well, we can find that out too, but we have to do things just a little bit differently. So what we can do is we can type get-process and then pipe that into where object and then bracket $_dot name -eq, and then the name of the process that we want to look at. So we'll go ahead and look at service host. So svchost. So we're looking at a list of processes where the name is equal to service host. And I'll enter a closing bracket and press enter, and I got an error, and the reason is because I forgot to put apostrophes around the process name. So let's type that again, and I'll put an apostrophe here, and an apostrophe here, and let's do that again. So now I see all of the service host processes on this machine, and you can see that there are a lot of them. But what if I wanted to know how many there were? Well, what I could do is repeat the exact same command that I just used, but assign this to a variable. So I'll just call this $A, and I'll set $A equal to get-process where object $_dot name is equal to service host. I'll press enter. So now all of the output that you saw before has been mapped to the $A variable. And if I type $A, you can see that information. So if I want to know how many instances of this particular process there are, I could type $A.count. And we can see that there are 65 instances of the service host process. So that's just a trick that comes in handy sometimes as you're working with system processes and other objects in PowerShell. At any rate, my purpose in this video was just to show you some sorting techniques that you can use as you work with various types of objects in PowerShell. In this case, I worked with the getProcess commandlet, but the techniques that I showed you will work with nearly any get-based PowerShell commandlet. So that's it for this video. I'll see you in the next one. Hello and welcome back. Way back in one of the earlier videos in this course, I talked all about PowerShell modules, and I explained how sometimes commandlets were grouped into modules, and that makes PowerShell extensible. And at the trailing end of that video, I quickly mentioned that it's possible to create your own module and even to create your own custom PowerShell commandlets. And in this video, I'm going to show you how to do just that. Now, if the idea of creating your own commandlet seems like a bit much, well, don't worry, because the process is actually quite a bit easier than what you might expect. So let's go ahead and get started. I'm going to begin by showing you a script that I wrote. And this script only contains about 5 lines of code. I kept it as easy as I possibly could. Let's take a look. And the script is 4-7.ps1. So here's the script. So what I'm doing is I'm setting a variable called $server, and I'm setting that variable equal to Hyper-V. Hyper-V, as you may recall from some of the other videos, is the name of the Hyper-V server on my network. So I'm just setting up a variable called $server, and I'm assigning it the name of a Hyper-V server. Next, I'm calling a function called get-myVMs, and then I'm passing the server name to that function in the form of the $server variable. So up here in the very first line, you can see that I've got a function, and the function is called get-myVMs. That's the exact same function that I was calling right here. And that function is configured to receive the $server variable. So within that function, I've only got one command that I'm performing. Get-vm -computer name $server. So this retrieves a list of virtual machines off of the specified Hyper-V server. So let's take a look at how this works. I'll go ahead and run the script. And that's what the script does. So I'm assigning the Hyper-V server name to a variable. I'm calling a function and passing that server name to the function, and then I'm retrieving a list of virtual machines off of that server. That's it. I'm not trying to do anything overly complicated here. So what I want to do now is take what I just showed you and turn that into a custom PowerShell command. Now, PowerShell already has a commandlet called get-vm that does exactly this. So I'm really not inventing anything new here. I just want to show you how to create a custom commandlet in PowerShell. So why did I start out by showing you that script that I wrote? Well, as I mentioned in the beginning, the way that we create custom commandlets is by creating a module and then creating commandlets within that module. So when we create a new module, each commandlet takes the form of a function within a script. So every function that we declare becomes a PowerShell commandlet within that module. In this case, my function name is get-myvms, and so get-myvms is going to become a PowerShell commandlet. So with that said, let's go ahead and set up a module based on this function. I'm going to go ahead and close out the script, and I'm going to load another script that I created that is very, very similar to this, but just a little bit different. The function section of the script, these 3 lines right here, haven't changed whatsoever. They're still identical. But I've done away with these 2 lines and I've replaced them with something else. Let me show you. I'll go ahead and close this out. And let me switch back to my scripts folder. And I've got another file here, 4-7.psm1. Now, normally when you create a PowerShell script has an extension of .ps1. But when you're creating a module file has an extension of psm1, the M standing for module. So let me go ahead and open this up and show you what it looks like. So here's my module. As I mentioned a moment ago, these 3 lines of code right here are identical to what you saw before. So nothing there has changed. The only thing that's changed is I got rid of the variable declaration and I got rid of the line that calls the function. And I replaced those lines with this line right here. So I have a commandlet, export module member. So I'm turning this into a module. And I have to tell PowerShell what functions I want to include in the module. So I'm using the -function parameter and then the name of my function, which is get-myvms. So get-myvms is going to be turned into a commandlet within the module that we're creating. So let me go ahead and close this out. Now, when you're creating a module, the location where you store that module matters. So right now, I've just got the module code stored in my scripts folder, and unfortunately, PowerShell can't use it in that location. So we're going to have to move this. So let me go ahead and open up another File Explorer window. And I'm going to go to this PC. I'll go to my C drive, and then Windows, System 32. Windows PowerShell. V1.0. Modules. And this is where all of the modules are stored. Now you'll notice that we have a series of subfolders, but we don't actually have any module files. So we're going to have to create a subfolder in order to store the module file that we're creating. So I'm going to right-click and go to New Folder, and I'm going to call this folder My Module. The folder name needs to match the module name. So I now have a My Module folder. I'll open that up. And now I'm going to copy my script into the module folder. I'll go to my PC, C drive, scripts, and I'll copy 4-7.psm1 over to the My Module folder. And it looks like the file has copied. So let me go ahead and close out some of these windows. And I'll clear the screen. And I'm going to type get-module. And that displays a list of the modules that are currently in memory. So we have 4 of them right now. Now this doesn't mean that these are the only modules that are available to PowerShell. There are many, many others. And the way that we find out what those modules are is by repeating the get module commandlet and then appending the -list available parameter. And if I press enter, we get a list of all of the available modules. And as you can see, there are a lot. So now what we have to do is scroll through the list and locate the module that we just created. And the module isn't listed, but I think I know what happened. Let me go ahead and open up File Explorer. And I'll go to the C drive, Windows, System 32, Windows PowerShell, 1.0 modules, and then I'll locate the folder that I created earlier, the My Module folder. And here it is. And what I did was I misnamed the file inside. I had this file named for the video that I'm creating, 4-7, and in reality, I need to rename this to match the name of the folder. So I'm going to rename this, and I'll call it My Module. I'll press enter, and now let's see if Windows recognizes the module. And here we have My Module. Now, remember when I said that I declared a single function within that module, and incidentally, you can have a lot more than just one function. You can create pretty much as many as you want, but I only declared one just to keep things simple. And I mentioned that that function was going to become a PowerShell commandlet associated with that module. So here you can see that function, get-myvms. So if we import that module, we can actually use get-myvms as a PowerShell commandlet. So let's take a look at what that looks like. Let me go ahead and clear the screen. And what I'm going to do is import the module that I just created. So I'll type import -module, my module. So the module has been imported. And if I type get-module, we can see that my module is indeed imported. You can see it right here. And we can see that PowerShell is aware of the get-myvms commandlet. So let's try running the get-myvms commandlet. I'll type get-myvms. And the get-myvms function requires a server name to be passed to it. So I'm just going to type Hyper-V. That's the name of my Hyper-V server. I'll press enter. And we're able to get the virtual machine information off of that Hyper-V server using a custom commandlet. So that's how you build your own module and you create custom commandlets that can be used in PowerShell.
In PowerShell, you can create a script that does almost anything. You can even build scripts that watch over your network so that you don't have to do it manually. Of course, you need a way to automatically run those scripts and to generate a notification if the script happens to find something that you need to know about. And that's what I show you how to do in this lesson. In Lesson 5, I discuss making a script run automatically, generating alerts from a script, and best practices for PowerShell scripting.
Occasionally, you may find that it's beneficial to be able to make a script run automatically. You might want a script to run at a particular time or perhaps in response to a particular condition. Well, if you need to make a script run automatically, you might take a look at the Windows Task Scheduler. So let's take a look at how to use the Windows Task Scheduler to launch a PowerShell script. So what I'm going to do is click on the Start button, and I'll go to Server Manager. And then from there, I'm going to click on Tools, and then I'm going to click on Task Scheduler. And this is going to open the Windows Task Scheduler. So let's take a look at how to make a PowerShell program run automatically. I'm going to click on Create Basic Task. And this is going to launch the Create Basic Task wizard. And you have to provide a name for the task that you're creating. You can call it anything, but it's a good idea to use something descriptive. So I'm just going to call this lesson 6-1. And you can see that there's also a field that you can use to enter an optional description. I'm not going to worry about a description right now. I'm just going to click Next. And now I'm taken to the trigger screen. And this asks, when do you want the task to start? You can run the task daily, weekly, monthly, one time, when the computer starts, when you log on, or when a specific event is logged. So you've got a lot of different choices right here. So I'm just going to set this to daily. I'll click Next. And so now you're prompted to enter a start time and how often you want the task to reoccur. By default, Windows sets this to every 1 day. So this task will run every day at the time that you specify, unless you choose a different frequency. So I'm just going to go with the defaults and click Next. And so the next screen asks, what do you want the task to perform? We have 3 options here: start a program, send an email, and display a message. So I'm going to go with start a program. I'll click Next. And so now I'm taken to a screen where it prompts me to provide some details about the program that I want to run. Now, I can't just enter the name of a PowerShell script in this box because Task Scheduler won't know what to do with it. So we have to jump through a couple of hoops in order to make this work. Let me show you why this is the case. When you tell the Windows Task Scheduler to run a program, the command line that you use to run that program is something that has to also be able to work from the Windows command prompt. So with that said, let me go ahead and open up a command prompt window. And incidentally, the command prompt is a little bit different from Windows PowerShell. Most of the PowerShell commands won't work in a command prompt environment. The command prompt is more similar to the old DOS environment. So let me make this a little bigger, and let's go back to the task at hand. We're trying to run a PowerShell script from the Windows Task Scheduler. So let me go to my scripts folder. And let's suppose that the script that I want to run is 6-1.ps1. If I were to type /6-1.ps1, that script isn't going to execute because we're in a command prompt environment, not in a PowerShell environment, and the command prompt doesn't know what to do with a PowerShell script. Similarly, I can't just type the file name. If I do that, then what ends up happening is that Notepad opens up the script, and that's not what we want to happen. So what do? Well, here's a hint. Watch what happens if I type PowerShell.exe. If I type PowerShell.exe, I'm actually taken into PowerShell from the command prompt environment. And you'll notice that my prompt changed. Initially, the prompt looked like // Now I have PS // indicating that we've changed from a command line environment into a PowerShell environment. And because we're now working in a PowerShell environment, we're able to run scripts. So I can actually put that to work inside of the Windows Task Scheduler. I can use PowerShell.exe to switch to a PowerShell environment and then run my script. So let me go ahead and show you one more example before we do that. I'm going to go ahead and close this out. And then I'm going to go back into the command prompt environment. And what I'm going to do is I'm going to type, or let me switch to my scripts folder first. I'll type PowerShell.exe. And then I'm going to type /?. And when I do that, I end up getting the PowerShell.exe help. And this shows all of the different parameters that I can use with the PowerShell executable. Now, if we scroll through here, you can see that there's a few different ones. We have -command, -execution policy. Here's the one that I'm interested in, -file. So you can actually specify a file to run. So here's how this works. I can type PowerShell.exe-file 6-1.ps1. I'll press enter, and my script runs. So now that I've shown you how to launch a script in that way, let me go ahead and close out this window, and we'll go back to the Windows Task Scheduler. So now I come to the screen where I'm asked to enter information about the program that I want to run. So for the program field, I'm going to type PowerShell.exe. Then I need to add that file parameter that I showed you a moment ago. And the place where I add that is beneath the program field where you see add argument. So I'll type -file /scripts /6-1.ps1. And then I'm going to append another parameter called noExit. And this will prevent PowerShell from closing so that you can actually see what's going on. So I'll click Next and click Finish. And the task is created. You can see it right here. And I'll go ahead and click on Run. And you can see that my task is running. So we can validate that the Windows Task Manager is set up correctly, and this task will now run on a scheduled basis. So that's how you run a PowerShell script automatically in Windows. Hello and welcome back. Sometimes you may end up writing a PowerShell script and you need for that PowerShell script to generate some sort of notification. Maybe a particular condition was met and you want to be alerted to that condition. Well, when it comes to notifications, you have a lot of options. So my purpose in this video is to show you a few different ways that you can generate notifications in PowerShell. So let's go ahead and get started. Now, for a long time, my preferred way of generating a notification in PowerShell was to have the script to send me an email message if whatever it was that I wanted to be notified about happened. And PowerShell actually has a built-in commandlet that can make that happen. It's called send mail message. And you can just type that out by typing send -mail message. And there are a number of different parameters that go along with that, such as the sender, the recipient email address, and that sort of thing. But there's a problem with using this particular commandlet. Let me show you. I'm going to open up a web browser. And I'll go to a search engine, and I'll type PowerShell, and then send -mail message. And so here we have the Microsoft documentation for the send mail message commandlet. And initially, this looks exactly like the documentation that you would see for any other PowerShell commandlet that Microsoft provides. But let's scroll down just a little bit. And right here, we have this big old warning message. And I know the typeface is a little bit small, but what it says is the send mail message commandlet is obsolete. The commandlet does not guarantee secure connections to SMTP servers. While there is no immediate replacement available in PowerShell, we recommend that you do not use send-mail message. For more information, see Platform Compatibility Note DE0005. So in other words, Microsoft is saying that this particular commandlet shouldn't be used because it's not secure and because it's obsolete, but unfortunately there's nothing to replace it. Now, having said that, there are third-party solutions that you could use if you wanted to make your script send an email message. And if you were feeling brave, you could still use send mail message. And if you're wanting to do that, I would recommend that you go and visit this page. And this page provides the full command syntax. And you can even see some examples right here of how this commandlet works. In this example, for example, we have send-mail message, and then we have the from parameter, and then the email address of the user who is sending the mail message, and then the to parameter, and the destination email address, and then -subject, and then a subject line. And as you can see, you can even send an attachment if you want. You can send a message to a mailing list. So there's all sorts of things that you can do with the send mail message commandlet. Now, because Microsoft discourages using this particular commandlet, I'm not going to be including it as a part of this course, but I wanted you to at least be aware of the existence of this commandlet in case you need it and decide that you want to use it. Just keep in mind that Microsoft strongly recommends not using this particular commandlet. So with that said, let me go ahead and close this out. And I want to show you some alternative techniques that you can use to get a notification in PowerShell. Now, one technique that's sometimes used, and I'm personally not a big fan of this one, but one technique that some people use is to simply make the console beep. And the way that you do that is by typing bracket, console, bracket, colon, colon, and anytime that you see a word in brackets like that followed by 2 colons, that's an indication that you're delving into .NET. So then you would type beep, and then open parentheses, and we need to supply a couple of numbers. The beep pitch and duration. So I'm just going to use 2000, comma, 1000, and I'll press enter. And it just occurred to me that the sound probably didn't come through because I don't have sound enabled in this particular virtual machine that I'm using for the video. So I'm going to do something a little bit out of the ordinary. I'm going to open up a PowerShell window on my local computer, not in the Windows Server virtual machine. So here you can see a window off of my local computer, and let's try that same command again. And I'll press enter. And hopefully that time you heard the beep. So let me go ahead and close out my local PowerShell window. And I will clear the screen. Okay, so there's another technique that you can use to get someone's attention using PowerShell. And that technique involves creating a pop-up message. Now you could manually construct a pop-up message application using PowerShell and forms and that sort of thing. And certainly I've seen that done, but there is an easier way of doing that. And there are actually two different ways that you can arrive at the same end result. And I'll show you both techniques because both of them are fairly easy. So what I'm going to do is I'm going to create a variable called $user. And I'm going to set that equal to my username, which I'm logged in as administrator right now. So I'll set this to administrator. And incidentally, this does have to be a real username. You can't just type a random value and expect it to work. I'll go ahead and press enter. Next, I'm going to create another variable. I'll call this one message. So $message. And I'll set my message equal to PowerShell needs to get your attention. So we've created two variables. We have $user, and that's equal to administrator. And then we have $message, and that's equal to PowerShell needs to get your attention. Now, the way that we turn this into a pop-up notification is by using a command called MSG. Now, MSG isn't a PowerShell commandlet. It's actually part of Windows, but you can access it through PowerShell. So because this is something that's built into the operating system, I wanted to go ahead and include it here. So the way that you use MSG is to simply type a space and then $user, and then another space and $message. And when I press enter, we get a pop-up. And you can see that the pop-up says PowerShell needs to get your attention. And take a look at the window title. We have message from administrator, and then we have the date and time. So PowerShell is actually conveying who it was that sent the message that appeared in the pop-up. And then to get rid of this, I simply click OK. Now, I mentioned that there were two different ways to get the same result. I'll go ahead and clear the screen, and I'll show you the other method. The second method is to use .NET. Now, personally, I prefer the MSG command because I think the output looks a little bit nicer, and because you don't have to add a .NET assembly in order to make it work. But I wanted to go ahead and show you the .NET-based technique. So the first thing that we have to do is to add an assembly. So I'm going to type add type, and then I'll type -assembly name, followed by presentation framework. So we've added the necessary type. Now what we do is we type bracket system.windows .message box bracket :: show open parentheses apostrophe PowerShell needs to get your attention apostrophe close parentheses. And I'll press enter, and we see a pop-up box that was similar to what you saw earlier. Now, I mentioned that I preferred the look of the other pop-up box a little bit better, and the reason for that is that the other pop-up box had a title bar that showed who sent the message and the date and time. This one doesn't have that. If you look, all we have is the message and then an OK button that you can use to clear the message. I'll go ahead and click OK, and then clear the screen. And so those are just a couple of options for generating notifications in PowerShell. Hello and welcome back. In this video, I want to do things a little bit different than what we've been doing throughout the rest of this course. Pretty much every other video in the entire course is going to be designed to teach you a new PowerShell commandlet or teach you some new scripting technique or something like that. This video is different in that I'm not focusing so much on a scripting technique or a commandlet as much as that I wanted to just kind of take a time out and teach you a few best practices for PowerShell scripting. So let's go ahead and get started. Now, in preparation for this video, I've created a really simple script. And the name of the script is 6-3.ps1. I'll go ahead and run the script. So as you can see, the script simply retrieves a list of virtual machine names. That's all it does. It's really simple. But as I said a moment ago, I constructed this script more for the purposes of showing you some PowerShell best practices rather than doing anything useful. So in just a second, I will open up the script, but before I do, I just want to say up front that even though this particular script is designed to teach you some PowerShell best practices, I will openly admit that I violate pretty much every single one of these best practices at some point in this course. A lot of these best practices I violate almost constantly in every lesson. Now, why is that? Well, there are a few different reasons. One, best practices aren't absolute. There are times and places for everything. Sometimes it just doesn't make sense to adhere to some of these best practices. Another reason why some of my videos violate some of the best practices that I'm about to show you is simply because I'm trying to teach you something that goes against the best practices as a way of showing you a better way of doing things. But then the biggest reason why some of the scripts that I'm going to be using throughout this course violate some of the best practices that I'm about to show you is just because these scripts aren't intended for use in production environments. Some of what I'm going to be showing you really only makes sense to use in production environments and in longer scripts. And if you've got a really short script that only requires a few lines of code, sometimes it just makes a lot more sense to just do it rather than to pay attention to all of the best practices, especially if that script is never going to be used in a production environment. So having said that, let's go ahead and open up the script. And the script is 6.3. So here's the script. And the very first thing that you'll probably notice in the script is a block of comments up at the top. And I used these comments to show when the script was created, who it was created by, when was the last time that the script was updated, and why the script was written. What does it do? So the idea being that if you've got a PowerShell script that you're using in a production environment, it's a really good idea to start with some documentation. Because even though maybe you know what the script does and why it was created and who it was created by and all that, there's a good chance that the script is going to be around for a while. And that maybe eventually you'll move on either to another job at another company, or you might get a promotion or something like that. And eventually somebody else is going to inherit this script. And it's a good idea to be able to help them out and just show them where the script came from, why it was created, and what it does. So that's just one best practice. In a production environment, start off with some documentation explaining what the script does and where it came from. So let's move on. So the next thing that I have in the script is a function. And you can see the function starts right here. Now, technically in PowerShell, anytime you declare a function, that function declaration starts with the word function followed by a function name. The line that you see right here, highlighted in blue, is just a comment line. And the reason why this line exists is because I found that a lot of times, if I'm creating a really lengthy script, all of the functions can kind of blur together. So sometimes I found that creating lines like this make it a lot easier to tell where a function starts and where it ends, and where the next function starts and where it ends. So you don't absolutely have to have these comment lines, especially in a shorter script, but if you're writing something really long, it can be helpful to have comment lines that make it really obvious where functions begin and end. It can make debugging a script a whole lot easier. Now, the next best practice that I want to talk about is just the existence of a function here. Because as a best practice, if you're writing something elaborate, it's a good idea to take any major blocks of functionality and commit those to a function. So that way you only have to write the code once, you only have to debug the code once, and the input and output for that function is absolutely predictable. So you know what that function is going to do and how it's going to behave every time it's called. It's an easy way of reusing code, and it's a way of simplifying the main body of your script. If you're pulling out all of the major blocks of functionality and placing those into functions, then that by definition is going to simplify your main body of your script. Now, again, if you've got a really short script, it may not make sense to break things out into functions. Sometimes it's easier to just do whatever needs to be done and not even worry about functions. But if you're writing something long and complex, then I would absolutely recommend using functions. Now, another best practice that I wanted to point out is the function name. Now, you'll notice that the function name in this case is get-myvms. You can see it right here highlighted in blue. And this sort of kind of mimics a PowerShell commandlet. You'll notice that I've adhered to the verb-noun naming convention that PowerShell commandlets use. Now, again, you don't have to do that. You can call your functions anything that you want, as long as you're not using a reserved word that PowerShell is reserving for something else. But the reason why I recommend naming your functions in a way that mimics PowerShell commandlets is because, as I'm going to be talking about in one of the videos in this series, it's actually possible to take a function and turn that into a standalone commandlet through the use of modules. And you never know when a function might prove to be a lot more useful than you originally envisioned, and you may want to break that out into its own module so that you can use that function outside of the script that it was originally intended for use in. And so when you do that, it makes a lot of sense to have a function that has a name that's a lot like a PowerShell commandlet, because really that's how you're using functions. You're using them almost like PowerShell commandlets. If I go down to my main body, you can see that right here I have get-myvms, and I'm passing the server variable to that function. And this looks a lot like a native PowerShell commandlet, but in reality, I'm simply calling a function. So give your functions meaningful names. That's the best practice. As I said, I like to give functions names that sort of mimic PowerShell commandlet structures. But even if you choose not to do that, just give your functions meaningful names. And that leads me to the next point. You'll notice that I've got a section right here. I'm making it really obvious where my script body starts. And I'm also placing a good amount of white space in between my function and my script body. And if I had multiple functions, I would recommend placing a lot of white space between those functions. Because again, it just makes the script easier to debug if you can tell where one function ends and the next one begins. At any rate, let me scroll down to my script body. And you'll notice that the very first thing that I have is a comment that says variables. And then within that comment, I'm setting a couple of variables equal to null. Now, you absolutely do not have to do this, because when you open up a new PowerShell session, there are no variables defined. Nothing is going to be left over from a previous session or anything like that. The only reason why I'm doing this is because starting out by declaring some variables and setting those variables to null gives me the opportunity to append comments to those variables. You can see right here that we have a variable declaration followed immediately by a comment. Just beneath that, I have another variable declaration followed by a comment. So if you're just writing a PowerShell script and you're arranging the logic so that each line occurs as it's needed, your variable declarations are going to be scattered all over the place within the script, which again, in the case of something short, that's totally fine. But the reason why I'm initializing these variables with null values is it gives me a chance to define all of my variables up front and in one place. So I recommend, if you're going to do that, use meaningful variable names and add comments, just like what I've done here, that describe in detail what that variable is going to be used for. Because again, this is going to make it a whole lot easier for somebody to come in behind you and figure out what in the world the script does, because you've given them a meaningful description of what all of these variables do. And that's a huge part of understanding a script's overall functionality. And so then, once we get past the variable declaration section, you can see that I've got yet another comment. Script logic begins here. And then I'm not really doing anything fancy in my main script body. I'm just declaring a variable. And you can see that this is the same variable, $server, that I initially set to a null value up here. The only difference is that here I'm setting it to whatever value the script actually needs in order to do what it's supposed to do. And then I've got a function call beneath that. But the point being that as you're writing a PowerShell script, it's a really good idea, if there's any chance at all that somebody else is going to have to use the script or make modifications to it at some point along the way, use meaningful variable names, use meaningful function names, and make generous use of comments, so that way it'll be really easy for somebody to come in behind you and figure out what the script does and how it works. So those are just a few best practices. You're free to use them or not use them. These are just some things that I recommend for use with complex scripts in production environments.